la limite, tu vois, c'est de faire d'un mètre, c'est un peu plus facile. Même si je suis jusqu'à là.
welcome everybody. It's a great pleasure to see you in Patras. This is the first meeting that we organize after 2 years. So it's a big kind of moment that for us that things are slowly but steadily returning back to normal. I will spend just a few minutes to introduce you to the city and the place before I give the floor to Sophie. So Patra is the third biggest city in Greece, but it is only 300,000. We are kind of to the northeast of the city. The main city is something like 10 kilometers from us. If you get the time, the places to visit are first the Cathedral of St. Andrew. Patrice guarantees that it brings good luck to your soccer team. There is a castle, actually you can see it in the picture here, from the Roman times. And there is also a good archaeological museum. Just a little about the history of the place. It's 4,000 years old. Unfortunately, it peaked 3,000 years ago. That was the best time of Patras. So this is a map of ancient Greece. The area around here is called Achaia. And in Homer, the Greeks that attacked Troy were called Achaeans. So this was one of the top places in the times of Homer. Its major characteristics is that it is the major port of Greece to Italy, and it's one of the few flat places that we have, so there is a lot of agriculture around. It has a lot of connections to Italy. I mean, it was not only during the Roman times, but it was also part of Venice. So if you go down, you will see that our theater, for example, is a copy of the Italian ones. And our best time was that 200 years ago, the Greek Revolution against the Ottomans started in this area. A little about Forth, the organization that we are participating in. So it's the research organization of Greece that has institutes in the periphery. The others are in Athens and Thessaloniki. Most of the institutes are in Crete. There are 6 there, and in Patras there is the Chemical Engineering Institute that you will see in the afternoon, and there is a biomedical one in the northwest. Right now we are in the University of Patras. Forth and the university are 2 different organizations. My actual job is in the university, and it is relatively young. It's 55 years old. It started with engineering, science, and medicine. Now it has education, humanities, business, and agriculture. Something like 25,000 students. It's a big area, so if you like walking after lunch, etc., there are a lot of places to see. Last, a little about our group. We are in the Center for the Study of Air Quality and Climate Change, located in Forth. You have met Thanos Nenes, my colleague, who is actually watching from Skype. He's actually right now in EPFL in Switzerland. And there is Maria Kanakidou, who is our global modeler in the University of Crete. There are 45 persons in the group, and half of us do experiments, half of us do modeling. If you need help, there are 2 more Marias. There is Mary Sipsa, who is my assistant. She will be helping during lunch and the afternoon. And there is Maria Georgopoulou. Maria, who is our PhD student working in Remedia. If you need local help, she can provide it. Sophie? The general one?
Yep. Thanks a lot, Spiros. Thanks a lot first for hosting us. That's a real great opportunity, sure, to be here together live, since it's been 2 years now from now that we last met, and hopefully we will be able to meet for real a little bit more in the coming years of Remedia, the 3 last years of Remedia. I really thank Spiros for helping us, and Marie, of course, for helping us organizing this meeting, since I don't know if how many meetings you've organized since COVID, but
That's the first.
yeah, so it's back to normal, hopefully. But that's really nice of you to host us, and I really wanted to say that first. What I'm going to do here is, well, first of all, to welcome you all, including those online. I don't know how many participants we've got online, but I know we've got quite a few. And what I would like to share with you is a little update of the last year for Remedia. But first of all, I'm going to show you a few slides, remind you of the project for those the new ones, since I don't know everybody, I don't recognize everybody, so I guess that there's new people in the project. So, first of all, the issue in question, that's exposome. This is really not a new, well, that's a new word for a very old concept, since Hippocrates has already said that if you want to take care of a patient, you've got not only to think of his disease, but also his environment, what he eats, which air he breathes, and which water he drinks. And so this is something really not new, the exposome, except that the term exposome has been first said in 2005 by Christopher Wilde, and he was explaining that exposome is the life course environmental exposures, including lifestyle factors, from perinatal period onwards, so all what you're exposed to. And in 2014, Gary Miller added the notion of the associated biological responses throughout lifespan. So it's now really something really complex when you think of exposome, with external components of the exposome, but also internal, and the genetic factors that's not always included in the definition of exposome, but it's really all what you are exposed through your life. The other issues in questions are the 2 pathologies of interest. So there's on one side COPD, or chronic obstructive pulmonary disease, which is an acquired multifactorial disorder with cigarette smoking as the main risk factor, so typically external exposome. This is characterized by there's a progressive decline of lung function and with the presence of recurrent exacerbations. The other disease of interest is cystic fibrosis, or CF, which is the most frequent genetic disease, rare genetic disease, so which is characterized by a loss of function and mutation in the CFTR gene. So it's inherited, of course, since you're born with it, and it's also characterized by progressive lung disease and decline of lung function and recurrent exacerbation. But given that it's a genetic disease, it can be considered as maybe outside the exposome finally, because it's not a real component of the exposome. But what was interesting for us is that both diseases are characterized by a high phenotypic variability of unknown origin. So this is really where we want to go there, is to try to understand this phenotypic variability and how exposome could take a part of that. So there are three major questions in Remedia. It's about how are the specific exposome or exposomes associated with particular COPD or CF phenotypes in terms of severity, mobility, exacerbation, comorbidities. How do similar exposomes can impact COPD and CF? Are they the same or different, or parts are the same or not? And another major issue and question is if there are specific exposome linked to lung function trajectories and maximal achieved lung function at early adulthood. Because this is something which is understood now, is that at early adulthood, when you're 20, 25, you've got your maximal achieved lung function. However, before 20, 30 years from now, we were believing that this maximum was the same for all of us. But actually, this is not the case. And this maximum can be different depending on what happened in your early life. So this is what we call the lung trajectories, and all what can impact these trajectories is really important, and that's something that we would like to focus on in Remedia. Well, we are focusing on in Remedia, actually. So with Remedia, the overall aim is to go from the graph on the left side, which is a hectic relationship between exposome and disease phenotype, and to go to the right side where there's a much better view of this relationship that can exist between exposome components and disease phenotype. So right now we are approximately in the middle, or maybe a little bit too much on the left, where we don't know yet, but hopefully in the coming years the line will begin to draw better. So to reach our aims, we've got a general approach which is in three parts. First, there's data integration, with data collection, enrichment, creation of database. I won't say it's unified. There's internal exposome analysis with lipidemic, epigenetic, and exposome phenotype association. So this is typically the aim of WP2. That's Etienne and Ralph will present after. Then there's a part which is experimental work, which is dedicated on one part to the development of sensors, biomarkers and environmental ones, which is the work of WP3. And another experimental part, which is the simulation of realistic atmospheres and realistic exposome, which is the job of WP4. And then the last part of the general approach is the computational analysis with machine learning analysis, cost-effectiveness models, and altogether the evaluation of effects and legal impacts. And that's the job of WP5 and 4. And so here we are with the 13 members of the consortium. I said new consortium because that's a slide I showed you already in the last consortium meeting in May, where we at first we had a UK partner, CEGX, who was supposed to perform the epigenetics analysis, but the partner decided to Brexit, to do its own Brexit, so no more epigenetic partner. But during the year, we have a lot of discussion to integrate a new partner, and this is now Stéphane Jamin. So this is the new concession with Stefan. We will have still to vote on the EC to accept it, but it's really on the good tracks. So this year we also had some changes in human resources for the project. We had changed our project officer because of internal restructuration of the different program at the European Commission. So now this is Maria Asperoa, who's our project officer, and we had a few discussions with her. Those who were attending the review report saw her also. And she's very active and very helpful. She's got the EC rules, so but she's really helpful. Second change is also the change of our scientific project manager in the management team, who's working with me. So for those who know Manon, who was there until May, she had left for another job, and now this is Roberta who's there. And I guess that many of you have seen her already. She arrived just in September, and she's now full gear for Remedia. Sorry. Another change that I've already told you that is about the epigenetic partner because of the departure of CEGX. So now Stéphane Jamin from INSERM is here. And we also have 2 new scientific advisory board members who just signed their confidentiality agreement. This is Marie-Aline Catillon. She's an associate researcher at the Computational Health Informatics program at Harvard. And Jeff Holworth, who's the head of strategic research of the Sustainable Health Unit at the Flemish Institute of Technological Research in Belgium. So both of them will join our 2 already SAB members. So this year has been also punctuated by the first reporting period, which ended in June 2021. Sorry. So thank you all for the great job you did during the holiday period, because we had to write and to send the report to the EC by the end of August. So July and August have been quite intense for the project. And at the end of September, we've been reviewed by an external panel of experts. We had, plus the EC members, of course, but we had 3 members in the review panel, 1 epidemiologist, 1 atmosphere chemistry, and 1 person from with ethics background. We had a 4 hours review meeting, which was quite intense. We've been challenged on a few points. And they sent us then our conclusions, and from out of them there was the need for new SAB members. So this we've been already active for that. The need for a CEGX replacement, that's also the case. So this is okay. They challenged us about the need for a backup plan for the unified database. So Etienne will talk to you about that afterwards. And 2 points that we still have to work on and hard is the need for publications. As right now they told us that the project is mainly aspirational, which is quite true, but we now have to be really effective in publication. We have 1 publication for Remedia, the profile paper, which has been published in September. But we really need now to write original papers from our research. This is really, really important. And also another point that I hope that this live meeting will help with is the need for more interrelation between work packages. Well, I'm pretty sure that inside each work package we discuss a lot, we see each other even if it's virtually and that's okay. But now we really need to change gear and to work together and to discuss outside work packages to build something really efficient for Remedia. We had, with all the PIs from the different partners, I don't remember how many calls we had for that, but quite a few about budget reallocation, because CGX departure, they had an allocated budget, and with a choice of including Stéphane to perform the epigenetics, because we have a discussion with Fraunhofer group also, but finally Stéphane was chosen. But or thanks to, I don't know, but the budget wasn't as high as what CGX was asking at first. So not to lose the budget, because EC has given us an entire budget, and if we are able to show them that we need this extra budget, they will give it to us. So this is not a problem. But we have to really be efficient in our and convincing in our discussion. So between the different partners and work packages, we have a common discussion and thoughts. And I won't go into the details of euros there, and maybe in the different work packages you will present that. But the philosophy back there was to, for WP2, to reinforce the omics analysis that were initially planned, by increasing the number of subjects or samples that are to be analyzed, and also to add new genomic analysis, which will really improve the quality of our data. For WP3, the objective was to increase also the overall number of analyses that can be performed, plus the duration of them. So, meaning to increase the number of environmental and biomarker sensors. For WP4, we are willing to add in vitro testing mechanistic studies, which was actually largely proposed and asked for by the review panel. So we'll add that. WP5 is asking for additional budget for publication fees that were not anticipated. And here's Ariel, I guess. WP5, Ariel. With no mask, Ariel. Thank you. And then WP7, the objective of the new budget is to reinforce the overall communication and dissemination abilities, bringing expert assistance on communication activities, policy-related activities, and also be able to perform specific communication and have policy tools and activities. So that was the general philosophy. We still have to sign the final vote, but maybe Christina will talk to us about that later. But and I really think that with all this new allocated budget, if the European Commission is okay, it will be fine, and it will really bring something better and add real something to the project. So now, and I'm going to finish with these ideas, is what are the objectives of this meeting? So, first of all, what will be provided? Well, of course, individual work package review, annual, because at management team, we organize monthly meetings with all work package leaders to follow over the different new events in the project, but so that with this individual review, you will all be able to see what has been achieved, the individual work package perspectives for next year's and others, and also the need from others, intra or extra work package. And I put an accent on extra work package, since it's really the opportunity here to ask for discussion with people from other work packages. So what is needed from you, and I really want to be very emphatic on that, is to discuss, to exchange, communicate, whatever for you to bring discussion. It's really the opportunity here. We're not online, we are live, and that's the first time since the beginning of the project, actually. So this is really important that you take time and you push yourself to discuss with each other. With that in mind, we've organized, I don't know if it's not really visible, but an agenda where, of course, the individual work packages have this special time to present their achievements of the year, but also we've put slots of discussion beside the coffee breaks and lunch, of course, but and we've got, for example, Pascal Matisse, who will present a bibliographic review of what's known on the exposome and the two diseases of interest. It's really to open people's mind and to be able to discuss. And tomorrow we will have dedicated breakout session for WP3 on one part and WP256 on other parts, again to discuss. So this is really, really important. I guess Christina will give us the technical thing of for tonight, the dinner and so on. So I won't go into the detail, but mainly today and tomorrow we're here, except for tonight we are at 4th. And so, yeah. Again, the overall aim of these 2 days are to build together, I really insist in together, and to go beyond the intra-work package work, so that Remedia can change gear really and to really work together, and with also all the other work packages. So WP1, that's the management work package, 7 is dissemination, 8, this is the EHE and the European Human Exposome Network, which we don't talk that much, but we should, since it's the work package that has been added at the end of the, when we were granted with the project, and that's a discussion with all 9 projects that have been funded by EC with this scope. So, and EC is putting a really big effort on this network, so that's quite important. So with that, we'll finish. And well, I'm here for questions, obviously, but otherwise I will give the floor to Etienne, I believe. Yeah. Non, c'est toi. Ah oui, sorry, so to Christina. Sorry. Donc, pour la peine, je te mets ton truc. Et après, c'est dingue, en fait. Ah oui, d'accord. Oh là. Am I okay? Or yeah, I could. My
We don't pay attention.
Thank you. Welcome. So just one word. Outside is the list with the attendance list. So you all need to sign. This is very important, not only for me, so that I can prove that you have been here, but also for you, because it's very likely that you will have an audit, maybe by an internal auditor, but also if you have the chance to have an audit by the European Commission. This can always happen. And then they will ask for proofs that you actually have been here. So I will scan and archive the attendance list, so it will be available for you up to 10 years after the project on our server. And also it's photos, you will take photos, because we just have that case that one of the European, another project, European member is audited, and they are really asking for boarding passes, for the minutes of the meeting, for photos, everything. So it's really important to have proofs that we've been here. Then you probably already grabbed your, what's it called in English, writing pen, stylo, writing pen. We also have USB sticks. So before we go out to lunch, I will be at the port and giving you a USB stick per person. Then for the PIs, it would be good if you take one box of the, how it's called in English, carte de visite, the presentation cards, thank you. A box of the presentation cards, so that you can distribute them when you go to conferences that hopefully will also start again in presence very soon. What else? I think this was it. So then I go to WP1. So the objectives for the second period, which started in July last year. Okay. Well, later. Normally should be online already via the YouTube stream. So the objectives for the second period were to organize a consortium meeting in person. So very thankful to be here that it really happened today. Do the transfer for the first interim payment that we received after the validation of the reporting, and of course continue the monitoring of all of the work packages. No, it's not moving. So for the task 1, I don't know if you remember, after the first periodic reporting, we actually had quite a lot of questions, which took a lot of time to answer. To be very honest, I was a bit astonished. I am used to having a lot of questions on the financial part of the reporting, but actually we only had 2 questions on the financial part, and all the rest was on the technical part. We think this is because the new project officer took very literally the C template, but also from what I understand, also from other projects that we have at INSEM Transfers, that with the change to the new agency, the project officers have a lot more projects to monitor actually. So what they want to have is a report where they don't need to have the description of action next to it. They want to have all the info they need in order to understand if we're really on track in the report itself. So this to me means that for the next reporting we will do, because the current periodic period will end of December, so we need to submit the next reporting at the end of February 23. I will change a bit the templates in order to anticipate as much as possible all those questions that we've had this time, because all of those questions, of course, delay the validation of the report and the receiving of the payment from the European Commission. This time we also had the review meeting at the same time as we had the reporting actually. And again, I was a bit astonished, because it's usual that the reviewers have some questions, recommendations on which we have to answer. Normally you do this in a separate letter. This time she wanted us to include us directly into the report, so this is also why it took a bit longer. But what we have to in mind is also for the next reporting, we have to integrate a paragraph where we reply how did we implement the recommendations that we've had from the reviewers. We need to show that we really applied. So we already started, because one of the critics was that we do not have enough members on the Scientific Advisory Board. So as Sophie said, we just recruited 2 new ones. And I have a slide on that also in a couple of minutes. Then the other point, which is still ongoing, is the CSX withdrawal, because officially they're still in the project. We didn't do the amendment yet, because we first need to know how to allocate the spare budget. And the first step that we did is we had an informal call with our project officer, because it's not automatic that we can keep the money. So we wanted to be sure that if we can justify that we can ameliorate the outcome of the project with this budget, it would be fine. Otherwise, it would not be possible just to use this budget to already finance stuff which is already financed by the general budget. So we really need to add something new and show that we reply with this money to the critics of the reviewers. But the PO, Nerea, was fine with it, under the condition that we can really good justify it. Then for the project monitoring, we have the monthly executive committee lunch calls that are still ongoing. I don't send around regularly, I think, the minutes of those calls, but you have all access to them. For each call, there's a folder in the meeting section on the extranet where we put all the presentations and the minutes. Then for the administrative financial support, the distribution of the interim payment, the organization of the Patras meeting, where we had also a lot of local help. This was very good. Then we had one General Assembly vote organized, which was the replacement of CEGIX by INSERM for the epigenetics tasks. And we have, as Sophie already told you, started with the discussion with the work package leaders on how to use the spare budget of CEGIX. The first draft that we received exceeded the spare budget that we had, which was a bit complicated then to manage. But finally, after some discussions and new drafts, I'm very happy to say that now everything fits within the budget we have. So this is the proposals that Sophie already explained to you. So for the budget part, so if you remember well, CEGX budget was roughly 1,036,000, I won't say all the numbers, and INSERM needs for the 1,000 samples that CEGX was supposed to analyze roughly 459,000. This means that we have a spare budget of roughly 577,000. So WP2 would like to have 189.98, 98, yeah. WP3 75, WP4 182, WP7 115, and WP5 roughly 5,000. There's still a difference of 22 euros, I know that, I've noticed, but I will squeeze that out somewhere, I'm pretty sure. So we're going to organize the General Assembly hopefully next week, when I'll be back in Paris. So the idea is that each work package leader sent us actually a template where they explained what was foreseen in the DOE and what they would like to add and what this addition would bring to the work package and to the project, what would it ameliorate and how much does it cost. This is important because every one of you who is going to vote needs to understand what each work package is suggesting. But we also will need this in order to go back to our project officer in order to justify as well why and how are we going to use this money. So the idea is to have a package vote. So the persons of you who are authorized to vote will receive all those documents from each work package. It's 1 page per work package approximately. And this table in order to have an overview of the costs, and then the idea is to vote yes or no. Because this is otherwise if we could vote for each work package proposal, but this was really this is too complex actually. So the idea is to have a package vote. So then the next step after hopefully it will be accepted would be to contact again our project officer, send her the justification that we already have in order to know whether this is okay for her or whether she has more questions, which is actually quite likely, I think. And then start preparing the justification letter for the amendment request with what we already have from the work package as justification and possibly with the other questions that she will have. And in parallel, open the amendment platform, prepare the amendment, which means we have to rewrite or modify the DOA. Each work package has to be adapted according to the proposal. The person months probably have to be adapted depending on the WP, and to the budget shifts for the partners on the EU platform. So this will take a couple of months, because it's work for the project management team, but then also the European Commission always takes quite a lot of time to go back and reply to us. So I think this will not be able to have validated before summer, probably more around September. But maybe it's quicker, but from my feeling, I think it will unfortunately take a couple of months. Then just a short word on our scientific advisory board. So we have Per Bakker and Gerard Lasfarge, who we already know. And as Sophie said, we just recruited Maria Lien and Jeff Hoibergs. We did not invite them today for various reasons. So first, Maria Lien and Jeff just signed actually a couple of weeks ago. Then I was personally, I'm an optimistic person, but I was really fearing that we will not be able to come together, so I'm very happy it worked. But the other thing is, people who are on the ACAB in general have a very busy agenda. Coming to Patras is it's 1 day of travel, and those people do not, they work for free for us actually. So they would lose quite a lot of time in traveling. So in general, by experience, SAB members prefer to come to a place where they can fly in, fly out on the same day in order not to lose a lot of their working time. So we will definitely invite them to another meeting. But what I suggested to Sophie and Roberta is, in the meantime, we can organize an online SAB meeting with the ExCom, maybe 2 or 3 hours, where the work package leaders will present their work that has to be done and the work that has been done so far, in order to get a feedback from the SAB members. This is also something that we have to report upon in the next report, that we actually ask for feedback and recommendations also from our SAB. Then meetings to come, while we continue with the monthly executive committee calls, and we also would like to suggest to have a physical executive committee meeting still in 22, before the end of the year. Normally in the DOA we were planning to have a physical physical executive committee meetings every 6 months. So maybe around September, October would be a good time. So this is to be discussed at the next executive committee call. Then hurdles and pitfalls. Well, the Liefersicht is a lot of work actually, and a lot of modifications. But actually I think we can also see it as an opportunity, because we have a bit more money and we'll be able to add some nice things in almost all of the work packages. And then the decisions and actions to be taken within the next 3 months is prepare the vote on the General Assembly, and then of course go ahead with the amendment and hopefully get the validation in the next months. And I think this was my last slide. If you have any questions, then just for the householding, I think. So we have a coffee break at 11 o'clock, which is outside, I guess. Lunch would also be outside, I think, in the same room. Then tonight, I have looked it up. I think it's possible, if you want to have a walk, you can walk to the fourth laboratory. Otherwise, we will have to organize with the cars that we have.
It's better to go for the latter.
For the car?
Walk uphill.
Ah, okay. Well, there's 40 persons, I don't know. And then, or we can call a taxi if it's necessary, of course. And then from the fourth laboratory back to the hotels, we have to gear up between us with the cars, or call a taxi as well. Because I think from fourth to the hotels it's a bit far, I think. Okay, then next should be, okay. Should be Dan, who just called, so I will call him back. Hi Dan. Can you hear us actually?
No.
Can you hear us, Dan?
Can you hear me?
Yes. Does he hear us?
I don't know.
Can you hear me? Hello, everyone.
You can hear us.
Ah.
There is lag.
I don't know why.
Yeah. So maybe he's hearing us actually. Just... Ah, okay. No.
Not helping, I think. If he can share his screen.
We'll see. In worst case, I have the slides here.
Okay, okay.
Okay.
Screen? No.
Here.
Oh, is she calling you?
Probably.
Hi, Christina. I'm seeing myself 1 minute later, so it's impossible to do the presentation.
Okay. Okay, well, I only
Wait,
did the slides yesterday, so I'll try my best.
If not, you can just not do it now, and maybe we can have like an online meeting with Consortium, with the management team or something like that.
Yeah, well, I can just quickly go through them. I think I just had a quick look yesterday and
We have
I
no
think I
delay.
got... What happens? Okay. Okay. True, me too. Okay, thank you. See you, bye. Okay, sorry. So here, I'll try my best. I just had a look at them yesterday because I thought it would work. These are the slides from from Dan, our ethic advisor, external ethic advisor. So if you remember well, we actually had quite a lot of ethic deliverables that have been submitted already. He actually went through there was the ethic reports which have been annexed to the periodic report as well. So we just did a list of the different, he was also at the review meeting. Then after the review meeting, as Sophie said, there was one reviewer from the European Commission who was also an ethics expert. And actually what happened is that most of the ethic deliverables, it was written as a requirement that we have to have permissions, authorizations at hand, but actually the deliverable did not say that we have to submit them. Then what happened is that the ethic reviewer from the European Commission wanted to have them all. So this is why actually all of the ethic deliverables have been rejected again, and we had to start get all the documentation together, and then also there were some questions, so we had to give a bit more details and more update.
Yeah, and Christina, they also said us that there will be an ethic review.
Yeah.
That we have to submit all the documents.
Yeah, so the idea why they wanted to have now all the ethical authorizations, all the paperwork ready, is that probably this year, we don't know when, but probably this year there will also be an ethics review. And so they wanted to anticipate this in order to have all the documents ready, because once the ethics review actually will be announced, generally it's like a couple of weeks before, and then you start looking for the documentation just a couple of weeks before the review meeting. It's a bit tricky. So now we actually have everything which was already available. There's still some ethic authorizations that were pending when we resubmitted those deliverables, but normally we should be more or less fine. Up to 90% we have everything on board at the moment. So yeah, done. So we don't know when the review meeting will happen, but I guess really it will be this year. So these were the ethic requirements, and the ones in yellow have been submitted but not approved yet, and the 2 in green, they actually have been submitted and approved already, but as far as I know, even if they have been approved, they can still be rejected afterwards, normally. And then there will be 3 still upcoming later on in the project. The next one is only in month 45. And Dan still had some open questions from the different ethic deliverables that he was actually proofreading. So he just listed the different steps that we have gone through. And for this one, he still needs a status update, but I think actually the best will be indeed to invite him to one of the executive committee meetings, or I'll just write down the questions and chase up. This is the question, yeah. This is the DPA, so this is the Data Project Impact Assessment. Whether we have to do it or not, this is still something that has to be discussed with Caduceo, I guess, because it's them who has all the data in hand, and Etienne also. And Dan. So this is still a discussion that we have to do very soon for this deliverable. The authorizations for animal experience, I think there were no changes normally. You had them all in already at the beginning. For the import and export authorizations, as far as I know, there hasn't been any sample extra import yet, so there's still no update. And as far as I know, you haven't even asked for it yet for the sample import, right? But we will go back to in writing. So until end of March, okay. So I will do a mail to the responsible persons of the different deliverables where there's still open questions, so that Dan can get an update on those. Because we also have in mind he has to follow up throughout the project, and at each reporting period he has to write an ethics report and how we're doing and if we are all respecting all the deliverables and everything on ethic issues. And I think this was the last question. Just to have in mind for Dan is that he has to submit at the same time as we, because it's an annex to our periodic reporting, his ethic report. So he also needs some time to do it. So I'll probably launch that even before our periodic reporting, so that he has the most up-to-date information at the end of the year and can start writing actually. Then I hand over the floor to Etienne, right?
Maybe Ralph will join here, and maybe when you get Stefan, if you will, maybe would you like some slides?
That one?
Yes. Thank you. Okay, so I will do the presentation for the work package 2. I'm not sure whether I can remove my mask just for the presentation, or is the policy very strict regarding that?
Keep it. We can hear you well.
Okay. But you won't see my facial expressions. Maybe it's better. Anyway, so the presentation is in 2 parts. The first one is an update on the work package 2 with some reminders on the main objectives, tasks, and where we are at the moment, and the perspective. And then we'll move on with the second part, dedicating to an important aspect of the project regarding the evolution and the lung function trajectories during the youth. So this will be presented by me and Benedict as well, regarding first the Pélagie cohort, which is a nice and important birth cohort from France, and then the ALSPAC cohort that I will present. After this presentation, the specific aspects of the COPD will be treated first by Mette Anthony regarding the Scandinavian cohorts, with some update as well regarding the use of the Tromsø and DCH cohorts. And then Pascal will present a review of the known and not so well known determinants of lung function and respiratory diseases. So regarding the work package 2 update, this is a quick reminder of our objectives. And as it was submitted in the project, our goal was to integrate within a so-called unified database some pre-existing cohorts. We now know that it won't be possible to integrate within a unified database all this information, because a lot of and most of the cohorts won't allow the unification and the actual export of the data. So we have to adapt to this change. And this was, of course, discussed with the CE experts. We still one objective is still to enrich the resulting database with new information, both at the environmental and also omics level, in a view to conduct a lot of different kinds of analysis, from descriptive and clustering approaches to characterize the different phenotypes of subjects and the different lung function trajectories, and then to explore the different exposome phenotype associations through what we call an EWAS approach. So the tasks are divided like this, and for today we'll mainly talk about the 2 first tasks, because the task 3 and 4 from the work package 2 are dedicated to the actual conduct of the analysis. So this is something that we will start as soon as we have the data, but I will update you on that right now. So the different study populations and the different cohorts. On the left, we have the cohorts where we aim to study the association between exposome and COPD, so in adults. And to do that, we will use data from the DCH, from the Tromsø and Novak cohorts. This is a presentation that I've already done, but it's mostly separated in two parts. The first is actually below, is the use of the overall population to conduct a very wide, a large population analysis to identify exposome-related clusters, and also more simpler, to contrast the characteristics of the patients with COPD with those without COPD. But it is a large population analysis. Then this will be completed with targeted case control studies where we aim to conduct omics analysis and with modified number of controls and cases from the COPD cases with at least 200 subjects in each group. This will be also detailed in the next slide. In the middle, we have the part for the analysis, the evaluation of the lung function and the different trajectories. So it will be based on LSPAC and Pélagie. And then on the right, the CF registry, which is very specific, of course, and which will be based on the national Vaincre la mucoviscidose CF registry, the French registry. So regarding the task 2.1, after a lot of different exchanges, and it's of course longer than expected, but one key aspect is to grant access to those databases. So we have an access granted for the LSPAC cohort, for the Vaincre la mucoviscidose CF registry. The application forms have been accepted for DCH and Novak, but Mette and Tony will make a more detailed update on that during their presentation. Regarding Pélagie, the access is already granted to Benedict. Other media partners will possibly access on request. And the timeline for access to the biological samples, we are still aiming at gaining access by the end of the first semester of this year. So regarding the development of the secure unified database, of course it has changed because it's not a unified database anymore. It's more of a combination and of various data from different databases. So the decision with Caduceo has been made to go to use Caduceo as the server owner with a secondarily transfer to INSERM, which will be important to anticipate. Regarding the omics analysis, I will be very quick because it's something that I've already shown. This is the proposal for the work package 2 for the use of the spare budget. So basically, we propose to increase the sample size of the different targeted cases control studies, including when it's possible repeated data, to increase statistical power and also to have a better control of the variability. So it means that for the epigenetics, we propose to increase from 1,000 to 1,200 samples. For the genomics, it's a new analysis, which was not initially planned, so it's from 0 to 1,000 samples. And for the lipidomics, the proposal is actually to use the initially planned budget, which was for a maximum of 2,500 samples, and to increase that to 2,200 samples. It gives you this detailed table with, on the right in green, the new proposed number of samples by cohort. What will be done regarding the different epigenetics and genetic analysis, maybe Stéphane will explain. I have some slides from you, which I found very beautiful, but I think you will be more expert than me to explain them.
Okay. just quickly to explain what we're going to do to analyze the epigenetic data. So I don't know if you're familiar with this kind of analysis, but the idea is to see whether cytosine are methylated or not, and we know that the methylation is associated with regulation of gene expression. So to see that, what we do is that we start from the DNA and we convert the DNA using bisulfite in order to convert unmethylated cytosine to uracil. Like this, only the methylated cytosine remains, and we can just then hybridize the converted DNA on beta arrays that are already available in order to determine for define methylation site in the human genome, which of them are methylated and which are not regulated. What is interesting with this approach is that it's not only a qualitative method but also a quantitative method, which means that we know not only if it's methylated or not, but if the methylation is 20, 50 or 80%, which means it can be quite interesting to have a quantitative value for this kind of difference. This is for the first slide. The next slide is to show you so the beta array that we will use, interrogate, it's on the right-hand side. It will interrogate 850,000 different sites on the human genome. So for all those for which we will get the DNA to extract, it means Adlis, Pelagie, DCH, Novak, we could analyze them on these bead chips. And for instance, for RSPAC, the methylation data are already available, but it's not exactly the same arrays that have been used, but they are similar. There is less sites that have been analyzed in this cohort, only 450,000, but they are similar to, they are included in the 850,000 that we will analyze. And there is several papers already published that compare the two different arrays, and we know that they are comparable except for a bit less than 27,000 probes that we could exclude easily. So it means that we should be able to compare the data between the different arrays. And for the last slide, it was to show you what we propose to do on genomic data, because we know that the genetic background vary from one population to the other, even through the European countries. It's shown on the right-hand side that if you just do a principal component analysis based on the genetic data in European population, you can see that there is some difference. The two first components are shown on this graph. So to avoid to have bias due to genetic stratification, the idea is to include this data in the analysis that we will do in the future, and we usually include between 10 and 20 first component of this kind of principal component analysis. And this can be really easily done with this kind of genotyping bead chips, for which we can have the genotyping data for 650, a bit more than 650,000 SNPs over the genome. And finally, another advantage of having this kind of data is that we could also take into account if people have a kind of genetic vulnerability to, for instance, lung disease, including this kind of information, and to see if they are more or less sensitive to their exposure due to this genetic background. If you have any question, of course.
Okay, so now we have a question.
One question, do you see any effect of the expression level when you look to the degradation of the DNA level from the phenotype? Investigate that? Or?
Yeah, we know if I well heard, you asked if there is an effect between the, an association or a correlation between the methylation data and the expression data. It has been done for many tissues. It's not perfectly correlated, but we know that usually there is a kind of correlation between the two, and we know that the expression data depends on the methylation data, but not only. So we know that there is a kind of a relationship between the two.
So the reason for asking is, when you see a correlation, then you have the possibility to find new biomarkers for the
Sure.
diseases.
Yeah, this is the idea. The thing is that there's two things. We will not have we don't have the expression data for most of the sample that are available. And the other point is that methylation data, so it's easiest to analyze than the expression data, but it's vary from one tissue to the other, but it can be quite constant between different tissues. So it can also be interesting for what might be estimated to what happened in the lung, for instance. Does it answer your question or not completely?
I know it's complicated.
Yeah, but we can maybe discuss a bit longer after if you want.
I also have a question. I'm not sure we have the right to do genetic data in Pelagie, so that's maybe something we have to discuss. Because methylation and epigenetic, yes, but genetic needs special authorization, and I'm not sure we have that. And I wonder about the other cohorts as well, yeah.
It's a very good point. Maybe we should check that.
Yeah, because it's not the same kind of informed consent. There is one specific, to do genetic data, it's very specific, it has to be a separate consent. And not all the cohorts usually have that because it's always more complicated to have consent for that.
Okay. Thanks, Benedict. And so I leave you the floor for your slide.
Okay.
We will move on with the presentation of the two cohorts. The first one,
Je vais là-bas.
Pélagie. Maybe it's easier.
Okay, it will be very quickly because, well, it's just to remind you or introduce you the Pelagie cohort. So it's one of the existing cohorts of the WP2, and just it's a child cohort that has the specification that women were recruited during the first trimester because when the cohort was set up, they were particularly interested in having prospective exposures during pregnancy. Most birth cohorts are recruited at birth, but here they were recruited during pregnancy. And it was more or less 3,500 mothers' children living only in Brittany, and most of the children were born between 2002 and 2004. So addresses of mother and children are available since pregnancy and for the different follow-ups. And so they were, we have questionnaires during pregnancy at birth, at the 2-year age of the children, 6, 9 to 16, with data at 12, and then normally next month we will start the follow-up that has been delayed, etc., so children will have 18 years old. And it's in this follow-up that we'll have the only lung function data for the cohort. So regarding respiratory issues, we have the ISAC questionnaire, or an adaptation of the ISAC questionnaire. So ISAC is the International Study of Asthma and Allergies in Childhood. So it's quite the standard questionnaire that has been used also in adults, actually. And so the idea was of the ISAC was to evaluate the prevalence of atopic disease worldwide. So it's validated questionnaires with self-reported questionnaires by parents and children. And they are interested in 3 sections: skin, nose, and breathing, with 22 items. And so for Pélagie, we have those questionnaires at age 2, 6, 12, and we will have them also at the 18 years old. So besides the Pélagie, we have also additional data on family history, environment since pregnancy, and use also of pesticides at home, and a lot of other environmental exposures. And also for the respiratory health at children at 2 years old, we have about information about otitis, bronchitis, and other allergic diseases, respiratory symptoms, and eczema-like symptoms. And it's very similar to at 6-year-olds and at 12 years old, with specific questions about infections before 1 year old. That can be, I think, interested as well. Okay, that's all for Pélagie. If you have any questions. So we have blood at birth and at 6-year-old, and at birth and 12 years old. But for the epigenetics, we will only have at birth. And for the lipidomics, it's also at birth, and it's 159 samples available. It's serum, yes, it's all the serums we have left.
For the genomics also analysis, it will be blood from birth?
Yes. Yes, so Stefan will do some tests because we have placenta. So for we have placenta for a lot of children. So Stefan will do some tests to see if we can use placenta, because we have a lot of placenta, and that would be the best. If not, we have whole blood, un caillot de sang. And we have DNA as well, but we don't know exactly, because it's kind of a homemade family cohort, so it's not so easy to know what we have for who. And the idea is to prioritize the children we have at least until 12 years old follow-up. But we don't know if we will have enough, if we have blood for them, etc. So placenta is true, so the ideal would be to do the placenta. But it's a new matrix for you, so we have to test if it's okay.
And at 18, will you do the lung function of all kids?
Well, the plan is to have 500, because yes, I think we have the budget for 500 kids. And the questionnaire will be sent to all. So we'll have the clinical examination in a subset. So first, it will be the children who has follow-up at 12 that will be invited, and then if there is not enough, they will open to more children. But the questionnaire will be sent to all that they are still being followed up. Yes.
Benedict, please, when does the cohort start?
It started in 2002. Okay. More questions?
Thank you. Okay, so next this is a presentation of the ALSPAC cohort. So the different analysis that will be done in Pélagie and ALSPAC, we will be able to compare some things, especially regarding the symptoms and the clustering of exposures, things like that, so it will be interesting. Of course, we won't be able to compare regarding the lung function because it's not available yet. So. And the results from the omics analysis will be compared to those already obtained in ALSPAC because there are some previous results. So ALSPAC stands for Avon Longitudinal Study of Parents and Children. It's a multi-generational prospective birth cohort study. with a lot of different information collected over time regarding the phenotype of the children and also omics data. The eligible sample was based on pregnant women living in close vicinity of Bristol in the UK in the beginning of the 90s. So this is the G0, what is called the generation 0. It corresponds to the mothers of an approximate number of 15,000, which resulted in an approximate 15,000 of fetuses and then children. And then this is G1, and there is the possibility currently to also assess the second generation, the G2, which is the third generation, so children from the children of the mothers included. So geographically speaking, so Bristol and the territory of the Isles Pact, this is here in the southwest of UK, and it corresponds grossly to the county of Avon, which was the ancient delimitation. Anyway, this is a very specific area, so it could be viewed as something, as a limitation, but within this area there is some kind of heterogeneity and a lot of different possible exposures, which remains very interesting. So basically it's largely a tertiary sector regarding the local employment, but they also have manufacturing, agriculture and food drink production. The area is called to have a temperate climate, but of course it's UK, so it's quite cold and rainy. No, I'm joking. So this is a table. I won't go into the details. It's just to show that within the Avon County, the ancient Avon County, there are different areas, both urban with the city of Bristol, of course, but also other areas more rural with different aspects of the exposure. The data collected is very diverse, it's huge, a lot of information on the different key phenotypes, genetic and biological informations are collected. So again, I won't go too much into details, it's just to show you the extent of the data collection. So those are the phenotype measures. It's based mostly on self-reported questionnaires from the children themselves, from the parents, and also from the teachers for the aspect regarding education and school-related aspects. Combined to those self-reported questionnaires, there are some clinical assessment measures, it's called CIF, donc a lot of different aspects regarding the physiological evaluation, so anthropometry, blood pressure, lung function, of course, based on spirometry, and a lot of tests regarding the vision, the audiometry, the speech, the language, the allergy, of course, but also regarding the cognitive aspects of speech and language. And after that, there are more dedicated sub-studies that I won't detail. Regarding the environmental measures, there are different aspects. First, the self-reported questionnaire measures. There are a lot of questions regarding the local environment with different questions on diet, the characteristics of housing, the social background, different stressors, different questions on the local air pollutants, and for instance, cigarette smoking, use of chemicals in the home, and so on. There are also questions on noise at home and at school, and on the different aspects of physical environment, safety, and characteristics of school. So there are a lot of different questionnaires that address the question of environment. There are also more specific focus assessment, but I won't detail that. So how often have been followed up? There are a lot of different time points, from birth to 18 and even up to 24 years of age, with a lot of different child-completed questionnaires, clinical assessments, and questionnaires completed by the caregivers. Mostly, there are a distinction between 6 data collection phases from infancy, as you can see, early childhood and childhood, late childhood, adolescence, and transition to adulthood. This is a representation of the attrition rate and the number of questionnaires completed over time. So, of course, with increasing age, there are a lot more missing information, but it is expected in such a cohort. But we still have a lot of remaining information, even in later stages, such as the transition to adulthood. Regarding the specific aspects of physical and social environment data, which is of particular interest in the Remedia project, we have different sources and different kinds of informations available. We have informations on the area level, built and social characteristics. So those are aggregated data on geographical areas. We have information on exposure measurements, participant-reported data, as I previously presented, so regarding the perceived neighborhood safety, for instance, or the characteristics of the housing, the noise perceived. There are some subsamples with information directly measured from participants, for instance, regarding blood lead or mercury concentrations, but also physical activity. And a big database updated, always updated, regarding the addresses of the participants at the different time points studied. So this is a big database of geocoded information. This is just an illustration of these reported and study collected measures to show the extent and the variety of data collected. So, for instance, we have different information based on sensors, on biosamples, and on questionnaires. Regarding sensors, there are, just to give you an example, nitrogen dioxide, toluene, and volatile organics, which are collected from a subsample of homes. Of course, it's very limited compared to the overall sample size of ALSPAC, but it's very specific information. So based on that, we had to browse all this information to make some decisions regarding the data that we wanted to access. So the decision was made in concordance with our objectives to keep all self-reported questionnaires and clinical information relating broadly to respiratory function, of course, and a large spectrum of determinants and potential exposures of interest. The idea was to find a trade-off between too much information and too few, not to be frustrated, but if we ask for everything, it's impossible to analyze because it's like 90,000 variables, different variables. So it's a lot of information to process. It's not useful to ask for everything. So this spectrum of potential determinants included social demographics, of course, clinical assessments regarding an inventory of the different associated diseases, anthropometric, lung function, allergic symptoms and complications, and also mental health and well-being in a broad way, because some studies have reported some association between mental health and respiratory function. We didn't ask for too specific clinical assessments because there are a lot of information, and sometimes we have the very detailed results from exams for the vision, for instance, but also for the hearing. So it's an open question. Maybe we could think, because maybe we will address the issue of noise, that the detailed results from the audiometry could be interesting. So it's something to discuss, but for the rest, there are a lot of specific clinical assessments which we don't ask for. We don't ask for, yes?
But this is the first set of data that you're asking to
Yes.
outside, but we can go back after having...
Yes, of course.
some
It's
data.
yes.
So this is really an open database, or not that open, but with the access, like, we will be able to go back and...
Yes, clearly. So if we missed something that we will need for a given analysis, it's completely possible to ask for an amendment and just take the opportunity of our I don't know the word of our authorization to ask for more. It's possible. And also, so we didn't ask for very specific education and school-based assessments because there are a lot and sometimes very interesting, but for us it's, I think it's off topic. But who knows, for instance, there are a lot of information of antisocial behaviors, things like that, so well, maybe it could be interesting, but at a later stage. Regarding the omics and the environmental data, so for the omics, we had dedicated meetings to choose from the available data catalog. So this is a short description, but here we made the decision with the help of Stefan and Sophie to choose those data. So those include both raw data, reference data for the genomics, and epigenetic results, with two kinds, one which is already available, so this is the last one, and ideally, but maybe in a later stage, we will ask for a better set of DNA methylation. But again, if you have questions with that, Stefan will answer. Okay, and so regarding the environmental data, one key possibility is to link the geocoded information from the ALSPAC participants to possibly new information, which are not currently available within the ALSPAC database. For instance, the noise. If we're interested in assessing the association between noise and the lung function trajectories, it could be possible to ask for this linkage. So there is a much detailed procedure on the website and in dedicated papers for the how-to. And there is a team in charge of that in the ALSPAC environment, who uses a very interesting software to preserve privacy of the participants while possibly enrich the database with a lot of new information. So, and I almost finished. For the ALSPAC, there are a lot of publications. There are more than 2,000 academic papers published from ALSPAC, and out of which a subset of publications have relied on geocoded data and environmental information at large. So I won't detail all the results, but different papers have demonstrated different associations between domestic exposures, maternal and child health, different chemical products, and also exposures such as electromagnetic radiation. There has been some publications on prenatal lead, mercury and cadmium exposure, with their associations with child development, but also school performance. Different works on particulate matter air pollution exposure and the associations with gene expression, and so on and so on. So this is just a picture to show some interesting papers for our package, to see what has already been done and where we can provide and find something new. So those publications include the evaluation of the association between residential green space and lung function up to 24 years of age, the assessment of the lung function trajectories themselves in a multi-cohort analysis, a very interesting one, published in the Lancet Respiratory Disease. So basically, what they found is there are 4 different trajectories: the low, the middle one, the upper one, and the better one. So it's not very groundbreaking, but it's interesting to see. There are also been some publications on epigenetics at 2 time points, the DNA methylation at birth and the DNA methylation at what we call pre-adolescence, so at 8 years old, and their association with the lung function and lung trajectories at adulthood. So our proposal was accepted. I won't read the detailed proposal, it's on the website, but mainly we focused on to be original and ask for something a little bit different that already been done, to focus on clusters of exposures and typical or atypical combination between those exposures. It means that one aim is to assess in combination what air pollution, socioeconomic deprivation, home environment, maternal smoking, things like that, how they interact and how they potentially affect the lung trajectories, rather than assessing things independently. We have some objectives regarding the characterization of the different clusters of exposures, and of course to address the issue of their association with lung function. Within this framework, we also have the possibility to assess potentially new risk factors or exposures. And when I say new in ASPAC, but maybe new by themselves. And one interesting candidate discussed within the work package was the noise, but this is something that we plan to discuss all together right now after the presentations from Mette and Tonier, and also tomorrow during the dedicated session with the work package 4, because this is something that could be possibly studied jointly in the population level studies and in experiments with mice to confront results and different kinds of hypotheses. Okay, so if you have any question, of course.
So yes, so noisy, I don't know if we ask the question now or we discuss it later, but it's very interesting. The problem is, how will you assess noise, because it's not so easy. And for example, in France, there is no good maps of noise. The ones that are from the EU are not good enough to do epidemiological studies. So I don't know if you have some leads or where you will find the noise exposure maps.
Yes, so we have the chance to have an expert on board. So Mette will answer, I think, more relevantly than me. But regarding the ALSPAC cohort, there are different sources regarding noise. And regarding Scandinavian cohorts, there are very standardized information for noise. But again, I think Mette will answer. And for France, I don't know. But for Pélagie, we'll need to check. Okay.
So I will continue the presentation of the cohorts that are participating in work package 2. And the cohort I'm responsible for, this doesn't work. This is the diet, cancer, and health cohort, and I will both describe what the cohort consists of, but also give an introduction of our previous experiments with environmental factors in this cohort. So the diet, cancer, and health cohort started in the mid-90s, between 93 to 97, where we enrolled, or we invited 160,000 persons, all between 50 and 64 years of age, and all living within one of the two largest cities in Denmark, Copenhagen or Aarhus. In total, 57,000 persons agreed to participate, and they came to our institute and answered a number of questions, these two questionnaires up here, which gave us really detailed information on both their diet habits, but also on their smoking habits. We have really detailed information on smoking of all these persons. They also have their weight measured, height, waist circumference, and we took blood samples, we took urine samples, and adipose tissue samples also. And also really important in the Scandinavian countries, when we do research like this, we have their personal identification number, and this number is in the yellow card you can see down there. That is our social security card. Everybody gets one of these when they are born, and you can see this 10-digit number. This allows us to link between all the registers that we have in Denmark. So which registers do we have available? We have our CPR registry. This is a register we use a lot, because in this register we have information on address history for all people living in Denmark dating back to 71, including moving of address. So if people move, we will have both information on the address before moving, after moving, and an exact date of moving. So using that, we can of course get address history for all of our cohort members. We also have a number of different registries, health registries. This is just some of the registries we have nationwide in Denmark. We have a hospital register, a mortality registry. We have several different clinical registries. We have a prescription registry where all redeemed medication is registered. Then we have a number of registries at Statistic Denmark, which is mainly the socio-economic variables. So we have individual information for all people living in Denmark on income, education, marital status, occupation, ethnicity. And this is time dependent. So for each year we have information on how much people earn. So we can actually adjust for this highly specific. So which registries will we use in this study? We will of course use our hospital registry, which has been nationwide since '78. And it holds information on all hospital contacts in Denmark, both inpatients, outpatients, and emergency patients. And what we get in these registries are the discharge diagnoses, and all of these diagnoses are coded according to the ICD-10. So using this, we can find out which persons in our cohort develop COPD. And we know that we have, at present, we have more than 4,000 COPD cases in our cohort. Another registry that we have, which we will use in the present study, and already have permission to use, is the clinical registry called the Danish Registry of Chronic Obstructive Pulmonary Disease. This registry includes both inpatient and outpatients, and briefly it includes all patients with a COPD diagnosis who attend this annual control visit for COPD. And this is a relatively new registry, so it's nationwide since 2008. And this has much more detailed information that are interesting for this project. So we have the FEV1 information available, and then also smoking state is available in this cohort. So we already have a number of environmental exposures in our cohort available. We have been working with air pollution in this cohort for many years. And the model we have mainly used to determine air pollution in this population is a multi-scale exposure model called the DEM UBM Airgas modeling system, which is a Danish developed system for modeling air pollution. It's a deterministic model, which means that there's a number of input variables like emissions inventories. We have meteorology going into this model and a number of other information. And briefly what this model does is that it combines the exposure both from the regional background. It combines, this is shown in this picture here. You can see this is the center of a city, and then you can see the contribution from these three different places that emit air pollution. So you can see the regional background is stable across the city. Then we have the urban contribution, which is modeled by this UBM model, which you can see down here. This is a map over Denmark down there. And this has a resolution on 1 × 1 kilometer. Maybe this, no, that doesn't work either. And then, of course, within a city, we also have some peaks from the street level, and this is modeled by the OSPM model. And as a new thing, we just developed model that are able to estimate ultrafine particles also. So these data are also available. And also as a new thing, we have just found out that we have developed a method to separate into specific sources. So we actually do have information on for example, the particles that are emitted from traffic and the particles that are emitted from non-traffic. Oh, you have one that works. That's much easier. Perfect. No, but it's better than the other one. Okay, so we already, as I said, had some experience on air pollution and COPD in this cohort. This is a study from 2011 on COPD, air pollution and COPD. And as you can see, we tried here to look at different exposure times windows. 35-year long-term exposure is the longest window, and this is, you could say, the poorest estimate. This is just baseline exposure. And if you look at the results here, the crude estimate in here, the adjusted estimate, and as you can see, not surprisingly, we find that COPD is associated with air pollution. We have in this study NO2 and NOx, and I think it's really important also to see how the estimates move from this is the crude and this is the variables adjusted for smoking. So this kind of indicates why we already know that it is so important to adjust for smoking and do it really thoroughly in studies on COPD. We also did another study, more recent study on COPD in the diet cancer and health cohort. This was within the lab study, which is a Health Effects Institute funded study that looked on low-level air pollution in Europe. And this is, you can say air pollution is here modeled using land use regression model. So this is a different exposure model. And it consisted of data from 3 cohorts in Denmark and Sweden. But if you look here in the number, you can see that in total these 3 cohorts had 5,000 COPD cases, but a little less than 4,000 of the cases was from our cohort. So it is basically the results for our cohort that you see here. And here we have information on PM2.5, NO2, and black carbon. And again, we see an increase in risk not surprisingly, but again we see this really huge difference from the unadjusted hazard ratios to the adjusted hazard ratios. So thorough adjustment for smoking again. And this is we just recently got this study where we were able to separate air pollution into traffic and non-traffic contribution, and we only have one study so far, which is on type 2 diabetes, and it's not our cohort, it's the entire Danish population, so we have 148,000 cases, and it's just been accepted, this paper. But I thought it was interesting to show that this is, as I said, diabetes, and we have here PM2.5, non-traffic, traffic, ultrafine particles, NO2, and elemental carbon. And here you can see what the results are if you look in a single source model, and this is when we have both traffic and non-traffic contributions within the same model. And
can I just ask you a question? I see that you've got ultrafine particle information, which is quite, well, for us, at least these American correct me, but in France that's very hard to have this kind of data. Do you have many ultrafine particle stations available to measure the...
I think we have 7 or 8 in Denmark, so, but it's, as I said, based on modeling. Also back in time, also using NOx, but you have to ask our exposure experts. It's a modeling system that is developed in the Netherlands, so it was developed in association with them. So, but I'm sure they can tell you more about that, because I think also it's, given that it's COPD, it would be really interesting to have ultrafine particles.
It's
but
quite new, like something that
yes.
can add something to the knowledge.
Yes, I think so too. That's also why I mentioned that we already have this information available. But also I think what is really new is that we are able to actually separate air pollution into non-traffic and traffic. And as you can see, what we actually found here for diabetes, especially for ultrafine and the elemental carbon, was that the association was stronger for the traffic the traffic source than compared to the non-traffic source. And I don't think that there are basically no studies also that have actually addressed that. So I also find it interesting because we know from the animal studies already that different parts of the depending on their source, the particles have severe difference in toxicity. So it could be interesting to also have this information in the EPI studies. So noise, we also have this information already in our cohort. We have estimated that using SoundPlane, which is a computer model based on the Nordic prediction method. Input variables for this cohort was, of course, the geocodes for all our cohort members. And then we have for all road lines in Denmark, we have information on the traffic composition, which means the composition relating to heavy light transport. We have information on yearly average daily traffic, on traffic speed and road type for all roads in Denmark. And you can see here in a 3D view how this actually looks in SoundPlane. In red you have all the road lines where we have all this information for all road lines in Denmark. And in blue you can see the buildings, which we have in 3D. We also have information on noise barriers and terrain, so everything is included when we estimate noise. We also include reflections, so both first and second order reflections are included. And this is, we have actually done this for all addresses in Denmark, and this is how Denmark looks when we look on a noise map. So is noise then harmful to human health? This is a study that I still get when I talk about. I've been working mainly, this is my main research topic during the last 10 years. So the first study we did was on road traffic noise and stroke, and we found an association there. We also did a study on road traffic noise and incident myocardial infarction in the diet cancer and health cohort. We also find an association there. And later on in 2018, WHO did a report where they ended up concluding that at present there are high quality evidence now to conclude that road traffic noise is a risk factor for ischemic heart disease. We have also found an association with heart failure, with type 2 diabetes, with breast cancer, and the most recent study is this study where we found an association between transportation noise, both road and railway noise, and incidence of dementia. And this was actually published in BMJ, and I would say also it went around the world. We found it in papers from Japan to Brazil. So I would also say from here to here, there's also been an increase in interest both from the press and from the politicians. So here I got the question, is noise at all a risk factor for human health? A lot. And now actually the politicians already know now that traffic noise is a risk factor for at least cardiovascular disease, but also potentially for a number of other diseases. So together with my noise colleague, Thomas Munsell, we also did a couple, actually we did a lot of reviews in cardiovascular journals to inform the cardiologists that this is indeed a risk factor that they have to take serious. So how is noise a risk factor for human health? Basically due to two mechanisms. First of all, we know that if you are exposed to traffic noise during the day, it increases stress response or the fight or flight response, where the body mobilizes resources to either flee or fight from a situation that it considers as dangerous. And this is, of course, not a problem in an acute setting, but if this is chronically, it can increase risk of a number of biological risk factors. But what we think is maybe even more important is that road traffic noise can lead to sleep disturbance. And I guess some of you already know some of them. These are conscious, such as you have difficulties falling asleep or you wake up early. But actually we know already that if you're exposed to traffic noise during sleep, it also has some non-conscious reactions. We know that there's a reduced amount of this slow wave sleep, for example, which we know is really important because this is where the body restores. So if we look on which biological risk factors could be possible here, we have hypertension, or oxidative stress, endothelial dysfunction, inflammation, which are all leading to this cardiovascular disease. We also see a number of risk factors important for obesity, diabetes. But what about COPD then? Is it at all possible that noise can lead to increase in risk of COPD? And I would say that we have done already some studies showing that if you're exposed to traffic noise, your lifestyle changes. You will be less willing to do exercise, for example. If you sleep poorly, you're stressed, it's much more difficult to actually motivate yourself to go out for a run. And we also actually showed that there might be an association between traffic noise and smoking. So if we think that road traffic noise would actually increase your smoking, then it could also increase the risk of COPD. Also, we know that if you are exposed to road traffic noise, we have both oxidative stress and inflammation increase, which might somehow at least interact with particles. So if we think that we know it coexists with air pollution, so if you have both air pollution and road traffic noise, I could easily see that there could be a co-reaction increasing the risk of COPD. So what can we do with our cohort then in Remedia? A study, I think I heard Sophie asking us really sincerely to start producing some publications. So a study we could start on already tomorrow is a study where we use the entire cohort, where we know we have these 4,000 to 5,000 COPD cases and find them in our hospital registries. And then we could look on all these exposures that we already have available. So this is air pollution, where we also have ultrafine particles, and as I said, we are able to separate these components into traffic and non-traffic exposures. We have noise, we have surrounding greenness, then we can do a normal survival analysis, and yeah, to look at different effect modifications. So that's at least one paper we could start do analysis for already now. Then, as I said, we also had this clinical registry where we had the FEV1 among the COPD cases. So I also see a study where we look at how the FEV trajectories develop over time among these cases, again using the exposures that we already have available. And then, of course, when we have the internal exposome information also, the idea is that we combine it with the Norwegian data at Statistic Denmark, harmonize data, and perform pooled analysis. Yes? So if there's any questions, and regarding noise, to answer the question that Etienne received, it's not that easy because this database we developed with traffic, it took, I think, 10 years for us to develop this database. Of course, if you have all the input data on traffic, it's fairly easy to ask a noise consultant to actually do the estimations of noise, but it's just to say we need good input data to be able to determine noise in the other cohorts.
Yeah, do you work on factual noise or perceived noise? Because the way the noise is received by people can be different among each other. For some of them it can be very difficult to have a little bit of noise, and another one won't be able to really think of it. So do you have factual measures and or perceived one?
No, and you could say we don't know yet whether this issue regarding whether you are annoyed, because that's what you're talking about. We know that traffic noise leads to increased annoyance. What we don't know so far, there's only been very few studies, is whether this annoyance actually affects the risk, the increase in the different risks. So is it only the people that are annoyed that also have increased risk in cardiovascular disease, for example, or are people that are not annoyed, are they also at increased risk? Because basically what we see is we know there's an indirect or unconscious effect on sleep for all people. So we actually at present don't even know whether annoyance is important in relation to development of disease. So what we estimate is noise at the most exposed facade, so just outside your window. In our studies we actually also have information on the least exposed facade, which we see as a proxy for nighttime noise. And for example, if you look at diabetes, we see that this least exposed facade is a much stronger associated with type 2 diabetes than the most exposed facade.
Yes, thank you for the presentation. My question is how much traffic noise and traffic air pollution are correlated, and then what is your strategy to disentangle both, because it seems complicated.
It's rather strongly correlated with NO2, but you could say, what is NO2? We don't even really believe that this is what is causing the effects of air pollution. We see NO2 as a marker for basically traffic, so I think it includes also noise. If we look at PM2.5, we have a correlation on 1.25, so that's not that much. So if we add them into the model simultaneously, we actually find an effect of both of them. So our strategy so far has been to put both in the models and then see which comes out strongest. But in most of our models, we find effects of both air pollution and road traffic noise, even though they're in the same model. Yes?
My question is socioeconomic factors, because I guess traffic noise is really related to Are you able to differentiate?
We have really good estimates of socioeconomic status because we have our registers. So I said we had income every year, we have education every year, but also just to say that it's kind of, people really always think that traffic noise is really strongly related to socioeconomic status. But if we look on entire Denmark, there is a slight truth in this, but because it's so expensive in Denmark and popular to live centrally, the difference between exposures in highly and medium educated people are not that high because all the highly educated are living in the cities, so basically they're the ones with the highest exposure. Yes? This one? Okay. Hello, everyone. I would also like to start with a general presentation of the Norwegian cohorts. The Norwegian cohorts consist of the Tromsø study and the Norwegian Women and Cancer study. And the Tromsø study is located in the municipality of Tromsø, up in the high north. What I did not expect was that the temperature in Tromsø right now is equal to the one in Patras, but okay. The number of inhabitants is about 77,000 people, and about 50% of them live on the island of Tromsø, as you can see at the right map here. But somewhat higher proportionals live in urban areas. But there's a large district of rural area in Tromsø. So then we also have variability in air quality and traffic noise as well. The Tromsø study has been going on from 1974 during 7 waves, and those waves are partly overlapping. So meaning that some participants have repeated measurements, 2, 3, or maybe 4. The study includes a comprehensive questionnaire information regarding exposures, lifestyle, diet, socioeconomic status, and self-reported diseases, use of healthcare services, and so on. Together with biological specimens like blood and urine samples, and all blood samples are analyzed for lipid profile and other biomarkers. But then the Tromsø study is not only a population study, but also a clinical survey with comprehensive clinical assessment, including lung function. And this is an important difference between the Tromsø study and NOVAC, that we have those clinical assessments in the Tromsø study. That we don't have in NOVAC, because NOVAC is a nationwide study. And it was initiated in 1991, including 172,000 participants. All of those are women, as the name indicates. And they are born between 1943 and 57 and have responded to from 1 to 4 questionnaires between 98, 91 or 96, 98 and 2017. We also collect 24 hours dietary records and blood samples, plasma, buffer coat, PAX gene, blood, RNA. And of course, these 50,000 women with blood samples are the most interesting ones for the purpose of Remedia. We also collected breast tissues, both from tumors and from normal tissue. And yeah, we have actually data from both middle-aged and old women. We have women, the oldest women are born in 1927. Are getting quite old. We also have comprehensive information from questionnaires in NOVAC, together with data generated from the blood samples on different omics, DNA methylation, and gene expression, mRNA, microRNA, but only for about 2,500 women, I think. And then, yeah, a lot of different exposures. Here's a flow chart of the NOVAC study with 4 waves in different colors here, and the time span from 91 to 2017, and then we have those blood samples with a tear here. According to previous studies, the research on environmental factors relevant for Remedia is quite scarce, I think, because most studies were conducted on persistent substances, persistent organic pollutants like PCBs, PFAS, and dioxins. But there are still interesting findings, especially according to level of POPs and diabetes, because there is a known association between high level of POPs and diabetes, but the causal pathway is not known, and that's a question of the chicken and the egg. What came first, or the exposure and the disease? And one study here found that that the higher level of POP concentrations in the T2 diabetes cases may be due to a slower temporal decline compared to the controls of the study. So that might indicate that the disease came first. Yeah, and we also have a study of skin care products and risk of breast and endometrial cancer that did not find any association. According to factors more relevant for the present study, actually we have one master thesis from the Tromsø study looking at the association between air pollution and airway infections, where the level of pollution were measured at study baseline, where the participants were asked about airway infection the preceding week. And they found one association between nitrogen dioxide and the prevalence of airway infection. But these data were based on air quality measurements from an air quality monitoring station in Tromsø. But this is the only highly relevant study, I think. So what do we have of environmental data in our cohorts? Well, we have data from these monitoring stations, measuring particulate matters, nitrogen dioxide, sulfur, ozone, and also noise measurements. We have traffic noise, but the question is at which geographic level we can make these comparisons more due to personal data protection issues. Because there are available data from modeling of local air quality and so on. But the question is, according to the Tromsø study, if we get actually more specific data on residents of living, maybe we can find a solution, dividing into urban and rural areas or something like that. We have some self-reported data from one of the waves of the Tromsø study, according to indoor air climate, traffic noise, and air pollution. According to the outcome data, we have 550 cases in the Tromsø study detected by spirometry. If we should have a prospective design with blood samples collected prior to the onset of the disease, then we have 300 incident cases with blood samples together with patient journal data. In the NOVAC study, we have so far only self-reported information, but we have
approval for linkage to the Norwegian patient registry. But that does not only cover data from the special health service, and a certain proportion, maybe the majority of COPD patients, they get treatment from in the primary health care. But there might be an option to link to the Norwegian prescription database as well, to get better data. So I checked that. We had 341 cases with blood samples among the 22,000 women who are asked about COPD. But as I mentioned in the beginning, we have about 50,000 women who have delivered a blood sample. So if we could to link to the registries, we would have access to more cases, I suppose. Yeah?
Was there any spirometry in the
NOVAC? No spirometry in NOVAC, no, only in Tromsø study. Yeah, we have no clinical data at all, because it's a nationwide study and only register and questionnaire data are available. Any other questions? No, you're ready for coffee.
So you said how many monitoring stations and how it's in rural area or urban?
I'm going to live in rural area. I don't know, 20 to 30%, I would guess. Okay, thank you.
Well, thanks a lot. It's time for
Yeah, we've got 8 minutes left. We want to stay on the schedule, so maybe we'll take 40. Yeah.
go back at 45.
Yeah, 11:45.
11:45.
And then the first is Latin. Can you please already look at all of the communications from the first and they cannot be replied to you, but try to send them before.
Hi. I'm next on the list. Okay. It's in Patras? It's in Patras? It's this one, yes. This one. Can I open it to see if it's working? Thank you. It copied. You copied. I can remove it now. Oh, yeah.
Wait a sec.
There is this. Yeah. Okay. Good.
Okay. Now you can remove it.
Thank you. Thank you very much.
Have another one. Okay. That one.
Yeah.
Okay.
Just want to copy that because I just got an email from one of the participants on the YouTube stream and he told me it's not readable actually. So I'm trying to send them before so that they can have the next to it.
Okay.
Can you just copy all of them?
All of them?
Yeah. Yeah, I'll just do one exactly. But actually there are more coming. Do you actually have a microphone that we can hand around when people are
Yeah.
asking questions?
Yeah,
That
I'll
might
bring
be
you one.
better.
And you have a presenter here, yeah?
Doesn't work.
Doesn't work.
Okay. Yeah, doesn't work because it was. Okay. Everyone?
Yes, the PowerPoint. Can we make a short look? It's working. Sometimes there are problems with different versions of the problem.
Is that it?
No.
Okay.
It should be good. Yeah, perfect. Thanks.
Okay, good to go.
Thank you.
Yes, please.
You want to?
Yes, please.
Aha, yeah, yeah. Yeah. Nee, vorgestern, am Samstag. Am Samstag. Genau, da hatte ich am Sonntag noch frei. Ja, aber ich war noch anderen Themen. Das war mir zu weit in der Vorfahrt, das hatte ich schon vorher gesehen und ich habe mehr Prozent.
Okay. Ich bin gestern dann mit dem Zug reingefahren.
Ah, okay.
Ich bin dann gestern mit dem
Ah ja. Ja.
Ja, das ist auch schon. Ich mache immer super Blick.
Ja, ich bin einmal diese lange Treppe hochgekraxelt.
Genau.
Am Samstagabend noch. Den Sonnenuntergang.
Aber dann hast du ja nicht mehr was vom Tag.
Ja, aber dann hatte ich irgendwie keine Füße mehr im Abend. Dann war es mir auch zu kalt auf einmal.
Ja, wenn die Sonne weggeht, dann ist es kalt, ja. Aber das war was echt schön.
Das stimmt auch.
Ich habe richtig abends zu Hause am Hals.
Okay, thank you so much. Thanks.
Ah, echt? Nee, das habe ich
You can take your.
Yes.
Telefoniert, weil gleich jemand kann.
That's okay?
Yeah, yeah.
Thank you.
So I just take the other ones. There was WP3 and WP4 who just went there. This one and the biosensor.
It's working, yeah.
Okay.
We'll have to put it on the USB stick first and then for the presentation.
Oh, okay. Yeah.
First, that's before. Nice, you have some pictures of countries. I wasn't sure the collection device. But if you talk about it, yeah. Oh, it's quite.
Okay, thank you very much.
Ejected.
Okay.
It's the bigger presentation, the one with 23,000 megabytes or what? No, not megabytes, kilobytes. Yeah, this one, yeah. It's from the work package 3, yes, you put it in order, then it's...
That
Yeah,
one.
perfect. It's
Okay.
sorted itself, yeah.
So take your stick.
Thanks.
briefly introduce myself. My name is Pascal. I have a background in environmental epidemiology, and so I will expose you some environmental risk factors. So I will digress a little on exposome, and then I will come back to exposome concept. So exposome, it was introduced in 2005 by Christopher Wilde, who was working in the International Agency on Research on Cancer. So he was working on a genome, and he was trying to try to identify key environmental factors that can contribute to cancer. So he was introduced a genome exposome. So he will say, okay, exposition and exposome. So it, from 2005 to 2021, it's a big, big evolution, because incremental evolution, where there has been a general environment and some specific, and then we introduce also the internal environment, which is all that affects the metabolics and also, for example, the microbiota. And the latest is Miller and Jones, that's this new exposome, which says that it's a cumulative measure of environmental influences. So all the lifespan from the bone, even before in the like fetus, to diet and endogenous process. So we introduce also some previous exposome studies and where Remedia comes from, and before Remedia were all the previous exposome studies. So before it was exposomics between 2012 and 2016. So it was one of the first exposome studies that tried to create like a holistic concept and how to integrate exposome in epidemiological studies. And then ELIX, that really focused on the early life exposome from children, so 2012 and 2017. So it was include 6 European cohort, and it's really focused on pregnancy and childhood, and how the exposures can affect child health outcomes. So also we introduced the concept of omics, molecular omics like epigenetics. It was introduced during the ELIX, one of the first exposome that studied omics as exposure. And then ELIX, HEARS, 2013 and 2018. So also complementing exposomics, how to better integrate integrated methodology. So we are now with all these exposome studies, we all have tools now where we can inspire ourselves for normally for example in work package 2, this EWAS approach is environmental exposome-wide association studies. So this literature review will focus mainly on exposome, but also on lung diseases, because exposome affects every health component. For example, as Mette said, noise with diabetes, but now I will focus only on respiratory diseases, and mainly cystic fibrosis and COPD. So as we see, you have this external exposome, internal exposome, and how the omics and the integrated approach through data acquisition. So, for example, biospecimen, where we can study microbiota, we can study with the fetus, microbiome, and immune system. So from the external exposome to the internal exposome, it's a integrated approach where we have all these previous exposomic study where we can inspire ourselves for a rigorous methodology. So this it's taken from a recent article for role of gene-environment interaction in lung disease. So they said now we have to integrate exposome to study. So here it's with asthma, it's the same. So external exposome, we have air pollution, climate, urban exposome, and the internal exposome, for example, again the microbiome and all these omics and transcriptome, proteome, and metabolics. And it contributes to understand, now it's asthma, but we can correlate that to cystic fibrosis and COPD. So also a recent study to determine the aspects of exposome in asthma. So now I will digress a little from exposome to separately take individual environmental factors and then go back again to this integrated approach. So some key studies that, for example, air pollution and outdoor traffic. So this is from the Danish nurse cohort. So long-term air pollution is correlation so as Mette introduced also, noise traffic and NO2, noise traffic and COPD. So as also Etienne introduced this study from ALSPAC. So early life, there is an impact of air pollution and lung function. So we have a decreased lung function with children exposed to air pollution. So now I will focus mainly on outdoor and traffic, and then later indoor air pollution. So they studied the impact of PM10 in pregnancy, and it's a small effect, but still there is a reduction in lung function in mid-childhood. So this study also it's a continuity of the previous one, where that shows that children are very vulnerable to air pollution, mainly in some early stages of life. And why this study is interesting, because we have all these other factors that impact, for example, maternal age, asthmatic status, and also breastfeeding. So breastfeeding may have a protective factor. So the next study is how we can assess the protective factor of breastfeeding and air pollution. So this study showed that it was in a Chinese study where we find that breastfeeding and air pollution is correlated, where the women who breastfeed the children have a less impact lung function. So there is a lower risk of lung impairment where children have been exposed to breastfeeding. So now we are looking into, we study, this is outdoor, but now the EPA estimated, the US agency, EPA, Environmental Protection Agency, said that 90% of Americans spend their time indoor, but I think we can correlate that to European standards, where I think it's like 80 or 70% we spend indoor. So this paper tried to, it's a review of all the potential air pollution inside and the strategies to mitigate this air pollution. So it's a Spanish study. Okay. So all this, as the EPA said, 90% spend inside. So we have the interaction between the outdoor environment and the inside. So later we'll see a study how the microorganisms impact the lung function and how, for example, mold can impact, for example, COPD. And later also I will tell you about the kitchen and how the biomass burning can also affect the lung function. So all these, for example, mold also affect quite a lot I will show you a study on fungal sensitization and COPD. So this, to make the link, it's a study how cleaning products and disinfectant have an effect on asthma. So this is like a study where they've shown a correlation between the use of cleaning products and asthma. With this result, it's more from preconception and conception and pregnancy. So we have a very high risk here of odd ratio of 2.25. So it's a continuation. Now it's more focused on cystic fibrosis, how indoor air pollution affect with a greater morbidity in cystic fibrosis. So this is how they studied two populations, pediatric one and adult, where this is second-hand smoking, and we can see that there is, for example, in pediatric, with second-hand smoking, there is a decrease. This is forced expiratory volume at the first second, so it's a marker of a lung function. So you can clearly see that there is a decrease in FEV. This is also noted in adults. So from 1 year, 2 years, and 3 years. in patients with cystic fibrosis, of course. It's not a general population, it's a cystic fibrosis population. So this one is a Taiwanese study. It's a cohort where they try to determine how the Taiwanese population, the risk of COPD and exposition to particulate matter, how it affects what's the relationship between fine particulate matter and COPD. So here we have also PM 2.5 and the decline in forced vital capacity, which is also a marker of lung function. So you can clearly see that the increase of PM 2.5, incremental increase, you can see clearly there is a decrease in the forced vital capacity in this patient, where it's clear here. Yeah. And another way of showing it is just increasing PM 2.5 and the hazard ratio. So you can see there is a steep increase once we are at 40 microgram per cubic meter. So clearly there is an association between PM 2.5 and increased risk of COPD development. So now, as I told you before, indoor air, there is this paper showed an association between fungal sensitization and clinical like defavorable clinical outcome in COPD. So fungal sensitization is like they try to have association between different kind of fungus. And now we have all these in red dots where we have they found an association, and it's there are all these fungi, and the main one is Aspergillus fumigatus, and these are the different strain of Aspergillus fumigatus. And there you can see the odds ratio, it's greater with Aspergillus fumigatus, and the different covariation. So the previous, where we show this big house where there is mold, so mold affect, so fungal sensitization, it affect also COPD. So we have odds ratio, which is clearly more than 1. So yeah, this is adjusted for age, sex, body mass index, and smoking. But we can say this limit of the study is they did not adjust for socioeconomic status. So they did not adjust for socioeconomic status, but they adjusted for smokers and non-smokers, and they still find positive hazard ratio. Now I will talk a little bit about noise. Mete already introduced, but I will talk a little bit about it. So the role traffic noise and lung function in children. As Mete said, there is a correlation between NO2, but as she said, it's maybe linked to air traffic, to traffic. So this is a different kind of statistical method of adjustment, and the one which is, for example, splines and linear cubic, all these different kind of statistical method for analyzing. So here we have forced expiratory volume and the forced vital capacity. So the only one which is where we found a correlation is this one, where they use spline method. It's a kind of adjustment using splines. So different kind of adjustment, and the last one, they showed an association between NO2 and noise. So as Mete said, there is this kind of where there is traffic and there is NOx and noise, and this lead to like an oxidative stress and also normal stress, which cause an inflammation and reduce lung function. But this is hypothesis also. It is just a hypothesis where we need to confirm on a biological level. But it's a hypothesis which is strongly, that has strong epidemiological strength behind it. So this study tried to find cortisol level in children where if it's correlated with green space, air pollution, and noise. So this study showed that there is a buffer of 3,000 meters, why cortisol? Because cortisol is a stress hormone. So cortisol level has a decrease in children where they have at least 3,000 meters of residential exposure. So there is lower, it's also an hypothesis, but there is a lower stress level with lower cortisol level in children within 12 years. And we've seen also that there is a link between cortisol level and respiratory function. But as Sophie also pointed out, there is different kind of like a limitation of studying noise is how annoyance and perception can have to be factored in, because people have different, even children and adults have different perception of noise. So they pointed out this limitation in their study, where they showed that individual perception is different from, so they have to also, this individual also may influence cortisol level. So we have to factor in individual perception and annoyance in a study of noise level. So this paper was about reviewing all the biological mechanisms behind all these hypotheses. So it's important to make the step from WP2, Work Package 2 and Work Package 4. So this all the biomechanical between noise and respiratory system. So I won't go all into detail, but we've seen already there is cortisol here, and also the noise from here, and it affects all these homeostasis in our body. For example, catecholamine, which is adrenaline and the immune system. So everything. So this also hypothesis is not clearly yet demonstrated, but it's they have very strong evidence behind. So we have a cortisol, we have an immune system, and we have sleep. So all these, sleep deprivation, and it affects COPD and pulmonary inflammation, which is impacted in cystic fibrosis. So all this leads to respiratory system which is impaired. So now I'll talk a little about temperature. So temperature do affect, have an effect on respiratory disease, and this paper they found that there is a correlation between temperature and COPD. So people who have COPD most of the time, which are exposed to very high temperature in 1 month, they do have it's increase in morbidity, so they have increase in decrease in lung function in this in COPD. So yeah, they have people exposed to heat exposure have adverse effect. So this study, a Spanish study, which Aurelio Tabias, I've worked with him. So he said this study showed that there is different kind depending on heat and cold also. So the impact of temperature on respiratory disease and cardiovascular. We won't focus on cardiovascular, mainly we'll study more the respiratory impact of this study. So there is cold also. You see in the blue one. Blue it's cold, and this is hospitalization. So there is a attributable function. It's larger with cold hospitalization in Spanish cities. For heat, it's a higher mortality. But we've seen that, for example, in France, there has been in 2003, I think. There will be an increase in death of elderly people due to a high heat episode. So now we see this is a number of deaths, and this is number of hospital admission. So with cold, there is more admission, but with heat, there is more increased mortality. So now I'll talk a little bit about social inequality and environmental inequality, and how socio-economic status can be part, and should be part of exposure. So it's a mixture of, it's a WHO study that tried to review, so trying to find the association between noise and social inequality. So this review, they found that social inequality, as we saw, noise in itself impact lung function, but if we add social inequality, the exposure is more have more impact. And this also is like indoor air pollution and socioeconomic groups. As we see, air pollution affects lung function, but if we add, the effect on socioeconomic group, it's how do you say? It's more. It's have also impact. So we have seen that noise has an impact and indoor air pollution, but if we take the social aspect, we have a more aggravating aspect, depending on your on economic status. So there is a different kind depending on low status and high status. So this review showed that population with lower socioeconomic status, they have a more increased exposure to particulate matter, NO2, and volatile organic composite. but rather it was associated with higher socioeconomic groups. And also we see that tobacco smoke is a very overwhelming burden with low economic status. So this is a key also component of this review. Just to like a follow-up from the previous, the key tobacco smoke and socioeconomic factors. It's associated in pulmonary decline in cystic fibrosis. So we have tobacco smoke and socioeconomic status. There is a decline in pulmonary function. Like we saw before, there is a decline in FEV and FVC. And smoke exposure is more present in families with lower income and education. And also we can add this in exposome, how public health insurance can also affect this outcome in the patient with cystic fibrosis. Again, just like a follow-up, this environmental risk factors is linked with socio-economic disadvantage. And mainly the use of biomass, tobacco smoke, industrial air pollutants, and all these linked together, there is a decrease in health factors, in respiratory disease mainly. So this study showed that it's not only in low income and disadvantaged population, but also in high income countries in Europe where there are disadvantaged population. So it's not only in low income countries, but in high income and middle high income countries where people living in disadvantageous conditions can be more affected by respiratory diseases. And now I'll talk a little bit about biomass and solid fuel, how it impacts respiratory health. So this is a report from the WHO dating in 2006. There is no update on this review, but it showed that in 2006, people from population from Africa, Asia, and Latin America, they found that it can increase from PM10 can increase from 300 to 3,000 microgram per cubic meter, and it can peak as high as 10,000 microgram per cubic meter. So it's very, very high. And they publish from this report, so where they find sufficient and insufficient data, so we focus on the sufficient data. They see that lung cancer and COPD, there's a strong correlation, and why they make this differentiation, because in 2006 they say, okay, women are more exposed to, because in these countries, women are more in the kitchen, outside like this, and they are more exposed, so they found a difference between women and men. So this is from 2006. So in this report, they introduce the concept of energy ladder. So energy ladder is like the very low income to high income they use different kind of energy to, like as the previous one said, it's fuel for life. So you need fuel for cooking, for heating, for every kind of purposes. So as long as you climb this ladder, from the very low income to high income, the use of, for example, crop waste and electricity, it's a ladder where you have to climb, and the use of more efficient energy sources. Now we have traditional biomass fuel, solid fuel, and clean fuel. So clean fuel, you have electricity, and all the natural gas and liquid gas. So ranging from very low income to high income, this energy ladder is how this population can climb from one step to another using wood, charcoal, coal, kerosene, and then now using electricity in a clean kitchen. I don't know if it's a clean kitchen, but where there is no emission of particulate matter. So just to like a little update on this 2006 report, still 2.6 billion people use solid fuel. Solid fuel includes biomass fuel, wood, crop waste, and charcoal. And kerosene it's in here in the ladder. And inefficient stove. When we talk about inefficient stove, we have to feed the stove more and more to produce the same amount of effect. So it's very well documented that it's most of these 2.6 billion people live in low-income countries, but I think it's changing now. More, it's also in middle and high-income countries also. And the effect of these 2.6 billion people using this kind of energy is like 4 million people die prematurely from lung cancer or COPD using this inefficient solid fuel. So 24% from pneumonia, 20% from COPD, and 8% from lung cancer. But it also affects heart diseases, 18% from stroke, and 27% for heart disease. So, as it's well documented, this paper tried to focus on high-income countries in Europe, USA, Canada, Australia, and New Zealand. How solid fuel also impacts respiratory health in high-income countries, because we know in low middle income countries, it certainly affects. So this review was kind of shocking because it's also shown that there is still use of solid fuel in Europe, USA, Canada, and Australia, and they found a positive association between indoor solid fuel and COPD and lung cancer. Now we'll talk a little about climate change and how it's also affect and how it's linked to all these different topics I talked before, like temperature and the use of solid fuel. So this paper showed that climate change also affects respiratory disease, and they propose this like respiratory health is in the middle, and you have all these air pollution, climate change contribute, they have interlink, and also the change in biodiversity also affect, like we told about mold before, fungal sensitization and COPD. So all these affect respiratory health, and we've talked about stress and all these respiratory morbidity, for example, decrease in FEV and FVC. And we talk also about all the temperature, how extreme temperature can affect respiratory health. So yeah, climate change in itself, it's an interactive component. So it interacts with air pollution and all these different key components where it affects respiratory health and clinical expression, like different kind of phenotypes, what we are trying to find in Remedia, how it impacts the different kind of phenotypic expression of cystic fibrosis. Yeah, and one thing I didn't talk about is also water pollution, how it impacts also the health, the aspect in asthma and COPD. So this is IPCC report from last month. So to sum up, so we have all these tripod. The tripod is climate change, vulnerability, like we talk about vulnerable people in high income and also in low income, and this is exposure. So this tripod, it makes higher risk, and they interact with each other. One is not alone from each other. The climate, vulnerability and exposure from, for example, noise or air pollution, it's always interacting. And the purpose is how to mitigate climate change and how to mitigate also the exposure so that it can, like in red, it's the negative impact, and the green one is the positive impact, like mitigation. So you see, it's like there is a positive one and negative where it can be changed. It's not something that it's permanent. For example, we can change road noise traffic. It's the exposure with noise road traffic will decrease, and then we can also have urban explosion where there is more green spaces, and all these policy is up to the political and political policymakers. And this also is just from the report, the predictions on how the temperature will change from now we are here, and the different modelization on how it will go. So we've seen how temperature also affect respiratory health, depending on change of +1 or temperature. Yeah. So as a conclusion, exposure and climate change mitigation, they both goes hand to hand, because as I expose all these individual, so I come back to the exposure concept where it's holistic approach and they complement each other. For example, we talk about the urban exposure and how we can reduce air pollution that can improve health, respiratory health. So it's an integrated methodology, which from the previous exposure studies, such as ELIX and the other ones. So, and also the importance of socio-economic status. So now we see that, for example, in use of biomass, these people living in high-income countries, they still are vulnerable for, as being part of having a low socio-economic status, they are more vulnerable for having impaired lung function. And now, just there is from the update from the WHO report from 2006, there has been little in climbing the ladder. It's the contrary. It's people are getting down the ladder because of the energy crisis we are living, and there is an urgent need for studies, and I think Remedia is part of this to make sure that as there is no efficient way of climbing this energy ladder, to show that we have health, to recognize the health impact and influence policymakers. Thank you for your attention. If you have any question. Right.
Thank you for your contribution. Just a second. Because otherwise people
Thank you for your presentation. I have one question regarding the information about the lockdown, because we know that the lockdown changed everything in our urban exposure. So I'm wondering if we have any data from the modification of exposure during the lockdown, and if they break the curse of the epidemic data.
Yeah, so the lockdown had a positive impact as such as there has been low traffic emission. So there have been, I don't have in mind, but the traffic emission decreased drastically, and also emissions in the hospital for respiratory health program also decreased very. And I can show you a study of Antoine Flau, who works as an epidemiologist, and he made simulations and modelization how the academic curve decreased, and also how, so you can look at Antoine Flau, and he made this kind of modelization on how the lockdown decreased the curve, and also different respiratory disease where it was less incidence other than COVID-19, but over like asthma exacerbation and everything, it went down also, apart from COVID. Yeah.
So thank you for the answer. If there is a decrease of the respiratory disease in general, can we discuss about the point that maybe there is the impact of outdoor exposure, but also indoor, because people are locked down, so they are at home, so maybe they are more exposed to indoor pollution.
Yeah.
So is there something that we just discuss more about that?
Because I think, yeah, the important key is like people who were locked down in differable circumstances, like people having a large family living in cramped areas. I think the lockdown has a negative effect on them, where if you live, you have a positive lockdown where you have a garden, you have, in Paris, for example, you have small apartments, students who were locked down, and the psychiatric effect. So Santé publique France, they did a study on the psychiatric effect on people who were having negative lockdown, where they were stressed out. And so I think it emphasizes the more vulnerabilities of population, socio-economic status also. It comes back to that, where people living in large families, living in a very small area, where they are exposed to more mold, indoor air pollution, and this kind of thing. I think it has been more disfavorable for people who live in bad condition. But if you have a nice house and a large garden, I think it would be it was a nice lockdown. But I don't think, yeah.
It's really interesting, the question you asked, because regarding the CF, it was really difficult to know exactly the impact of the lockdown, because we know that there were less sick, less exacerbation, probably due because of the lower presence of viral infection. It was not only the COVID because of the protection, but we know that CF, they are used to have the protection against the virus and the bacteria. So it was not only this. And if you compare the different social, we have a look on the social difference with the CF, and we saw that, for example, during the lockdown, people with high level of with high level, they were doing, for example, more sports, and it was the opposite of with people with low level, that they were staying in the house and doing nothing. And so there is a lot of impact that mitigate all this impact of the lockdown. It's really interesting. And I think we need to look at this because, for example, for COPD, it was a little bit different, but there is some difference that could be, I think, studied, I guess.
Yeah, thank you for the great presentation. So I have a question about the prediction models you mentioned. So they take under consideration only the traffic. So PM originated from traffic emissions.
Which prediction you are talking about, the IPCC or?
No, about the lockdown period. So you said that there is decrease in the exposure. So the prediction models take under consideration only the traffic?
Yeah, I think in Paris there are different kind of station. The one urban station and suburban station, and the urban station there is linked to traffic also. So it's for example near highways and everything. So they've seen a decrease in traffic and in these particular stations where it's close to. It's called traffic-related monitoring station. Yeah.
Okay, nice. But at the same period, we have an increase in biomass burning.
I don't know about that in Paris. I don't know.
Okay.
But I think I can look it up. I don't know if there has been increase in biomass fuel at the same time as because there's no little study in France particularly the use of biomass fuel. There is a review about biomass fuel in Europe, but not particularly in France. Yeah.
Yeah, I'm still thinking about it because it's also depend the residential biomass burning up to the income. So maybe we have to burn something, but it's not the same when I have a different income.
Yeah.
And this has a great effect.
Yes. Yeah, I think so. Yeah.
In the exposure.
Yeah.
So it could be nice if we have.
Yeah.
Okay, thank you.
Thank you for this very nice review. And what I think very interesting is your conclusion and on the main key points that could be studied and addressed within the Remedia project. So I like those avenues because I think the first one was the fact in relation with the definition of exposome that we need to assess simultaneously multiple factors when it's possible. Yeah. So I think it's interesting because something we discussed this morning. I think it's also very interesting to remember the different vulnerability subgroups and the socioeconomic factors associated. It's something which is very important. There is also the gender issue, which is can be associated. I guess this is also something that we will discuss today, and something we can quite easily assess within the different statistical analysis that are planned to check whether there is some kind of interaction with gender or socioeconomic aspects. And also the reminder that household fuel, it's not something from the past in Western countries. It's something also that we should account for when it's possible. We have, for instance, this information within the ALSPAC cohort study, so clearly we need to account for that factor. So those were just comments, and thank you for this very clear review.
I think it's the gender gap is not only in salaries but also in this factor. I think it's data in 2006, but I think it's still. I think we still can have differentiate like a sex ratio between COPD and apart from smoking, because it's how we can differentiate women and men in the impact of COPD in, apart from smoking, and it is very relevant. We can find different factors that can contribute to COPD. Yeah.
Okay, thank you. Thank you. I think we had a discussion regarding the work package 2, which was planned in the program. Because we are already quite late and because we already discussed a lot of the work package 2 objectives and perspectives. I propose to have not a wrap-up, but just a follow-up conversation on work package 2. And what do you think? And do you have any comments or questions that we could discuss now?
I think there is something that we have in mind, but we did not discuss a lot. It's the difference of the CF and the COPD. In all discussion, we have this, and it's not a problem because we knew it before. It's the difference between COPD and CF. COPD is a disease in older patients around the 50. Which is not the case of CF. CF is a pediatric disease, at least at the beginning. I'll change a little bit, but it's really different. And just a comment about what we have done with Pélagie, what we want to do with Pélagie and ASPAC is to try to imagine the impact that we can have to the trajectories. And because we can impact the trajectories, we can impact the COPD, which is really important regarding the trajectory. So that was the way that we decided to work on WP2. And I think it is important to remind this in our different discussion. We'll see this morning, it's really important to keep in mind how we can prevent all the impact we are going to study. It's just to comment with the talk of Pascal.
Okay. It's time to eat, Sophie and Christina.
So lunch is waiting outside, I think, and the sun too. And we have to get back here at 2 o'clock sharp.
Ja, wie auch immer, in der eigenen Arbeit ja, wie gesagt, Où est-ce qu'on déjà Ok, super, merci.
It's a show. This one
Yeah.
and no.
Don't touch because
Sorry,
that's
sorry.
clear.
This one
And
and the first one.
okay. Both for today.
Yes. I think for today, not. And so, if we, this is the one where I will do the slide.
Okay.
We can do something, or I have to go outside. What do you think?
What do you mean?
When I will use a Slido, I have to go outside of the PowerPoint.
These ones.
Mm. You don't know.
Tell me again.
Sorry, because when I use with my laptop.
Okay.
While I'm showing the PowerPoint, I could show also this without to go out from the PowerPoint. I don't know if we go on on the PowerPoint.
Yeah.
And we go on Slido. We can do some. No. Begin. Remember the password. So it should. Okay. A few clicks on slide. Okay. This one. But went round. Okay, great. go outside.
I'm gonna search for it, but I currently don't know the answer.
But so I go outside and I go here.
Yeah.
It's easier. Okay.
And
We will do like that.
Paul 1, 2, 3.
Yeah. Okay, I will do like that. It's not a problem.
But if I'll let you know if we can do something.
Yeah, yes. Can I would like just to check my presentation if it's okay, because thanks. So it's with this that I...
Yeah, this or this.
Okay, I don't know.
Or whatever you like.
So I can change things here because with the Mac it changed all my presentation.
Yeah, you can change.
I will I just do some. No. Okay.
Well, we can't change because we have no authorization. This is the stick. Let me check something. No, we can't. It is because you made it on Mac for Mac.
So the two are. But I can't present like that. And I can do nothing to...
No, because it's only for reading, not...
Okay, so I have to change on my Mac and do it more...
Yeah, probably. Or you can save it for also making changes. I think it's something like how you share it to PPT, share it only for reading or share it for reading and making changes and stuff.
If I show you on my Mac, you can tell me what I can do, or you don't know?
I'm not very familiar with Mac and...
Étienne, je peux te demander une chose? Toi, quand tu fais tes présentations sur... Parce que j'ai fait ma présentation sur les Mac, et là, c'est tout complètement...
Ah, c'est décalé.
Oui.
Ça m'est déjà arrivé d'avoir un topo que je faisais sur PC et je venais de le faire sur un Mac, ça faisait ça aussi en fait.
Et là, je peux pas... Tu n'as pas...
Je connais pas de truc par
D'accord.
rapport à ça, je pense qu'il y a un truc de format. On va pas refaire vite fait les titres.
Mais il faudrait que j'ai un...
15 millions de taille, peut-être ça suffit, je pense.
Ah, si je diminue la taille des choses?
Ouais, j'ai du titre au violet, c'est ça qui déborde un peu.
D'accord, bon, je vais faire
J'ai
sur
l'impression,
mon ordinateur. D'accord.
Enfin, ouais, je ne sais pas si après ça marchera ou est-ce qu'il vaut mieux que tu le fasses directement sur la version PC.
Ah, c'est qu'ici, il ne me laisse pas le changer.
Ah bon?
Ah non. Je peux pas.
C'est bloqué.
Oui, c'est tout bloqué.
Ah, merde. Mais ça, c'est peut-être quand il a ouvert, non? Tu sais, d'habitude, on demande si on a le droit de modifier.
Ah oui?
Did you block the
No.
modification mode? No, it's
No,
like that.
it's probably it's saved only for reading, not for editing.
Ah, okay.
It's Mac, Windows.
And it's always complicated.
Yeah.
Du coup, sur ton Mac, tu peux peut-être faire plusieurs versions. Tu sais, tu fais Save As et tu peux essayer peut-être genre PPT 97, enfin.
Ah, okay.
Older versions.
Ah, okay.
Maybe it works better. I don't know. I don't have a Mac. But this way you can have several chances.
Okay.
Et sinon, s'il n'y a pas d'animation, tu fais un PDF.
Ah, je sauve comme un PDF.
Ouais, normalement, si peut-être tu es dans ton PowerPoint, tu peux checker vite fait si tu veux. En général, tu peux faire save as PDF, un truc comme ça. Mais au moins, tu sais que c'est un PDF, ça touche pas.
Thank you.
You can also hear us, right?
Yes.
Good.
So if you can share the screen.
Basil, can you try sharing your screen?
Yes.
Wonderful.
Okay, is that good? I mean, is everybody...
Maybe we can like just put it in full screen. And then, why is this here? So
it's the code.
Always there. Okay. Enter view. Anyway, it doesn't matter.
Yeah, anyway.
Good. Okay. Yeah. So welcome everyone to WP3. We start with the presentation on the environmental sensor, which is going to be held by Basil Adams, who is connected to us via Skype. Hopefully this works. And then I think we'll go on with the biomarker sensor and finish with the study we have executed with the healthy patients, following by the plan we are going to execute, or the idea for the study with the COPD and CF patients. So now the stage is yours, Basil.
Hello.
We can hear you well.
Yes. I think I'll share my screen using another section. Let me try again. Can you see my screen? Hello, everyone.
Hello.
Can you see my screen now?
We do see a screen, and what we see now is the Chrome browser with a YouTube link, or the YouTube
perfect.
stream.
So, hello everyone, my name is Basil Adams from Town Club IZM. I'm talking to you from Berlin today. He's not setting the right...
Yeah.
I think there's something like delay of 1 minute maybe.
Okay, we do it the following way. I show the slides, and you make the sound. If this doesn't work, then I just go through the slides.
All right.
No, this.
Yeah.
All right, so just start, and I try to sync with you by clicking through the slides. Okay, I think this is actually too complicated. We just switch to me giving the presentation and then say thank you anyway to Basel for being here virtually. Good. Anyway, yeah, I think this is too complicated. Or actually, I could call him so that he can listen to what I say, but even this. Good. So welcome, WP3. So as I introduced earlier, hi Basel. Hello. Okay, I think I hold the presentation. I share my screen so you can maybe follow in what I do, and then. Here we are. Good. As I was introducing, like work package 3 consists of the parts environmental sensor, biomarker sensor, and the studies which are having the purpose of validating the sensors. This is not my institute. I know roughly this is an institute dealing with microsystems and the electronics that connects to this, and therefore this institute, the IZM, are the ones being in charge of developing the environmental sensor together with the Fraunhofer ITEM. As a status update for the environmental toolkit, we're looking at a huge range of sensors. After we were selecting from the literature research which were the interesting... Yes?
Can you hear me? Sounds work now, so I might overtake the presentation.
Great, yeah.
Oh, perfect. You might go back to the first slide. Okay, let's give it another try. So today I would like to give you a short update about the progress in development of the environmental toolkit. Can move to the first real slide. Yes, next one. So what we did so far, the first thing that we tried to select the suitable sensors for the project. We tested more than 35 sensors. We tried to compare different technologies, and we had different criteria for selecting the sensors. We really need the first thing is the selectivity, just to make sure that the cross responsibility of the sensors is not a big problem for the gases we are measuring. For sure, the sensitivity and the measurement range, the lifetime of the sensor to make sure that we can use it for many years, and find out some sensors which don't have big dependency on the environmental influences, temperature, humidity, and to make it wearable, small device, power consumption is also a very important point. For the purpose of the project, it was important to find sensors which don't need to be calibrated like every time you use it. So this was also an important point. So we tested all of those sensors, and at the end we decided to select or to choose all sensors. Please move to the next slide.
Am I too far?
Yes.
That's the one now.
Okay. So the sensors we selected use mainly the three technologies: the electrochemical, the metal oxidation semiconductor, and for the particulate matter, we are using sensor using the dynamic laser scattering technology. Please move to the next one. And here in the table, you find the sensors we decided to use at the end. We decided to use very small sensors in the table. Down here, you find the media requirements, which may depending on the studies at the beginning and the range of the sensors used. We were sure that all the requirements are all covered using the sensors, also the range of the measurement and the resolution. Could you please move to the next slide? Here you see a block diagram or an overview of all the other parts used in the device at the end. So we have the main microcontroller, main processor, and we have the SD card where we're going to save the data as Excel sheet at the end. We have the GPS module, the power management part, which will be like a chargeable device, like cell phone. We have all the sensors connected to this PCB. So we have the ozone, the carbon dioxide, the SO2, the NO2 sensors. We have also a very small OLED display where you can see live update about the measurement results. And we have two or four buttons, two push buttons just to jump between the pages, and one button to switch the system on and off. And the other one just to say I would like to save the data on the SD card or not. Next page. And we developed a PCB with most of the system components. You can see the big PCB, the green one here. And to make the system much smaller, we try to move to something called system in package, to put all components on 8 different layers to make the system much more compact. And you can see the one on the top, which is only 13 by 3 millimeters. And we already started with the firmware development for the final system. It's also almost done. And we also built the structure for the data for saving the results of the measurements. Next page. Could you please share the Excel sheet?
Yes. I am sharing the Excel sheet. Can you see it already?
No.
But you can talk. People can see it here.
Because of the delay. So, on the top of the Excel sheet, every time you save the results, you will get the Excel sheet with all the parameters you needed. So, At the left of the Excel sheet, you have the time, the date of the measurement. You get the NO2 results, the sulfur dioxide results, carbon monoxide, the ozone concentration, temperature, humidity, air pressure, and you get also a parameter which gives you general information about the air quality. It's a value between 0 and 500. It's called IAQ. You also get the CO2 concentration, the VOC also in ppb, and the next columns you get information about the particulate matter. So in the project, the requirement was only to get the PM1 and 10, but since the deliver much more information, so we are saving all of them in this table. The particulate matter 1, 2.5, 4, and 10. And using this, it's possible to calculate the mass concentration, which will be also saved in the table. And if you go to the right, there will be information about the GPS coordinates, so you will be able to see the coordinates of the patient. And you get the time of the GPS connection, so in case the patient is at home and he doesn't have the GPS connection, you get the date of the last data set on the SD card, and for sure you will get the coordinations. Back to the slides. Or to be great if you just share the live video I have sent to you, Alexandra.
Yep, I do.
I'm not able to see what you are seeing right now, but I try to say something.
The live video is running.
Alright, so at the beginning, this is just a display we're going to have in the final system. At the beginning, you see the logo of the project, and then you move to the first page where you get information about the coordinates of the vision. So it takes several seconds to get connections. Here you see you have 6 satellites, and get the time and speed from the GPS. You can see some information about the temperature, humidity, and air pressure. The mass concentration, actually the same information you have from here. I try to match, match, and you see that the particulate matter jump high. And next page, number concentration, the typical size of the particle in the air. You also get the information about the general air quality, the VOC, CO2, the NO2, SO2, also CO concentration, and O3 concentration. Then you get the time and date, which will be saved on the SD card. Back to the slides.
Yeah, wait a second. Okay, we are back on the slides.
Perfect. Slide number 9.
I think that's the one with the design concept, right?
Right.
Good.
So we also started to make concept for the final mechanical design. We will try to put all the system components inside 3 small boxes. Unfortunately, some of the components are relatively big, like the particulate matter sensor. So we need 3 boxes, 3 small boxes. We try to print a dummy system, see the red one on the arm, and the whole concept will be made like armband. And we will try to put all system components inside the sensors, the GPS module, and screen, battery, and so on. Last slide.
Yep, we are.
Yes, so actually we already done the big part of the project, but there are still some steps we still need to go for. So we still need to finish the mechanical concept. We're going to use injection module housing, and we still need some firmware updates just to reduce the power consumption of the whole system. At the moment, we can use the battery like for 1.5 days, and we would like to extend this for 3 days. We already built the first PCB design, but we need to cut it into 3 PCB designs for the 3 boxes. And at the end, you need to validate the system again with the housing, and for sure to make a user manual. That's it from my side. Back to you, your questions.
All right, thank you very much.
Thank you.
There's a question by Sophie. I'm not sure if how well you can hear the people from the audience. If you can't hear it well, then I will repeat the question for you.
It would be great if you can repeat that question. Can I hear it?
Hello? Do you hear me?
Yes.
Yeah, okay. Thank you. It's a very exciting topic. So I have several questions. What about the strategy to estimate the accuracy of the measurements? And one background question, what is the accuracy that we need to get information from this sensor for the application we have in the project?
Okay. So during the development of the project, we try to compare the results we get from our sensors with another system. We bought a measurement system from the company in Vega, and it's a professional system, and we tried to compare the results we get from our sensors with this system. And most of the sensors we have, they are already calibrated before, and we have a certificate that those sensors are calibrated already, and the calibration can be used for at least 2 years. So this is also a guarantee from the manufacturer that we can use this system for at least 2 years. But we have now the measurement system, and during the study it will be also possible just to make measurements to make sure that the system is still running as it should be.
Okay. So
I hope this answers your questions.
Partly, but I have the impression that from the experiences, from the intercomparison of several sensors like this can be very disperse, the results, and it can change maybe over time, at least for gases, for particles, I don't know exactly. So maybe it's good to have also a strategy that will consist to compare to reference monitoring systems, maybe sometimes, and then it doesn't answer the question, what is the accuracy do we need to get the information and to answer our scientific question? Because maybe it's not as accurate as the reference system, of course, but if we get information from that, it's anywhere usable. So that's an important question, I think.
I can also say some words to this because I was also involved. I mean, what we did is we went into the literature and looked at what exposomes we found that are known to have any kind of influence on the progress of, for example, COPD and CF, or especially COPD and CF. And there we had ranges, or from this we deduced ranges to look at. And from this we were deriving the remedial requirements that are shown here. saying, okay, these are the ranges we should look at, and actually what we did is we got the sensors with the highest resolutions we could. And I think we should also take like the hint you gave by taking the sensor again and again for calibration if it's needed, or just for checkup of the internal calibration the sensors have.
Yeah, and maybe I may add some additional thoughts we had. So you have to look for a compromise, because we are not able to build a system that has the accuracy that your lab systems might have. Absolutely impossible. We checked several different sensors, especially also for repeatability, and that's not in this presentation here. We rejected several sensors because they were not really good enough to be repeatable. Then we set up a system with a chamber where we could mix gases. Yeah? And as a reference sensor, one of the reference sensors, we put in the Strager sensor, because that's a very reliable sensor. That's a sensor also used, for example, in gas measurements for medical technology. That's indeed, again, not the accuracy you would expect for your experiment. But nevertheless, variation outside scene, that's something I think we can really measure with this system, with, I would say for such a sensor, a huge amount of sensors, different types. And in total, this will cost about, I think, 1,000 euro per sensor system. And that is something we could really afford with the budget we have. And that's a compromise we had. And where we have to look for is especially that the different sensors are comparable.
Thank you, Gerhard. I would like also add something that we, as I said at the beginning, we looked really to several sensors on the market, the best one available, and we bought about 35 of them and tested them all. And we selected the most sensible one of them. So the sensor we are using, they are worldwide the most sensitive available, or the most sensitive we could buy.
Yeah. There is another question from Patrice.
Yes, thank you. I will jump in. So first, thank you for this effort to build this prototype. It is we know that a very great effort. I wanted to go back to what just said Gerhard, because it's very interesting in terms of philosophy. He was talking, of course, in terms of accuracy. It's clear that you cannot be so precise as, of course, a monitoring device that is built for this with a lot of money. But you are talking, Gerhard, of a compromise. I have an alternative, I think, that we can discuss. This is qualification regarding environments. I mean, of course, you can have in mind that you have to make compromise because you have not the perfect accuracy, or you can also qualify the prototype or the sensor for some types of environments. I mean, it's also very interesting to say, for example, it's working, for example, in a peri-urban area, but it's not working in a urban area, or it's working in rural areas. Because, of course, when you are working, and it is normal that it is the start in the lab with control condition and so on, you have an adaptation of what you are able to measure with what you are simulating. But, for example, we are in Greece, so for example, I know that Spiros team has some station in the mountain ready for that. If you qualify, for example, that the prototype or instrument is working very well for, let's say, a Greek environment and not for Paris or Berlin environment, it's another option. And it's not a compromise saying, oh, it's qualified for this, and has to be developed for other environments. So it is just an alternative that I'm pointing out.
Could you get that, Basel?
No, sorry.
Patrice introduced the idea of qualifying the sensor for some certain environments. He is working with an environmental chamber being able to simulate certain environments, and I guess that's what you are suggesting to...
Especially natural environments, because when you are in natural environments, you have very fast variation that could affect, for example, the electrochemical sensors or whatever.
Yeah.
They could have constant condition or high variation.
Yeah, I think that's very interesting. We indeed have chambers for simulating humidity, temperature, and all these things, but that's a different story than having really environmental challenges outside, and therefore I think we should know.
All right.
And also, I have the impression that it's much more easy to trust the PM measurements from these sensors, and it is the most important component. So it's also a good point, of course. I don't know how you can use the other measurements. For example, I don't know if you plan to have this the information about the indoor and outdoor environments. Maybe the CO2 is usable for that, maybe the relative humidity, I don't know, but it's interesting also. And CO2 measurements are probably reliable, I think. And so, this is a complicated story, but with very promising information.
Wait, one more question here in front.
We've been talking a lot today about noise, incorporating noise into work package 2, but also to try to incorporate it into the animal studies. So my question is, could you also consider measuring noise in your sensor?
That's a good question. I think actually we could. Basel, I think we have to go in detail, but I think measuring noise is not that difficult. So I guess we should have a look what sensors are there available and implement it into the system. I think especially if the energy consumption is low, should be fine, I guess. Yeah.
Yes, it would be possible just to add a microphone to the system, and this will make it easy to get information about the noise pollution. So this is one important requirement for the project. Maybe it's still not so late to implement it.
Yeah, all right. Nice idea to introduce.
Thanks a lot for the suggestion, Meta. I think if it's feasible, that could be great, and really in the idea of adding from our common faults, and that would be really important. I've got a question about the refreshing of the measurement you're having in your software. What's the frequency of measurement? Every minute, every whatever?
This can be freely set. We can make it once a minute, once a second, once an hour. We just have to put into the program how the time interval should be, and then it can be done that way.
Okay. Yes, so we have two files inside the SD card. We have the first file where the measurements are saved, where the results are saved. Actually, that is an Excel sheet I already shared with you. And there is another text file with the time constant between two measurements. So it's something between 1 second and 10 hours. So the doctor or the one using the system can decide which intervals you have for saving the data.
The limiting component is actually the energy available in the device. The more data points you're saving, the more energy you will use. And depending on this, it's more or less a balancing how long do I want to use the device before recharging and how many data points do I need.
Thank you for the presentation. I want to say if maybe in the future we can correlate, for example, a monitoring station that uses microbalancing like TEM. How do you think we can correlate monitoring PM by microbalance and this kind of sensor? Is a discrepancy, or we can combine these two data, or for example, traffic which uses microbalancing and this sensor, as we can bind two data together, or it's difficult?
I think it's not too difficult. Gerd would know for sure.
So this sensor is a well-defined sensor. It's from a company I think most of you know. It's a Concession sensor. That means we have to characterize if we really have the right port to suck that in. My idea would be, since we are planning also to do some urban experiments with our volunteers, to compare that with nearby stations from the urban network. That could be a possibility. And what we could also do, try to get also more information on the accuracy of this measurement system talking to Sensorion. Yeah? If that is not sufficient, we have a lab where we could do these measurements. I'm afraid whether that is really that helpful. I would rather like to compare that, for example, with concentration you have in the streets, and you know the concentration measured by urban stations. Because if you start with artificial aerosols, the answer of the system, because it's an optical system, will be different.
We have one more question from the audience. Or in addition?
Thank you. No, just a comment again about the needs of the information we can get from the sensors. Very classically, when people are doing estimation of health impact within epidemiological studies, they are using, for example, model output or some fixed station data. And then already what would be interesting, for example for PM but other pollutants, is to estimate the variability that is induced by the movements and the different environments people are confronted to, and to compare to fixed or model measurements. It's already a first answer and it gives information. So.
Just one idea, we could also go into one of the simulation chambers. I don't know whether if you only are simulating gases, but as far as I remember, you're doing also particles, yeah? Just put one of these devices inside and look, compare with all your extensive measurements.
Yes. Yeah. All right. There's one more question from the audience. Or a remark.
Thank you for your presentation. I just have a naive question, let's say. I'm wondering, I take the advantage of the previous question. I'm wondering how it's possible with your system to quantify, for example, the impact of telephony and networks, wave networks, because we didn't talk about that, but we know that there is some cardiopathy because of that. So I'm just wondering if first you can make the link. And another question is, I guess that you're planning in the future to monitor patient. So I'm wondering exactly per people if you already evaluated the cost of that. And my last question would be the system. Is it possible to split the sensor from the system itself to improve the practical aspect for patients?
Okay. Do you want to answer, Basil, or do you want me?
Sorry, sorry, I didn't understand the question.
Okay, I think the first question was about electromagnetic waves. If, I mean, the sensor cannot do it yet. The question is if you can more or less easily implement the possibility of measuring electromagnetic waves.
This would be possible, but it will be much more complicated than just getting the noise. So, something we can still do if we get the time we need. But it's a little bit complicated. What will be complicated also to measure it. So, to compare it with the reference and to do the whole validation work. So, but it's something we've already done also for other projects.
Yeah. Okay, on your second question, the costs, one of the sensors is around 1,200, and once it's built, it doesn't have actually running costs apart from the electricity. Or was it something different you meant on that?
No, that's what I mean. And the last part was about the sensor.
Yeah, I mean, what we did is actually we had all the sensors by themselves to see if it works alone, and then Basel is in the process of combining all the sensors. I mean, you could take them apart once again, but we did the testing, the validation, if necessary, for the sensors in a separate mode, let's say, or was it a different question?
Yes, partly, because I think that it could be interesting if your sensor in the future will be with the biomaterial to be able to be more closer to the nose or something, and then the patient can wear it very commonly, let's say. Yeah.
You mean the question is if you can be able to measure what is exactly breathed in, for example, or?
Yes, I'm wondering if it's possible to do that in the future. I think that right now no. But if to be more closer to the through, because you know.
In a way, you can do it. I think you would need the sensor. The sensors themselves are not that big, but you would need some kind of holding system, which wouldn't be very helpful to wear in everyday life. I mean, and what we are thinking, what different positions where the sensors could be. Also what is feasible for a patient to do in a study, and for us it seemed like the most sensible thing to have it on the arm. It's more or less the air the patient will breathe, and it's not in a bag or something which is sitting on the bag and being inside. It should be more or less the same air that is then evaluated. The patient is also breathing.
Okay, thank you.
Yeah.
I have a question. Also, thank you. And I think also the simulation chamber are good tools and good infrastructure to test the sensor, because we can test all the gases you are measuring, but also the particulate matter. So all kind of particulate matter can be tested in control conditions. So it can be a good idea to use the chamber to test this kind of instrument. And I have a technical question about the particulate matter measurement. Do you think to put a fan, or how do you want to make the sensor close to the sample, especially for the particulates? Because if there is a box, maybe the particulate, it's not so easy for particulate to go too close to the sensor. So
yeah. I think the particulate matter sensor from the company Sensorion is already having a fan inside, right, Basel?
Right, there is integrated fan and using the laser scattering concept.
So we are taking care that the air which is supposed to stream in is not obstructed in any way, and therefore the fan from the sensor itself should be sufficient to deliver the gas to the sensor itself.
Okay, so it's actually an active system.
Yeah.
Thank you.
All right, I think we're done now for this part of WP3. Thank you for remarks, ideas, and so on. And thank you also very much, Basel, for your more or less free speech. speech here with my presentation. Okay, bye-bye.
Bye.
Those are more my stuff. I think you can use that one here. That should work. I think you can't use it for clicking, but yeah, there you go.
Thank you. Hello, good afternoon, everybody. First of all, I would like to thank you for inviting us to this nice city. So I am Meran Koshit from KU Leuven, Belgium. Today I am speaking about the work package 3, task 3.2, about the current measuring capabilities of biomarker sensors. So in general term, a biosensor is actually composed of a receptor layer, which can be have a natural origin, like nucleic acid, enzymes, antibodies, or synthetic, such as a polymer. That these receptor layers can selectively bind to the target molecules in matrix. This layer is integrated to the transducer, which converts receptor-target interaction into a measurable signal. Actually, MIPS, or molecularly imprinted polymers, and optomers are two most important bioreceptors nowadays that we are using in biosensors. MIPS are synthetic material. They are suitable for small molecules. They are made of monomers polymerized in presence of templates. They are resistive in harsh environments such as low pH or high temperature. For Remedia project, actually, we are collaborating with Fraunhofer ICT, which today Isabel from the group of Dr. Jürgen Horteland will further explain about her part in MIPS after me, and then afterwards regarding the optomers, which are, let's say, which are selected via a complex system from an oligomer pool, and they are good alternatives for antibodies, which will be provided in this project by Dr. Markus Menger from Fraunhofer EZBB, and he will explain about this part later on. At the start of the Remedia project, and since the both COPD and CF are complex, have a complex multi-biomarker pattern, therefore, we had a meeting, and then we discussed with all the partners from Fraunhofer Institute, and we decided to use hexanol, 3-nitrotyrosine, and neutrophil elastase as, let's say, model biomarkers for COPD and CF biosensing unit. And then we decided that we make a molecular imprinted polymer for hexanol, both a MIP and optomer for 3-nitrotyrosine, and an optomer for neutrophil elastase. We did a literature study to see that what is the range of these biomarkers that can be detected in the XL breast condensate in patients and healthy people. And then we found that hexanol is in the range of 14 nanomolar in healthy patients and 63.5 nanomolar in COPD patients, but unfortunately, at least I could not find value for CF patients. and for 3-nitrotyrosine in healthy people is 3.5 nanomolar, and for COPD patients 5.5 nanomolar, and in CF 111.8 nanomolar. Regarding the neutrophil elastase, it's quite low at around 61 picomolar for healthy people. I couldn't find a value for COPD, and for CF patients around 132.2 picomolar. So since we decided to use exhaled breath condensate of the healthy people and patients for this project, we developed EBC collection tube device for EBC collection. So basically it is two stainless steel straws that are assembled inside an aluminum core, and then we keep this metallic part inside the freezer at -20 for, let's say, about 5-6 hours could be enough. And then after assembly in the holder, and then a patient or healthy person can breathe through these straws by breathing at around 6 minutes, like 10 times per minute. We can collect at around 1.5 to 3 ml of the exhaled breath condensate, which depends on the situation and the person, and also the humidity and all these factors. So in our group, actually, we are also collaborating on the molecular to produce molecularly imprinted polymers, but our technique is based on electropolymerization. Electropolymerization actually divides to two different techniques: chronoamperometry and cyclic voltammetry. In very simple words, chronoamperometry is, in chronoamperometry we actually apply a square wave potential to the working electrode. And this technique actually is a time-based technique. And then we send this potential for several cycles to make the polymerization over the electrode. In cyclic voltammetry, we actually send a sweep of the potential to the working electrode at a certain, let's say, at a certain rate, predefined rate. And again, we will have the polymerization over the electrode. But electropolymerization seems very simple, but it's much more complicated that we look at the techniques, because it seems it should be very easy and the device can do it for us, but it's much more complicated in the basics. Actually, we found out that we looked over the oxidation potentials of the target molecule that we started with 3-nitrotyrosine. The oxidation potential here is 600 to 750 millivolt, which means that at this potential we will have oxidation of 3-nitrotyrosine molecule, and then the molecule will change. And then the pyrrole, which is one of the monomers, the oxidation potential is 900 millivolt, which is far higher than the oxidation potential of 3-nitrotyrosine. Dopamine is 600 millivolt, which is very close to oxidation potential of 3-nitrotyrosine, and phenol is 350. It looks good, but the polymer is not very efficient for polymerization. Therefore, we came to the idea of hybrid polymer, which consists of polypyrrole and polydopamine. The main advantage of this hybrid polymer is that it requires less voltage for polymerization at around 500 millivolt, which is less than the oxidation potential of 3-nitrotyrosine, makes a much better adhesive polymer, and also makes a more resistant polymer against acid and base extraction. For electropolymerization, we have this autolap potentiostat. Then this is our polymerization holder. This is our chip, will fit inside this holder. And then we used the technique of coronoamperometry for the polypyrrole and polydopamine polymer. Actually, for electropolymerization, we gave 500 millivolt potential for 30 seconds and for 15 to 20 cycles. And as you can see, this is the concentration of pyrrole, dopamine, nitrotyrosine as target in 0.1 molar KCl with pH 6. Then we did a template extraction with a chemical method that we incubate the polymer layer in sulfuric acid for 20 minutes, then in sodium hydroxide for 20 minutes, and then washing steps in molecular water for 20 minutes. Just as a reminder, this is the sketch of our remedial sensor, and we have the impedance chip with 4 spots. 3 spots will be one for hexanol with the MIPS, 1,3-nitrotyrosine with either aptamer or MIP, and one biomarker, other biomarker, which is neutrophilic elastase here, which is with aptamer, and then one reference channel with NIP. Then we put a reservoir over our chip after the polymerization and attachment of the aptamer to the electrode of the chip, and then we put it in the holder. This is our biosensing unit, and then we push it inside the device, and there is a handle, and with the handle we push the chip to the electric connectors, and then from the top we will inject the liquid, which is EBC in this project, and then this is our miniaturized impedance analyzer, which is from PalmSense, and it's called PalmSense MS.Pico with a multiplexer, and then which is inside this box. At the start, we have to see that if our sensor by itself without any polymer or any aptamers is working well, we did the biosensing unit calibration measurements in 1x PBS, and as you can see in this impedance phase and also nitrous plot, that all 4 spots behaving very well and very stable results we have from the calibration measurements for the blank chip. Then we did the electropolymerization, and we make a molecularly imprinted polymer for 3-nitrotyrosine, and then we compared it with a non-imprinted polymer. And the results were quite interesting. We did the impedance measurements with frequency sweeps between 10 Hz to 500 kHz. The excitation voltage was 60 millivolt, and the measurement time per concentration was 60 minutes. At the room temperature, we have a stable, a room with a stable temperature at 19 degrees always, and then the results are shown here at the frequency of 340 Hertz, which is a very nice frequency, especially for this project, that we think that at the end also we will analyze the results at this frequency. And then, as you can see, this is in 1x PBS, and then after increasing all the concentration, the NIP, non-imprinted polymer, is not really responding, but the MIP stepwise responding. But the baseline for the NIP and MIP are different, which is quite logic, because in the characteristics of both polymers are different a little bit inside, because the MIP has more, let's say, a spongiform structure rather than the NIP. And then by correcting the baseline, as you can see in the panel B, you see that the NIP really does not respond that much, but stepwise by increasing the concentration from 100 picomolar to 1 macromolar, we have an increased response for the imprinted polymer. So in this panel, panel C, we just made an average for 3 last stable points after at the end of 16 minutes measurements, and then as you can see, we see a dose response curve for the MIP and also for the NIP, which is, we have a huge, let's say, significant signal for the MIP rather than the NIP. And then on the D panel, we subtracted the effect of the NIP for the unspecific bonding from the MIP, and then we can see this differential dose response curve at the right side. Also, we did the surface characterization for MIP and MIP with atomic force microscopy, and then we found out the thickness of the polypyrrole polydopamine layer is around 5 micrometer. Still, the thickness is high, but we are working on it to decrease the thickness and then see what is the effect of the thickness on the behavior of the polymer and the response of the signal. But up to now, we measured everything in the standard condition, which was 1x PBS. But we are measuring at the end in XL burst condensate. So as you can see, I did a conductivity and pH measurement for, especially for EBC, which is it was very important, and some reference measurements. And then as you can see, the EBC that my promoter, Dr. Patrick Wagner, donated this EBC, the conductivity is too low. But this is one drawback of measuring in EBC with impedance spectroscopy, because we need ions. Then we came with the idea to mix EBC with 1x PBS, and then we will at the end measure the mixture of 50% EBC plus 50% 1x PBS, which shows a better conductivity results, and then we will measure in this mixture for the biomarkers in the real patients. So furthermore, we made a new polymer, and we started to measure with the MIP inside in the mixture of the EBC and PBS. But this time we spiked the liquid with different concentration of 3-nitrotyrosine. As you can see on the left side, you see the pattern after 16 minutes, after injections for 16 minutes. And then on the right side, you see the dose response curve for the average of the last 3 points that we have. And then you can see that we have a very nice response again in a mixture of PBS and EBC. We had a little bit problem with the NIP this time, but we are working. The problem should not be that much difficult to be solved, but the NIP behaving very well in this situation as well. So a summary at the moment, because the data that we get from impedance measurements are quite large, and we have to do also some kind of fitting, and we are now busy with the EIS equivalent circuit fitting for the MIP and NIP composed of polypyrrole polydopamine. Then we will see the different, we want to, based on this fitting, we can have the different components, electrical components or equivalent electrical circuit for this MIP and NIP layer. And then also we are doing the polymer characterization with AFM, SEM, and DECTAC, and to optimize the polymer thickness and the structure. Also, I have a master thesis which already started for MIPS electropolymerization for hexanol. That will be basically the same procedure at the moment, and then we will see how will be the results in the coming months. And then I am working on the optimization, the extraction protocol using FTIR technique. We are working on the improvement and establish the sensor calibration for 50% EBC plus 50% 1xPBS. And I have to say that all the components of the second biosensing unit is ready, and then they are under assembly to be delivered before end of March to Fraunhofer ITEM. At the end, I would like to thank my colleagues, Professor Patrick Wagner, our doctoral student Surush, which is expert in impedance, and he is an electrical engineer, and our master student which works on the hexanol MIP, and Mr. Werner Niefs, which is our technical guy that's working on our biosensing unit and assembly of that. Thank you very much for your attention. Yes.
Thank you, Marianne. I have a question regarding CF patients, because you know there's pH, acid pH, at least in the salina. I don't know how far it can affect the EBC, but maybe that's some point of well, be careful of that, you know, for the calibration and so on. That's something to consider with these particular patients.
Yes, that's also important. Also during the lunchtime, I was discussing with the colleagues. Actually, the pH is very of the EBC is very special. Is very sensitive. So the CO2 gas dilution in it will affect. Actually, this is the EBC that Patrick donated, and I found it to be acidic, but it should be more alkaline in a healthy person. But this is very special. Either it can be the gas, which is the CO2 gas, which is diluted, because also this is a freezed sample for around 4 to 6 months ago, and then we did the measurement. This can also affect also the type of the diet of the person. For example, a person that drinks more acidic liquids, like let's say cola or other kind of beverages, has more acidic EBC. And also because also Patrick has a background of asthma, taking some medications, also that can be happen. But yeah, this is something that we are really careful about that, and we have to take into account even for the patients. Yeah.
Yeah, how will you manage that? I think with Ralph's patients, CF patients, how will you calibrate or adapt the system to this kind of particular patient?
Yeah, actually, you mean the pH, especially the pH measurement. How we? Yeah, this is actually also is important, that the kind of probe that we have to use on these kind of samples. I don't know. I have to check either the probe that we have at the moment is the best probe for the best pH probe that exists for this kind of measurements, because I see that some special probes exist for this small amount samples. And at the moment, our system is calibrated, but in a chemical lab, but not really for this kind of patients. But we will improve it. So I have to first search for a good probe, and then we do the degassing And then, because degassing also is important, here I didn't do the degassing of the sample, and then we see that what will be the results. But in healthy patient, in a healthy person, we have to expect a pH of around 8.1 to 8.2, so it will be, let's say, a standard pH. Yeah.
Okay, thanks.
I don't know if you can answer the question yet, but in your opinion, what is the delay between the measurement with the patient and the moment you are measuring all the data? In other words, do you have to make the preliminary to the patient and freeze it and then send it, maybe, I don't know, all the preliminary, or do you need to have the two sensors to?
Yeah. Actually, at the moment, what we are doing, because we are a bit far behind the schedule, and then we don't have the complete device, and biosensing we need to do that, but in the future we hope that we can do maybe at least at the same day without the freezing, and just we put the samples directly from the patients inside. If it's possible, I don't know, or either we keep it for a short time, not a long time.
So that means we need to have two devices in two different place.
Yes, we will have to, actually the idea is that we will have three devices, if it still is the correct, is still the plan. I think that this is still the plan, that we have three devices, one in Leuven, one in Fraunhofer, and another one in Paris. And then all can be separately work with the program and everything, and then we will do a training, and then it will be done by a person in each place, and it can be fast at the same time, but yeah, a little bit maybe takes time, but not too much, and then it can be right away after taking the samples. The idea is that.
It's for the two presentations, but do you think in terms of clinical trials, in your mind or in your discussion, do you think we need to go with a step of validity, feasibility? That means it depends with the patient when you are doing the trials. Is that what you want to measure, like a difference and with, I don't know, many patients, or do you need a step of validity, feasibility, as you have done with not patients but volunteers? I don't know for the two if we where we are now.
Yes.
Is that okay? So you agree?
Yeah, he will. Julian will speak about that afterwards. Yeah.
Okay, maybe the next presentation.
Thank you very much.
Good introduction.
Okay. First one?
Don't worry.
Okay. So, hello everyone. It's nice to see you again after 2 years in person. So, my name is Isabel Wilhelm. I'm from Fraunhofer Institute of Chemical Technology. I'm a chemical engineer there. And normally we're dealing with military topics, but Remedia is one of our civil projects. And I will give you a short overview of what we have done now. So, as Mera mentioned a lot before, I'm giving you a simple scheme from the principle of a molecularly imprinted polymer. Here is a molecular imprinted layer as a synthetic receptor for a targeted molecule. So it's analog to the natural antibody antigen system, and the recognition is based on size, structure, and functional group. In this case, you can see here the layer which is targeted for the biomarker, and the shape fits perfect to this molecule. So at Fraunhofer ICT we're working with two selective materials. The first one is the acrylamide-based MIP. It's an organic monomer, and the thing is you have to apply an anchor layer on the sensor surface for the binding from MIP to the sensor layer. In this case, or mostly cases, it's gold. And the second material we're using, it's a solar gel MIP. It's kind of inorganic material, and we have a good adhesion on the surface without an anchor layer. And the big plus at the solar gel MIP is that is temporarily really stable. So the next thing, the coating methods. We tried a lot of coating methods to apply our materials on the sensors. But we have chosen two methods. The first one is for the acrylate-based MIP, and we apply them with a nanoplotter. This one puts some really small droplets over the sensor area. And for the solar gel materials, we coat it with electrospray. Oh, there's something missing. Here it is. So you put a solution through a needle and apply voltage to obtain a precise spray jet. But you have to use a stencil for accuracy application. So normally we use a quartz crystal microbalance as a screening tool. And normally we did it in a gas phase, and in this case we are measuring in the liquid phase, so we bought a new system. And it's based on the resonant frequency of the oscillating crystal that depends on the mass of the material adsorbed on the surface. So when we're having a MIP layer on the quartz microbalance, and you absorb the targeted molecule, so the mass is changing and the frequency is changing. This is a good method to test the molecularly imprinted polymer regarding its absorption behavior. So we pre-selected layers were applied on the impedance chips we received from Mera. And we sent them to Mera, and he measured them for us, as he explained in the presentation before. And I would like to show you one result from a solar gel MIP. It's targeted for hexanol. And so the concentration here is missing, but it's in the range as before, from 100 picomolar to 1 micromolar. And the important thing is here the impedance increase. That's important graph here. As you can see, the non-imprinted polymer, which it's not targeted for a molecule, has the same behavior as a free spot sensor area which is not coded. So that's really good that there's no response. And there were 4 parts of the sensor. One is free, the second was coated with a not imprinted polymer, the other 2 areas were coated with hexanamib. And as you can see, both hexanamids have the same response. And what's really important is the ratio between the MIP and the NIP. And you can see a really good difference between. So our next steps. We want to implement spectroscopy system at Fraunhofer ICT. So the aim is that we can react faster in the development process and we don't have to send our chips to Meran. And what's super important that we optimize our coating method, and as well as the sensor layers regarding reproducibility, absorption capacity, and selectivity. Any questions?
Okay. Skip this. Okay. Hello to everybody, and thanks for the organization here of the nice meeting in Patras. And I will come to the last part of the sensor toolkit. So I'm coming from the Fraunhofer Institute ICBB. It's called for Cell Therapy and Immunology, and it's branch Bioanalytics and Bioprocesses. We are located in the near of Berlin in Potsdam. You see here the building and some places of laboratory. And we developed aptamers for the biosensors, so we'll make a short excursion what aptamers are. So thanks to Meron for the introduction of the biosensor. He has mentioned the aptamers. And what the aptamers like antibodies, I think antibodies everybody knows now after 2 years of Corona time. So many people have learned about biochemistry and things like that. And aptamers are single-stranded DNA or RNA molecules that make a specific 3-dimensional structure that can bind and a target like a key open the door. And you can see here an example for an aptamer. In the background there's a protein showing in the charts division, so red is negative and blue is positive, and you see here this aptamer, it's an RNA aptamer, that it's find a nicely epitope for binding that is more positive charge on the surface. That is clearly because in DNA or an RNA have a negative background on the phosphate background. And aptamers can make in principle against every kind of target, so from ions to nucleotides, small molecules, or to proteins, and also against virus or cells. And they have a high specificity and high affinity like antibodies, so you have binding constant in the range of the nano to picomolar range. And that Meron have shown, so I can make shortly, that there are 2 targets that we have chosen for the aptamer generation. One is the protein nitrophil elastase, and the other one was a small molecule, a 3-nitrotyrosine, and you see here the structures of the molecules. And we have started the selection with a protein, and I'll show you some results to that. Firstly, how did an aptamer generation works? You start with a library, and in this case you use a library that has two converged primer regions, so that you need for amplification of this DNA, and in the middle there's a randomized sequence. So we use in the case 50 to 18 nucleotides that are randomized. That means when you use a 40 nucleotides long randomized site, you have 10 to 23 possibilities of sequences that you started in the nucleic acid in the aptamer generation. And that you take in the process that is shown here. So you have your target molecule, and at first what you've done, you make an in vitro selection where you incubate this library with the target molecule to get enrichment of molecules that binds to the target molecule. Then you make a sequence analysis that may be by NGS, of course, that you have in the morning. So you get a high deep sequencing information, and then you synthesize candidates that can aptamers binder for the target and characterized by the binding constant, by the affinity and also the specificity to the target. And then you can make optimization, modification for immobilization on the surface of the sensor, for example, and then you make the synthesis. I show you here in more detail the process of the in vitro selection, so the core point of the aptamer generation. So Marion have also shown it in the beginning. You started with this pool, with this library, incubated with a target. Then you have, in the beginning, of course, only a few molecules that bind to the target, the others don't binding. Then you separate the binder and the no binder by washing steps. Then make isolation of the binder. Then you make an amplification. Therefore, you need this constant enrichment to make PCR, polymerase chain reaction, to get a double strand and make again a single strand. And this round make several rounds, up to 10 to 15 selection rounds, to get an enrichment of binders. And you can control this process in this case by monitoring managed with different methods. And the things in the red circles are automated in our system by using magnetic particles that we can transfer from tube to tube and make different reaction steps there. And here you show the managing of the selection process of aptamers against the neutral elastase. You have also the PCR, and what you see here is you look to the last washing step and to the beads in the end, and between that there's a lucent step. And when you get a high signal here and no signal in the wash step and on the beads, then you have an enrichment of binders to the target molecule. And the other point is to look to the diversity of the assay. I've mentioned that I've told in the beginning they have 10 to 23 different molecules in the beginning, and you want an enrichment of binders, and in the end you have 10 to 5 or molecules in the end. That you can take by this assay in the beginning. When you have in the plus lane no signal, you have a high diversity, and here you see the selection rounds different from 11 and from 12, and you see here in the plus lane a signal. That means that there's an enrichment of molecules that bind to the target molecule. And so we can decide to go to the next step, and that means NGS sequencing by Illumina. And I show you here the results. I will not go in detail in this table, but I only show you can here quantification, the enrichment of nucleic acids. You see in the beginning, you have over 90%, and in the end we have 50 to 20% enrichment. That's very high. What you also can see is here the sequence length. It's not changed by the process, so it's in the range of over 80-90% and in the same length, so only a little deviation of 1 or 2 nucleotides. And what you also can see here is the enrichment of sequence. So you can see here in the end you have 4 or 5 sequences that have a repeat over 10,000 in the end. So it's a high enrichment. and also near 20 to 30 management of repeat of 1,000 to 10,000. And that you can cluster to sequences that are shown here by bioinformatic analysis, that you look to the sequence in detail and there are similar motifs in the sequence. You see here, this cluster is very similar. It's only one or two nucleotides that are different but always the same. Or you have a sequence in the beginning is different but in the end it's the same sequence, and so on and so on. And then you can pick up defined sequences for analysis and looking at good aptamers by characterization measurements. As you show here, they have identified potential aptamers in the red bars that we have chosen, and then we have made the synthesis and validation of these candidates. And I show you here the first experiments of that. So we have different assays for testing the affinity. The first, a very simple one, is a fluorescence assay. There we're working with microtheta plates, so we can make a screening and can test several nucleotides in parallel. So what we are doing, we couple the target molecule on the surface of the microtheta plate, incubate with an aptamer candidate, and after incubation we wash very intensive, and then we take a dye inside the solution that only bind to the nucleic acid. So we can see very nicely is there a binding to the target or not, that you can show here. Here you have the surface with the target molecule, and you see the high barrier, and here's a control, and it's much smaller, and you see there's a binder. And what we also have used is another kind of measurement for looking for the affinity. It's called EMSA, or electric mobility shift assay. What you do done, you have on one side the nucleic acid that you can detect in a gel electrophoresis, and on the other side to incubate the DNA molecule with the target molecule, and then you get a complex of the target molecule and the DNA, and normally they have a different mobility in the gel that you can detect it by a shift like this. So this is the DNA alone, this is only the protein that habits, and when the DNA bind to the protein, you get this shift, and you can see here. Here's the library, the start library. There's no shift when you take the protein inside, but then this clone that we have identified, you see here the shift in the line here that is from here to here, and you see there's binding to the target molecule. What we also can do, we can quantify this binding constant, and for that we use surface plasmon spectroscopy, SPR. In that case, it's also that you couple the aptamer on the surface of a gold plate, and then in the microfluidic system, the target molecule go over the chip. Whereas the binding, then you get a shift in the frequency of the light that is reflected on the surface of the chip. And that can you measure it with different concentration of the target molecule, and then you can fitting that and you get a binding constant. And in this case, we get a binding constant of 216 picomolar. That's very high for an aptamer. And in order that we have a low concentration of the protein in the patient probes, that's very nice that we are see a good chance to detect the lactase in the chips in the sensor system. So next step, what we want to look for further aptamers in our pools. Perhaps we get an aptamer against an epitope. We can make a sandwich assay, and we have defined this aptamer, and also we transfer it now to the biosensor system, to Meran, to use it in the biosensor. And also we want to start again the second aptamer target solution to get an aptamer against 3-nitrotyrosine. So thanks for your attention. That is the division I'm working, and this is my small group who make aptamer generation. Any questions? Okay.
Hello everyone, my name is Julian Merek. I work at Fraunhofer ITEM as a study physician. I joined the Remedia project in the last year in the final design for the first trial for the biosensor data. And I have a two-part presentation and will present you the first study we did for the EBC, the exhaled breath condensate collection, which will be used with the biosensor. And I also want to propose a study design for the upcoming trial where we try to combine biosensor and environmental sensor data. So what was the idea for the first study? Well, we knew there are these three parameters we will measure, and of course the input for the sensor will be exhaled breath condensate, and we would need some other samples to cross-check these results. And so we decided that we can collect volatile organic compounds, and we will find the hexanel in the gaseous phase, and also induced sputum, which is something I will explain a little bit later. And we can use the sputum or the supernatant from the sputum to measure 3-nitrotyrosine and neutrophil elastase. Furthermore, because we want to know about inflammation in the airway, similar maybe to something we find in COPD, we added as an experimental condition an ozone exposure for the healthy subjects. And usually subjects that go into the ozone chamber for 3 hours and will be exposed with a mediocre level of ozone will have a neutrophilic airway inflammation that is over after 24 hours. We added some parameters and measurements we collected for our own research interests and also to complement anything that might come up in work package 3. So the overall objective of the trial was of course to collect biosamples, and there were quite a lot. And this translated into primary endpoints. Of course, we will need the sputum, which is also used as a measurement if the ozone exposure was correctly performed. And of course, we need the exhaled breath condensate before and after ozone exposure, and maybe one more time point. We also had some exploratory endpoints, which were basically all other samples and measurements we collected. What kind of patients did we need? Of course, they should be healthy patients. The age range was from 18 to 50 years, and they had to be non-smokers or have at least a very low smoking exposure over their life. The lung function should be normal, and for the sputum induction, we pre-checked if they produce enough sputum so that there are enough cells we can evaluate under the microscope later. Anything that would put the subject at unnecessary risk, or anything that would interfere with most samples or measurements would lead to an exclusion of the subject. There shouldn't have been any active allergic rhinitis within the past 5 years, and no acute infection before the trial, and also no reason to intake corticosteroids via any route. This is the study flow chart. What you see here in blue is the ozone exposure over 3 hours. This is the experimental part of this study. I left out some thing we need in the screening period. There are a lot of procedures performed to check if it's safe for the subject to join the trial, some standard measurements we take into the trials. But basically what you see here are all the time points where we collected the interesting samples. For example, the EBC was collected at one different day during the screening and before subjects went into the ozone exposure, directly after they left, and 5 hours later. We know that approximately 3 hours after you leave the ozone exposure, so this is the time point 6 hours, The neutrophilic reaction in the induced sputum is at the maximum, so at the peak level. That's why we set the induced sputum for the 6-hour time point and try to put anything else as close as possible. And just that you get an imagination what we did at Fraunhofer item. The subject is in a chamber where he or she is exposed to ozone, and you can see that there's something like a B-cycle ergometer, because the subject has to reach a set ventilation rate, which we find out during the screening phase with an exercise test. And then they stay in there for 3 hours and intermittently perform exercise every 15 minutes. For the induced sputum, you nebulize a saline solution, which is then inhaled by the subject. I spared you the image of what the subject produces after this. It's a lot of saliva in a dish. But I gave you a picture of what we are interested in the sputum, and there are some plugs inside which then can be evaluated under a microscope. You can count the cells or freeze it for later analysis. The volatile organic compound sampling was quite simple. Subjects exhale into aluminium reservoir for 5 minutes by simple tidal breathing, and afterwards the result is analyzed in with a GCMS. You already saw the exhale breath sampling device, which was provided by the team from KU Leuven, and subjects were required to breathe into the 2 straws. They were pre-cooled, and there's a sleeve around it so the subject doesn't freeze, and there are also rubber mouthpieces to protect the subject, and anything, so the subject breathes in through the nose and out through the mouth, and on the inner wall of the straws the condensation then freezes, and afterward it can be collected in tubes. Oops, this was one too much. So, I left out a little bit what we also have done in the trial. We collected some more samples, but these are the most important for the evaluation with the biosensor. So where are we right now? We submitted the study documents, which is a requirement from German physician law, in July 2022. And after a while we got an answer from our ethics committee. The responsible one is always the local ethics committee for research projects involving humans, and they had no concerns for the conduct of the trial. After this we had the registration in the German Clinical Trial Registry, which is ICMJE approved, and could directly start after this with our first patient on 22nd October 2021. And after almost 3 months we concluded with the last patient. We planned to measure 10 patients, and as you know, this all takes then time to analyze the samples, so the analysis is still ongoing, but I have some preliminary results. We screened 11 subjects, so one was not suitable for further testing. There were no serious adverse events, meaning that there were no really bad medical situations where the subject was required to go to the hospital or anything related to the procedures. And we successfully sampled all the primary and exploratory endpoints. So now we have a lot of data, and I want to present you some preliminary results. It's mainly about checking if everything we planned worked correctly. This is the analysis of the sputum cells, so the cells are simply counted and then compared to the relative amount of cells. And here we see that at the baseline measurement, which was done during the screening phase, and the measurement after 3 hours in the ozone chamber, the neutrophils from a relative perspective have increased. And well, we had some unexpected results, because for 2 subjects the value decreased. And furthermore, something we cannot explain right now really well is that there was a high baseline level of neutrophils seen in most of the subjects. Compared to the neutrophils, the macrophages usually decrease after ozone exposure, and we also saw this. As you can see, we tried to test for significance both values for the neutrophils and for the macrophages are approaching significant. I talked this through with our scientific expert Olaf Holz, and he told me that we can assume that the ozone exposure worked as expected. With a sample of 10 subjects, you're a little bit lucky in the end if it's really significant. But from the trend you see that the expected results are there. We also saw a decline in lung function, which was maybe not due to inflammatory processes, but due to the subjects, they had some symptoms which were reported in a questionnaire, and the subject experienced a little bit of chest pain during deep inhalation, and this prevents you from deeping in really breathe and performing during a lung function as you expected. So the decline in lung function, which we see in some subjects after the ozone exposure, might not be directly related to the inflammatory process, but more to a neuronal psychological mechanism. On this ozone symptom questionnaire, we handed out several time points exactly before, right after, and 3 hours after ozone exposure. Subjects reported some symptoms, but most of them were assessed as mildly, and something like coughing, shortness of breath, and exhaustion were recognized. Some other symptoms were not recognized at all from the 13-point scale. I will skip over this because we are already over time, and this is maybe the result you are most excited about, the hexanol measurement in the volatile organic compounds. This is the automatic analysis. We haven't looked into it into more detail right now. This is the baseline from the screening. This is directly before ozone exposure and directly after, and then 2 to 3 hours after the ozone exposure. It's not clear we can see any trend. We haven't tested it yet because, as you can see, there are some outliers, and we will have to check for these first in a not in an automatic analysis. So the further steps for the analysis are the evaluation with the biosensor. We have all the EBC pre and post ozone exposure and from the screening phase ready. And of course we will analyze the hexanol further for concerning neutrophil elastase and 3-nitrotyrosine. We will see what are the results of the biosensor, and then we can estimate or check with ELISA in the EBC samples if still something is left. And we also have the sputum supernatant from the induced sputum procedures if there's not enough material. So for the next trial, there's a lot we have to keep in mind, and these are mainly anything you heard about Remedia in the morning. Where does this project go? What do we want to find out? What are specific objectives of the work packages? And overall, we have to keep in mind the work package objective 3.5. Show correlation of biosensor signal with environmental sensor system in a clinical challenge setting. And of course the overall goal of work package 3, measure selected air pollutants together with specific biomarkers. But if we want to do everything of this, we have a trial we cannot do because we would require to have a long-term observation study. So we're talking about probably over 1 year with 100 subjects in parallel from all the interesting groups, COPD, CF, and of course healthy controls. We would have to frequently collect EBC and also have an ongoing analysis of the environmental sensor data, and then retrospectively analyze the interesting or relevant cases. And as you might think, this would totally break the subject. So what is something we can do right now and we can do in our next trial while keeping in mind all the goals of Remedia? Well, Remedia wants to assess something that is in the real world. So we propose a real-world environmental exposure study with healthy controls and COPD subjects. And we would set as the objectives of this study to assess the impact of different real-world exposomes on non-smoking healthy subjects and COPD with the environmental sensor and the biosensor. For example, these exposomes could be something like close to traffic, in a park, in a forest. There will be pilot studies where we'll define these different sources for the exposomes. And also with the sensors we have the opportunity to describe something like an everyday exposome of COPD subjects and healthy controls. The intervention that I would like to propose is not something like an LPS or ozone study again, but real-world exposome exposure, also on consecutive days to have something like a cumulative effect of such an exposome. And of course, we would randomize subjects in a crossover trial to minimize the variability. This was something like a timeline. So here's the exposome 1 and exposome 2. Subjects are exposed on consecutive weeks and visit the source of the expected exposome for several days. We would collect EBC before and after the exposure starts. We would have continuous environmental sensor data, and we would also add volatile organic compound measurements, behavioral questionnaires, and particle measurements and sputum measurements at the start and the end of the week. And if we would do this, what would we get after all? Well, we would have a lot of data, and we would be able to correlate the data from the biosensor with what we collect from the environmental sensor. If we have this everyday exposome, we can describe the exposome for COPD subjects and for healthy controls. And we could assess also the real world, or otherwise an exposome we find in the real world, and see if this has an impact on the measured parameters. Okay, that's it. Thank you for your attention. And are there any questions? Yes. Microphone? Oh, okay.
Thanks a lot for this presentation. I saw that you have in mind to assess level 1 and 2 COPD patients. Do you believe you will see something with this kind of mild COPD patients, or would it be interesting
more severe?
Yeah, to have more severe patients.
We were discussing this internally, and if you want to have more severe COPD patients which have more progression in their disease, you should keep in mind that they have to be able to participate in the study. If you do a real-world exposure you have to go out. We proposed 4 hours. This is still open for discussion, but we have 3 hours in the ozone chamber, so whereas a controlled environment, so maybe 4 hours for a real-world environment are quite feasible. They have to walk around and perform some intermittent tasks, so they can deeply breathe in the exposome. And from my experience, it will be hard with COPD subjects where they only can walk for like 500 meters, have to stop. I think it will provide interesting data. But even, I think the more severe you have the disease, the more, well, the more variability you will see. And then you will need more and more and more patients to have some effect after all. As you might have also seen, we have more healthy subjects planned than COPD patients, not because it's that hard to find the required COPD patients, but when we do a real-world exposure, there might be, we cannot assess the effect right now. Otherwise, we would have to do more than one study and split it up into several pilot studies, but then I think we would get over the planned time. And from the planning right now, when you want to include healthy subjects and COPD subjects in one study, you have to account for the mobility of more severe COPD stages. Yeah. This is the main rationale behind including goal 1 and 2.
And how will you choose the different exposomes, and how will you characterize them? And to be sure that from one patient to another, it's going to be the same, or at least not that different.
Yeah. We expect a lot of variance in the real-world environments. And we have 2 measuring stations from the Umweltbundesamt, so the Ministry for Environment in Hanover. And these 2 measuring stations define a traffic environment and not that polluted environment, let's say park environment. So one station is really in the park and the other one is close to a street where there's a lot of traffic. We would try to define or find these environments next to our institute. We could get close to the measuring stations and also integrate this data, but this is so far away from our institute. We have to transport subjects there first and see if we can, if we find similar environments close to our institute. We would not have this factor. Usually you have to think about the logistics of the study. Bringing subjects somewhere will extend the day for like 1 or 2 hours for the subjects, and this is also what we planned is probably 6 hours. And if you make a really long day for COPD subjects, there's a lot of exhaustion and yeah.
Okay, thank you.
Thank you for your presentation. It's nice to have results, preliminary results. From a practical point of view, and I'm talking for CF patients, you talk about some limits, and I think it is important to see that, as you said, with 8 COPD patient or 8 CF patient, it's what we can do right now, I guess. But we need to know that probably we will see some trends, if hopefully, but it's going to be really difficult to see significant difference. And for example, you show that 1 or 2 are going out of the. So it's not a problem, I guess. It's just that we need to say that. And in this matter, for example, for the primary objective, we need to put more feasibility or things like this, because otherwise it's just that we will not succeed in our study. It's just something practical. But
I get the problem, yeah. The sample size calculation is really hard if you don't know your effect size. I hope that maybe we will be able to estimate an effect size from the results we get from the biosensor for the ozone exposure in the healthy controls. That might be something we can use for sample size calculation after all. This is just a rule of thumb. So 15 might be practical for the healthy, where we can expect at least an effect for the environment. And for the 8 COPD subjects, if you start looking for effects there, you might not get one. Yeah.
And from a practical point of view, again, I think if you think about 4 days like this, with the patient walking around for 4 hours, is that what I understand? So you need to have somebody with them. I don't know. We thought about this and we say maybe like we have a person that is in charge of rehabilitation. That could be something interesting for him in the studios. I don't know, but it is feasible. But you need to find patient that will be happy to spend 4 days during in the wood and 4 days in the. It's not. It is feasible for a small number of patients, but it took time, and we need to talk about this. I don't know. I'm talking like from my experience, but I know I took the photo. I'm going back to the CRC. It's going to be a lot of talk to and I have another question, but the healthy. So you plan to take patients who are smoking, healthy patients, smokers and non-smokers, so it's going to be 4 groups? Is that correct?
We haven't really decided on the smoking status of the healthy subjects yet.
Because
I would propose to do something like behavioral questionnaire, where every cigarette smoked is marked, and then we have the time and point, and can see what the environmental sensor recognized during that time point. I know from other studies we did that the non-smoking COPD patients are sometimes hard to find, because usually they continue smoking. There are some, and you're also right about the logistics for a 4-day. This requires the subject to get some holiday and to participate in our study. We are hopeful that we find these subjects. Usually we have someone in the database which we can invite. We have seniors from the COPD side around 60 and also receiving their pension. They have free time, they're interested in studies, and there are some subjects we know we can invite for these studies. But you're totally right, it's quite a burden for the subject to have 4 days on 2 consecutive weeks.
And the objective for the LC subjects is to show that you may have some difference between COPD patients and LC patients regarding the levels, or is that correct?
Yeah, basically it is. We hope that by introducing more healthy patients, we can be more clear about the impact of the environmental exposure at all. If you want to compare COPD versus healthy, we would have to even out the sample size, but then the study would get bigger and bigger. We hope that 8 COPD subjects, which have like as confounding factors their disease, then the environmental exposure and also the variability we have from these environments, we hope that we see something. And if we don't get something from the exposome, from the real-world environmental exposure, we still hope that maybe the description of the everyday environment which a COPD subject, everyday exposome COPD subjects experiences, might shed some light into it. So we can look for differences in like what they are doing every day, differences especially for the environmental sensor, And then we can see, is there any impact if we send them to different environments?
Okay.
And you're totally right. We have to discuss the sample size, we have to discuss logistics for the study, and what we can do also with CF patients.
Thank you as well for your presentation. I had similar questions to those from Ralph. So regarding the sample size calculation, I think also it could be interesting and important to give it a try, even though you don't have a clear hypothesis on the effect sizes, just to check the magnitude of the effect size that you will be able to detect. I think it's important. Maybe it's something that will be asked by the committee, the ethics committee for the second part, maybe I don't know, but it's usually something expected, even if it's difficult. Second, regarding the crossover randomized trial, first, because it's randomized, I guess it should be maybe 16 healthy subjects, so that you can, an even number is more practical.
This was something I talked with my boss, and I said, let's make 16. No, it's 15.
Yes.
I don't think it will matter that much, but for evening out and have a 2-to-1 ratio, it might be nice again.
And I was thinking, because in randomized crossover studies like that, usually we are cautious regarding two kinds of effects. The first one is the carryover effect, where we introduce a washout period between the different sequences. For instance, between exposure 1 and 2, here you have several days, so I think it's no big deal. But I was thinking, is it, it's a naive question, is it relevant to think about the period just before week 1, just before week 2, to standardize things a little? I don't know whether the day 0 could be influential if the patient, I don't know, have some kind of activities on the beach or in the forest the day before. Could it be an influence on day 1, day 2 of each week? I don't know, it's a nice question.
It's a really nice idea. So we have to do something like an exposome washout period before we start a trial. Yeah, usually patients are that compliant that we can do something like this. So they should not just get back from the North Sea holiday or anything. They should maybe, like, let's say, have 2 weeks stayed in Hanover and do their everyday work or whatever, so that there's no big influence from an other environment than their everyday environment.
Yes.
Good idea, yes, thanks.
So relatedly, there is the time effect. The time effect is, it's difficult to explain like that, but over the year, would the different weeks will be balanced? I mean, the more we advance in the year, maybe we advance into winter or into summer, and we don't want that there is some kind of imbalance between the groups. So that, for instance, by a lack of luck, I don't know, the first sequence is always in summer and the second is predominantly in winter. Of course, it's a bias because it's not the same exposure. So. But it relates with what was being said on the logistics and think about how it will be done. Yeah.
The initial planning for the trial was to start this autumn. So let's say autumn is like October, November. And with more environmental sensors available, we will be able to measure in parallel. We have to see what we get from the discussion tomorrow, what we get from the sample size estimation, and then see if this is a possibility. But you're totally right, the seasonal impact is a big factor. So I would not want to have the study more than 3 months.
Okay. Thank you.
Yeah, I suggest that we just stop there because we're already 45 minutes late. So we're going to have the break right now, coffee break. Let's get back in 20 minutes. And Ariel, you can
ask your question privately to Julian. Thanks a lot.
I'm really looking forward to the discussion tomorrow, so if you have any ideas, just contribute.
Question for tonight. Just going down. Before we begin the air quality session, there's a question about whose is by foot, because we need to take cars to go to a fourth institute. So please, for those who are on foot, please go to Christina, and so that we can arrange the number of cars and to fit everybody inside cars. Okay, so before the end of the afternoon, have that said to Christina, and those of you who have room in their cars, please also tell that to Christina. Thanks.
So I would like to summarize some work that we have done during the last year linking particulate matter and health. These are kind of side projects to Remedia preparing for the exposure experiments, but they are also kind of relevant to other work packages in Remedia because there are a few surprises. So the first project actually had to do with work in the US, where there are the similar issues as we are facing in Remedia in Europe. There were few observations back in 1990 when it was dirty. There are more right now, both in urban and rural areas, but still it's a big country, so it is difficult to go from these to what actually people are breathing. And while in the US networks there is chemical composition, there is no information about sources. So this was our effort to link particle health effects to composition and sources. So the idea was to link the emissions through a model that actually resolves sources, as we heard in work package 2, get source resolved concentrations, then use the US census tract and a lot of data that they have to do epidemiological analysis for 20 years. We actually had more emission sources. We had on-road mobile emissions, non-road, biogenic, electric generation units, all the other industrial sources, and unfortunately sources like wildfires, restaurants, residential wood combustion were mapped into other. One of the advantages is that we could follow both primary and secondary material through the model. So these were kind of the predictions for how air quality was in the US. There is a big gradient that we try to take advantage of in the middle of the country. It's a lot dirtier in the east. And of course things got better during these 20 years. the model could give us for every year not only the total concentration, but could actually give us how much of it came from pollution outside the US. 20% was from outside, 11% from the electrical generation sector, 5% from industry, 5% from on-road transportation, 3% off-road, 5% biogenic, and other, which mainly is biomass burning. Some like 60-70% was responsible for half. So we could break the PM2.5, the organic aerosol, the sulfate into sources, and depending on what you were looking at, you would see, as I told you, that for organic aerosol, fires and residential burning were the biggest source. For things like sulfate, the yellow are the electrical generation units. We could evaluate with models, with the measurements, and of course no model is perfect. So this was, how well the model did for PM2.5. But the issue is that we could also evaluate the components, because the errors are due to the components. Organic aerosol was okay, but had its problems. Sulfate, these models can do better with sulfate than organics, so this was very good. So one thing that we did, and this was a neat idea, is that we actually combined the measurements in the few places with the model predictions and corrected for the bias using geographically weighted regression. I'm showing one component that the models don't do well. Right, this is our model, so that's nitrate. So the model was actually seriously over-predicting it. And after the correction, you can see to the right that the bias was removed. So these results now, sources, components, were used for the epidemiological study that was published in the end of the year, last year. The epidemiological work was done by Pope and Rich Burnett from Canada. They used a national cohort that the US is following with 170,000 people, and the end point was the cardiopulmonary mortality. So it was a lot more than COPD and CF that kind of Remedia is looking at. But there are some interesting results. I have just a summary here. This is the hazard ratio. There is the PM2.5. It gets 1.04, similar to what most other studies get. Now the interesting parts are first the components that, according to the study, are most toxic. The first one is elemental carbon. That's not a surprise. Most studies see that. The biggest surprise is the second one, which is the secondary organic aerosol. Actually, if you look on top of it, is the primary, the stuff that comes out from the engines, and this is even a little negatively related. Most of the secondary organic aerosol is products of reactions of gases coming out of cars, gases coming out of combustion, and actually gases coming out of trees, right? So it has all kind of the chemistry. For the sources, the one that was most associated was vehicles, but according to the model, 80% of the particulate matter from the vehicles was secondary. So this shows, and this is kind of the input for the work for the exposure, that if you believe this, of course, we need to have elemental carbon, but the major focus shouldn't be on the primary emissions, but on the secondary. This is what we are breathing, and this is what makes the work package 4 work kind of relevant and different from everything else. So one more thing that we have been doing is that trying to add another metric for the health effects of atmospheric particles. And this is the oxidative potential. So we have been using the DTT assay, which tries to simulate the rate with which the aerosol constituents deplete antioxidants. And thanks to the work of Thanos Nenes, we have built a system that does this work, which is quite time-consuming semi-automatically, so that we can analyze the samples. Now, thanks to Maria, which is here, we have been looking at how this chemistry changes the oxidative potential of particles coming from different sources. One of the sources that we looked is wood burning, and I have Maria's results for oxidative potential here to the right, and it more than doubles after a few hours of reactions. So this is consistent with epidemiological study that the particles that not only change, but the products of the reactions are, at least as far as the oxidative potential is concerned, a lot more toxic than the primary ones. A last thing is that a lot of this chemistry we thought that happens during daytime and mostly during the summer when we had photochemistry. And we discussed this with you last year, that we have seen now mechanisms and we can reproduce them in the chamber where these reactions can happen during the night and even during the winter. So this, if you want, chemical change of the particles for the worst is happening all the time, not only during sunny summer days. So this was, what we have learned from this, that what we are breathing can be quite different from what is emitted. Right now in Europe and the US, the more developed kind of continents, for fine particulate matter, 80% is secondary, only 20% is primary. So this happens during the whole year, not only during the summer, and that these chemical reactions appear to be making the particles that we are breathing more harmful. And the good news is that we think that we can successfully simulate these processes in the chambers, and this can be a big step forward for a media and the field. And the last but not least, that we can also use the oxidative potential as an additional potentially useful health metric. Questions?
Okay, thanks for the talk. I have a question. So here there is no inclusion of metals, transition metals, and we do transition metals, and we do know that they are associated to this oxidizing potential. And on the other hand, you are showing the effect of elemental carbon due to epidemiological study. Can you imagine that, for example, these metals from traffic are hidden in epidemiological studies in the black carbon or something like that?
This is an excellent point, right? That we know that black carbon can be, or elemental carbon can be a lot more. There are polycyclic hydrocarbons, aromatic hydrocarbons that come with it. There are also a lot of other kind of components as the metals that you said that are coming with it. So you're right. For the biomass burning that we looked at there are no heavy metals emitted if you just burn wood. But yeah, linking the metals and where they are hidden in the puzzle is a very, very good question, because they could be a low-hanging fruit if we can figure out what is going on. They didn't appear, we were hoping that they would appear in the electrical generation units in the US, right? Because from power plants, you burn the organics, but you get some heavy metals. But they didn't show up. So, but we agree that this is a significant question that so far, even in the chamber experiments, we are not ready to address. We are trying to do it with ambient measurements. We measure the metals and we try to link them to the oxidative potential. But this is something that we can think of, how to add, what type of source would we add to the chamber experiments for the metals.
Okay, thanks.
Thank you, Spiros. Question about the oxidative potential and how stable is it? Meaning, because in biological process, depending on which reactive oxygen species you're measuring, the stability is really not there. And so how do you deal with that, and how stable is it?
We have been experimenting with it, so we can analyze it right away, or we can freeze it and analyze it later. And I think, Maria, our conclusion is that if we deep freeze it, we are okay for a month.
Yeah.
But you need to freeze it after you correct it at -20 is our conclusion. So yeah, one needs to be careful, right? We transferred some samples from Athens to Patra. And, it changed by a factor of 3 because we didn't freeze them properly in the way. So one needs to be careful.
And how fast does it occur? I mean, this reaction?
It can occur in hours if you keep it, how can I say, in 20 degrees or 25 or 30. Of course, it probably depends on the organic components, etc., what you have in there. But yeah, one needs to be careful. So the plan for a media is, to collect them and either freeze them right away, or we can even think of analyzing them in situ.
Yeah, no, my question was about the formation of the oxidation of volatile organic compounds that forms via this secondary organic aerosol. How fast is the reaction, and how?
The reactions can happen in the atmosphere in the time scale of an hour.
Okay.
So they're quite fast.
Okay.
And in the chamber, they also happen in time scales of 20 minutes, 30 minutes, etc. So you can see the change rapidly.
So even by simulating an individual atmosphere, in 6 hours from now, the oxidative potential will be different, or?
That's what we see from our experiment so far, right? So the results that I showed is the same source, and going through the chamber, and in the one, it just goes through. And in the other, we turn the lights on as it goes through.
Okay.
And that's the change that you observe. So you can actually turn the lights on or off and see how it changes.
Okay, thanks a lot.
Thank you. Impressive study. This US study, I was wondering, what is the resolution of your exposure model?
The resolution of both the exposure module and the health data is the metropolitan statistical area. So we actually, the model has relatively coarse resolution, but the health data also have coarse resolution. Right, one of the challenges with resolution, as you know better than I, is that the people are moving. Right, you can have a model at resolution of 100 by 100 meters, but everybody's moving, right? You're not staying as a porch potato in your home. So for this, our kind of idea was to actually go against and use coarse resolution, and actually the statistics worked quite well. And you know, of course, right, that in the US, people live in one place in the suburbs, they work in the center of the city, they spend 1 hour each way on the road, so their exposure patterns can be quite complex compared to where they live. So that was kind of the decision. And that's the other interesting thing is that if you believe our result, that secondary pollutants are so important, actually resolution becomes less important because they have smaller gradients in space. Right? The primary can be a lot more next to the road compared to 200 meters away. The secondary, because chemistry needs an hour, spread out more.
Yes, I agree, but it could maybe be interesting to look at this with similar data, higher resolution, to see if your results could be reproduced in a population with low resolution
this is,
to see if the primary particles still...
This was a great idea, but we actually did it. So we published a paper where we did now the modeling with 1 by 1 kilometer. And actually the average exposure doesn't change. The distribution, as you realize, of exposures when you go to high resolution gets wider, but the average does not. So this kind of confirms that the average that we got was proper. But so yeah, there is value in the high resolution, right? Because there are citizens in the higher tail of exposure, and there are issues of environmental justice, etc. But this says that at least for the US situation, that one can do okay with lower resolution modeling for this.
Il y a encore une question? There's still a question. Sorry, thank you for your presentation. I don't know in which session is the best for this question, but because you're talking about the dispersion of secondary pollutants, I'm just wondering if we have an idea about the dispersion in the airway, in the tract, and the difference between people. So, for example, in a CF patient or BPCO or healthy people, I don't know if because we changed the atmospheric composition, if the dispersion of the particle would be also different for these people, and how we can assess this question. So this is not specific to your presentation, this is something that I have in mind. And,
Spiros, take
the major point that I tried to make is that we have all been thinking for a long time about pollution, that there is a source, it emits pollutants, concentrations are high near the source, and they drop as we go away. And what we're trying to add is the fact that there is a lot of chemistry happening at the same time. And if the chemistry is making things worse, in some ways it counteracts the effects of dispersion. that was the main point.
Thank you again, Spiros. So, because we are running out of time, I merge the two last presentations. The first is the status of the WP4, and the second one is like to put an open question in mind of everybody before tomorrow. So the WP4 is supported by the Lisa University of Paris team, INSERM with the team of Sophie, and FORCE with the team of Spiros. And our objective, the main objective of WP4 is to reproduce the health impact of the exposome in naive COPD or CF preclinical models. More specifically, the objective are to generate representative atmosphere at the laboratory, especially in terms of micropollutants. So basically, since the start of the project, we are, let's say, basically happy of what we have done, even if we are improving a little bit. I choose to focus on this first point during my tiny speech. Point 2 will be to implement more complex simulated external exposome with probably noise, physical activity. So this is, let's say, starting today. And 3 is to expose preclinical models to this atmosphere. We are basically happy also with the development we made since the start of the project, but I won't present anything today regarding that aspect. So of course, to simulate real air pollution episode for mice exposure is our task, and as you can see at Paris with support of INSERM team, we have a huge team working on it. The people that have their name in bold are present in the room. Whoopla, sorry, I make a mistake. Up. And I wanted to especially emphasize the role of Mathieu Cazono, that is there. Maybe Mathieu, you can show up. This is the lead engineer for the development of the platform. I will present, and it's a very impressive work he managed to do with his team since the start. So thank you, Mathieu, for that. So I won't make a course on air quality, especially in presence of Spiros, but because I want everybody to always remind what we are talking about. The main pollutants we have in the atmosphere are numerous, various, low concentrated, with gaseous pollutants at very low concentration, plus various aerosols from diverse origins. As you probably know it, primary pollutants are the compounds directly emitted into the atmosphere by anthropic activities. You know most of them, the carbon oxide, the nitrogen oxide, the VOC, the sulfur oxide, all particles, some metals we just were talking about. And in addition, we have secondary pollutants that are produced directly in the atmosphere that act as a chemical reactor with the sun as the major energy sources. And this is just an example of the type of cycle you can find in the atmosphere. This one is a very well-known one, producing ozone that is not emitted from anywhere but produced in some condition, for example, under the wind of polluted city when you have sun, hot temperature, and so on. So it's just to get what type of, let's say, challenge we have to face with simulating this in the lab. We are not mixing pollutants. We are trying to reproduce, for example, in this, in such an episode, for example, a summer anticyclonic situation. We have some pollutants emitted from in the atmosphere of the city that are reacting under the wind, maybe moving to rural areas where you have emission of VOCs, biogenic VOCs. In fact, COVB is French for. And due to this type of cycle, you have production of pollution with a maximum usually when you have the maximum of sun, let's say during the afternoon. So this is the type of phenomena where we have an episode of secondary pollution at the regional scale and with large spatial scale. So our task was first to reproduce this type of urban or peri-urban atmospheric episode for days at the laboratory and to expose marine models to this atmosphere. And I can say we succeed in two cases. Case we call Paris-like case and Beijing-like case. So to simulate Beijing at the laboratory, please remind that this inhabitant of Beijing were not wearing masks due to COVID, but it was prior to COVID due to phenomena like this ultrafine particles episode that occur, let's say, very frequently in some large megapoles. And they are due to the population, their activities, the traffic, also the industrial activities that are close where the people are living, and also impacted by, for example, the environment. Here, this is some view of the Gobi Desert, and sometimes you have desert storm coming from Gobi Desert, impacting Beijing. So this is a summary of what we have done with a central tool that is an atmospheric chamber of 4 cubic meters. But let's first focus to the left, where you have all the precursor we introduce in the reactor, in this huge reactor, to reproduce the chemistry that occurs in the real atmosphere. So, for example, we introduce, as you can see, VOCs in gaseous phase, also some inorganic salts. Here you have ammonium sulfate, also mineral dust particles with a specific device, and also soot, for example, another type of particles, by burning, in fact, propane with that device. So just to illustrate, this is one view of what happened in the laboratory with some of our colleagues, with this device, that is a device reproducing, in fact, what could happen in terms of dust rising in Gobi Desert. So this is a device that is used to shake mechanically the natural soil. Of course, we recover desert particle sand from the Gobi Desert, and we are able sometimes in the day to reproduce a desert storm coming from Gobi. And in this section, you see how we introduce inorganic salt in the system. Of course, in the middle, we reproduce the chemistry, let's say for approximately 4 hours, with some artificial irradiation that is activating the chemistry inside the reactor. We have the capabilities to predict and to understand also what we observe in the reaction chamber. For example, here, before the opening of the light, that means the source of the energy source, you can see, for example, here the increasing of nitrogen oxides that we are introducing. And at the moment you open the light, the chemistry occurs, and then the concentration of nitrogen oxide significantly drop because, of course, you have products that begins to be produced. And we can do that for tens of species. For example, here, the type of simulation regarding the PAN compound. From time to time during several days, the, let's say, evolved atmosphere flows through this exposure device where the mice are exposed into cage. We can expose close to 100 mice, at least 20 cages in this section. And of course, continuously they are exposed to, let's say, the same amount of pollution. This is, let's say, our ID with a control mice exposure device in parallel. And as you can see, let's say the final touch of this platform is the amazing capability of analyzing in live what occurs in the chamber and also in the two exposure device regarding the gas phase products, the particles present in these environments, and online and also offline because we are sample some of these aerosol on filters. So to illustrate this analytical section, just a tiny example of the survey we made with PTRMS. So at the start, nothing very exciting on the signal because you only have a blank plus water vapor. Then you inject your own mixture of VOCs that are, of course, choose due to their importance for Beijing case. So you see some signals. And when you turn on the energy, you turn on the lamp, then you see several signatures. Maybe you can see them because it's quite tiny. I emphasize that signals. And, of course, you can identify the type of compounds. In that case, you got in gaseous phase, as you can see with some process organic compounds. So a view of the platform from the top. So it is more like to, let's say, the impressive vision of the laboratory. More informative is the view from the front, where you can see the two exposure devices connected to the chamber. And in the front also, you can see, just to illustrate, the device that is only devoted to inject soot particles inside the chamber. So since the start of Remedia in February 2020, we are able to support 7 campaigns from October 2020 to, let's say, 10 days ago. You see here part of the insert team working here on an exposure device, and of course here with a safety, microbiological safety position to deal, let's say, with the mice and with the mice environments. So even if I'm not qualified to talk about this, an illustration of the, let's say, efficiency of this platform. So at the lab we simulate in 2021 specific episode of the spring 2017 in Beijing with, as you can see, let's say a mean high concentration of particles with a background of NO2 and SO2. These are, of course, only indicators. We are reproducing as possible all the complexity of the chemistry of Beijing atmosphere. So it was qualified as representative of Beijing during this summer. And here you have a survey of them at the pulmonary level for the control mice, the mice exposed to the simulated pollution of Beijing, in the case of wild-type mice and of mice that are of the CFTR branch, I mean models of vulnerable population with cystic fibrosis. And as you can see, when they are subject to a representative episode of the atmospheric pollution of Beijing, they present a more important quantity of this marker, contrary to the mice exposed to non-polluted atmosphere or of white type. Of course, this is only one indicator, and it is just an illustration of the numerous results that were obtained, especially on that type of mice in the different experiments. So, talking about future, the perspective in terms of experimental development, let's say on the short term, because October, November 2022 will come very fast. We will couple type of device from force that we may have the opportunity to visit by the end of the day, especially dealing with the biomass burning emission to our chamber to, let's say, have a more representative outdoor atmosphere capabilities for Remedia. At the same time, we were willing to add other component of the external exposome, and I think this is something we heard a lot this morning. We are talking probably about noise. And in another step, let's say maybe in 1 year from now, we'll add in vitro mechanistic studies with these instruments that will offer us capability of exposed cell in parallel to the marine models to the same simulated pollution episode. So I think for the first part, it is now open to question. Thank you for your attention. Okay, very clear. It's logical. We talk a lot about these developments.
I'm not sure how this...
Sorry, Alexander, you have to wait for Christina. It's German policy.
Yeah, for the atmospheric chamber, I wondered if it's not loud in that room or in the chamber already. So are you not having noise already for the mice you're investigating there?
You are talking because there are some background noise. You are talking about the noise on the platform already?
Exactly,
yeah. Yeah, so we have of course noise on the platform, especially because, for example, we have cryothermostats that are making some noise. Of course, the noise we measure with not highly precision because it was not made by scientific is, let's say, the environmental noise, when the noise that is important for us is the noise inside the exposure device where the mice are. In addition to this, we have also some question about the noise. That means, from what we not learned, but let's say heard, the mice adapt, let's say, better to a constant noise, whatever is the noise level. I imagine there is a threshold, than contrary to, let's say, variation of noise that are for them, for their organism, probably more impacting. So we are at constant noise, and we don't start any specific studies. Stefan is also one guy that gives some clues about the let's say the well-being of the mice, because he's in charge of the behavior studies regarding the mice. So we can say that only by eyes he can say that the mice is happy or not, or impacted by the noise. But this is the first clue. So apparently they are acting like usual mice. I mean, more active at night, very quiet at day, not aggressive between them, and so on. But of course, this is something that we have to qualify for the next step. Okay, then I switch. This was an excellent transition, Alexander. Thank you. To the focus on the perspective 2, to add other components of the external exposome to the mice exposure. So this is just preliminary open questions that we will discuss a lot tomorrow. In fact, what is noise, and for WP4, how to simulate noise for mice in our platform. As Etienne already says, this is not yet or poorly studied. So we discussed a little bit this in the frame of the WP2 status by Etienne this morning. We have the bibliographic review by Pascal, additional data and inputs very interesting from Mete, and tomorrow the plenary discussion of WP2, WP4 articulation, where I imagine we will focus in part on this point. I have to confess that only talking about air quality, let's say academics, our preliminary and I say and limited ID, was maybe to register crosswalk traffics and diffuse it to mice. Of course, this was before asking ourselves what are mice able to hear from that type of tape or whatever. So rapidly we understand that it is not a good approach, and that maybe a way to reproduce or simulate the noise and why not the socio-economic income is to implement stress to the mice. Because finally, this is what we saw this morning. The noise is, in terms of mechanistic, is stressing the mice or introducing maybe sleep disturbance or the type of problematic to the mice. So we have a lot of, not of question, of very, very preliminary question. If yes, what are the current and authorized stress to simulate? We are also talking finally of ethics. So we need some bibliography and especially experience from biologists to share. Do we have to make them vary? In other terms, do the mice adapt to stress? Okay, I put, I don't know, I don't think it's very ethic, but a cat in front of the mice, maybe she will be stressed, but after 2 days she will understand that the cat won't come. I have no idea of this. So is it relevant? So do we have to make a variety of stress? Do we have to reproduce at the same time exposure to noise, stress, and to atmospheric pollution? Or imagine we can address them in synergy or one after the other, and maybe the most open or let's say stupid question, are the stress that are already documented, are they some relative to primary noise and other to, let's say, socio-economic impact? This is a very open question. So this was just to put some points, and of course, if you have preliminary ideas or comments to address, don't hesitate, or we can, of course, do it deeper tomorrow during the different rendezvous we have already planned. Thank you.
Okay, I think that's better. I'll start with a really naive question from an epidemiologist who have never worked with animals. Is it possible to somehow insulate the cage so it won't get all the noise from all your machines, everything else that are in the chamber, so that we have a more silent environment for these mice?
Of course, I will say in principle, everything is possible. In fact, when we address problematics, we can find an option. I mean, basically, I can see two. First, we need to qualify, because there are some preliminary data, but we need to qualify what we are facing. I mean, intensity, decibel, and so on. And then the origin of the, let's say, noise that we want to remove, because we can, of course, isolate the exposure device or whatever, even if we have to develop something, but we can also isolate, for example, some machine, as you say, that are the one relative to the, let's say, bad sources that occur. I'm especially focusing on the cryothermostat that we have, that is for sure a noise producing machine. So in principle, yes. In principle, yes. But we need first to have a clear qualification and of what is the noise that the mice are facing. And I think on the Faculty of Science we belong to, we have some people in specialists of acoustic. So if we have some question to address, they will be the best. I think it won't be very complex for them to document this on a scientific way first.
Okay, because one of my noise colleagues, I think he's basically the only one who have done similar studies. So I could also establish contact with him. Thomas Mincel in Mainz. I know what he has done is basically he have looked on white noise as kind of in the control group and then tried different, because I think that could be interesting, trying different type of traffic noise, like road traffic noise, aircraft noise, which has this completely different intermittency. So at least I think we could maybe ask him for some assistance, because he already have experience in also doing both air pollution and noise exposure in mice.
Of course. Thank you. And of course, to add something, in fact, we are also facing two different approaches, and we don't know what is the best one, because we are not qualified with mice. This is to reduce the maximum all the noise they are facing, and on the other way is, do we have a way to diagnostic on the mice if she's stressed by the noise? I mean, like, I don't know, by dosing any biological component, because this is also a way to say, okay, with that background level, it's okay, the mice are not stressed. I don't know if this is something we can identify.
Okay, then we can move on to Ariel.
Thank you. Ah, tu l'as pas mis, c'est pour ça que je cherchais l'information. Non. Où est-ce que ça va ? Sur le côté là. Ok, merci. Et après, à mon avis, tu lèves la main pour que les jeunes t'aident, parce qu'après, c'est un peu... Merci.
Oh. Oh, pardon. Ah, across. Thank you, Spiros. No? Okay. Good afternoon, everybody. So let's move to WP5 and WP6. I will speed up because you are all tired. So to recap, WP5 objectives are to investigate the risk assessment of exposome-related lung disease with two specific objectives, using artificial intelligence models under the responsibility of Etienne, and to collect key exposome risk factors data for lung disease across the countries in the EU for constructing a synthetic risk indicator. So I will just spend 2 minutes to explain what does it mean, synthetic risk indicators. So this is a task of WP5. So so the 5.1 and 5.2 will start at month 36, so not yet, and task 5.3, the Pan-European Risk Assessment Analysis, has already started, and I will present to you some key features. So this is task 5.3. The work plan is to select relevant and existing cross-country exposome risk indicators. And indicators could be quantitative or qualitative, and to transform the quantitative variables in classes in order to be able to mix with quantitative, and construct a database and perform a multidimensional analysis. So this is the objective. This is a cockpit of plane in the 70s and the cockpit of plane now. You will see that if we see each indicator, each other, we have a very complex view of the environment. And so it's a reason why it's important to synthesize the information. So that, in order to synthesize the information, you know, in biology and in medicine, most of the case when we have a lot of criteria, it's very easy to just make an addition. We call that a score, and in every therapeutic area in medicine, we use score, and including also in pneumology. But when we calculate a score using an addition, we call that an additive score, we have an ordinal scale. Like the Eiffel Tower, you can see we have 3 floors, but the height of the floor are not the same. And methodologically, we don't have the right to calculate an average. We don't have the right to calculate a mean, but everybody calculates an average and everybody calculates a mean. When you use a clinical questionnaire calculating an ordinal score, most of the time everybody does an average, and this explains why it's not very differentiating. But we can calculate median, of course. Yes, this is just a bar chart we have constructed. I want to show you 1 minute because I'm sure it's the first time you have seen this bar chart. Imagine we have a score. This is an allergy score, RTSS. It's very easy. It's a score composed by 6 variables. We have 6 indicators, and each variable 4 answering modalities, 0, 1, 2, 3. So how many profiles we could have? 6 variables and 4 answering modalities. We can have 4 power 6 different profiles. So we can imagine 4,096 different combinations of these 6 variables and 4 answering modalities. And now, please look at the bar chart. You will see how many profiles we have to have the maximum range. So 18 is the maximum because we have 6 times 3. We have only 1 possibility to have 18 and only 1 possibility to have 0 because we need to respond 6 times 0 or 6 times 3. But can you see how many possibilities we can, how many combinations to have the score 9? We have 580 possibilities to have the score 9 or 546 possibilities to have either the score 8 or the score 10. That means that if we use a score, an additive score, at the end we mix a lot of things and we don't have any differentiation, and this explains why it's very difficult to interpret a score and of course to use a score as a primary endpoint in clinical trials. So this is the best case, what we call that a cardinal scale, not ordinal. We have a fixed 0 and every grade are the same. For example, in glycemia, blood pressure, a success rate is a percentage, morbidity, mortality is quantitative, and we can make addition, we can calculate mean, average, everything. Now, we have developed a methodology to turn around the problem of additive score. We have worked with the WHO to organize a risk assessment in yellow fever vaccination, where to vaccinate in priority in Africa. This is a map of the Burkina Faso. And if we use a score, we have the left map, and all the country is risky, except the desert in the north of Burkina Faso. But if we use a multidimensional analysis using mathematical projections, we can see that it's much more differentiating, and we were able to discriminate a very high-risk district versus very low-risk district. But using a simple additive score, it didn't work. So we have done that in 12 countries in Africa. We have published the methodology. Then the objective was to now to use the same approach for Remedia. This is another use case we have done with WHO about the H1N1 pandemic, and we concentrate 6 variables to represent the vulnerability of the country, and 5 variables to construct a synthetic indicator of the capacity to respond. And then we have 2 cardinal indicators, and we can represent all the countries in the world according to these 2 cardinal indicators. We can see here in pink the African countries which are very vulnerable and low capacity to respond, and in red, in the top left, European countries with a high capacity to respond and low vulnerability. So this is another example with 3 synthetic indicators. So how it works with our media in the frame of WP5, we use 2 databases, the Eurostat European database and the WHO database, the Global Health Observatory, to list 14 variables of pollutant. Also, this is after the analysis what is done. So we have a cardinal synthetic indicator of pollutant. And because it's cardinal, we can say that if we have 100, it's twice more polluted than 50, or if we have 90, it's 3 times more polluted than 30. So it's not a score, it's a projection, mathematical projection with a cardinal. So it's like a score, but you can better discriminate. And here we have the most important country, Malta. I think that it's because the fleet of the vessels, that it's the reason why Malta is very considered as to generate pollutant emissions. And Slovenia is a minimum. It was done with 14 variables together, okay? And then when we have this bar chart, we can use the quarter between 0 and 100 and design different maps in different color, and this was the objective of this task 5.3. What about ranking pollutant by surface? So it's that we have many countries in the few area, but Luxembourg it's a little bit more discriminant. So it's not a very nice map here. What about economic taxes variables? Economic tax against the pollutant, so total environmental tax, energy taxes, and transportation taxes, so economic variables. This is the bar chart, and this is the derived map. What about disease burden? Based on 11 variables of epidemiological data, and there is a much better variability from Netherlands to Latvia, and this is a corresponding map. So I won't spend time to interpret because I don't have a lot of interpretation to do that. What about the pollutant per population? And here the pollutant per surface. Okay, so what about the next steps of WP5 task 5.3? Just to try to pick up the most interesting maps and bar charts to draft a scientific manuscript. Of course, we will need all of you to present the background and to try to discuss a little bit the results, because I have no idea to why the data are this or are that. And I hope to be able to share a draft to everybody soon, and then you will be able to make addition and interpretations and discussion. And then, of course, we'll be happy to make any additional multi-criteria analysis as soon as we will be able to work with additional criteria or additional database derived from WP2 and WP4. This was from WP5. Do you have any question before switching to WP6? The cross
Yes, thank you, Ariel.
I switch here or not? No. What does it mean here? That?
I think it's for modification. Usually
okay.
it's,
Okay. Okay, looks like that.
okay, so we will have, I think, a working group session tomorrow, Ariel, and we'll discuss that. But the methodology that you present is interesting, and as you showed us, it's quite useful to provide synthetic and summaries of data at the country level. So I think it's interesting. As we previously discussed, indeed we need to discuss for each bar chart and each category of indicator a number of possibly caveats and pitfalls for the interpretation from the quality of the data at the start. So just to check with you, where does it come from? Are there some gaps in the data collection? And to explain, for instance, some outliers, because we could see rapidly that some countries, in some cases, has a zero indicator. So what does it mean? Because I guess it's because there is some gaps in the data. Just to check that. After that, regarding the nature of the data, so I'm no expert, but my understanding is that between emissions and concentrations, there are some questions to ask, to check what kind of data you used. For the method by itself, I guess you used PCA, principal component analysis, to merge the different indicators.
Yes, we have used the multidimensional analysis like PCA, but we project in one axis instead of projected in two axes, and then we find the most relevant axis. Yes.
Okay. So I was wondering, but again, it's an open question that we can discuss tomorrow. Whether some techniques, like for instance, it's another variety of factorial analysis. It's called multiple factor analysis. It resembles the PCA, but one key advantage is that we can define groups of variables before conducting the analysis. That way, all the different variables don't have the same weight, because when we have some kind of catalog like that of a variety of pollutants, of course some of the pollutants are highly correlated and they count higher in the analysis. Their weight is way higher. So in a way to provide a more balanced analysis, multiple factor analysis is very useful, and it's just an extension of PCA.
Yes, definitely. Well, it's particularly relevant when we have both quantitative and qualitative, yes, because we can group the quantitative in classes, and yes, definitely. We can discuss about that. Have you some experience about that?
Yes, it's the same kinds of packages in R, actually. So
okay.
Okay, so we'll discuss that tomorrow.
Yes.
Thank you.
Thank you, Etienne. We switch to, yeah.
So, yeah, just following the intervention, the first intervention. So, what is the origin of the data for the pollutants? Because I don't think it was written on the...
Yes, it was Eurostat. And
for the pollutants also?
Yes.
Okay.
Yeah. Eurostat. So let's move to WP6. So WP6 focus on economic assessment with the main objective to carry out economic assessment of the relation between exposome and the course of COPD or CF So WP5, we focus on risk, but we don't make the link. Here, we try to make the link using many sets of criteria, including economic criteria, but not only. And the specific objective is to use the econometric modeling approach, because it was in the call. There is a term econometric, so we propose to do an econometric model, and also to evaluate the cost effectiveness of relevant preventive strategies. When we will have a good idea of the risk, we could imagine some public measures, and if we imagine some efficient public measure, we can design a cost effectiveness of this measure versus nothing or versus alternative measures. So task 6.1 is ongoing about the development of the econometric model. We used the same database as the WP5, so Eurostat, and also the WHO statistical data. And 6.2 about the ethics and legal will start at month 25. And 6.3, cost effectiveness simulation model, we start at month 30 because we need to discuss all together what will be relevant public health measures to protect people against respiratory exposome, and then we'll be able to perform cost effectiveness simulation models. So very quickly, because I have tons of tables, but just to show you the overall concept. So what about COPD mortality and pollutant using this database? Yes. So we use Eurostat here, and for CF we use the annual report of the European registry of CF, and when we read the annual report, we pick up the prevalence of CF across countries and over time. So this is a set of epidemiological variables we used, the set of pollutant variables, the set of ecological variables for the environment, and the 4 economic variables. And then we analyze we have a lot of analysis, because imagine all these variables over time, over each country in the Europe. So we generate a lot of noise. I will show you some tables and some way of potential clarification. So here, if we try to link time, to make a correlation with time and the taxation of transport, just an example. So we can see that we can have a negative correlation in the top right. We can have a positive correlation, and then here you have the list of all the countries with a negative correlation, for example in Malta. So that means that if the taxation if the time increase, the taxation decrease. And for example, the positive correlation in Italy, if the taxation if the time increase, so over time, the taxation increase. So they tax more and more, and in Malta, they tax less and less. Here, what about with PM 2.5? We have a set of countries with negative correlation over time, most of the countries. So that means that over time, many countries reduce the emissions, so Netherlands, Finland, Sweden, Austria, but some countries, the white one are not significant, but some countries are negative, so Czech Republic, Poland, Denmark, Estonia, but it's not you have the correlation here. What about the correlation of the mortality of COPD over time? Then, for example, we have a negative and a positive correlation, the same, high or low correlation. And for example, in Lithuania, the mortality decrease over time significantly with a significant correlation. And in Croatia, the COPD increase over time. Of course, I don't have any interpretation. I don't know what is the situation in Croatia. And we can say, you will see that in Cyprus, for example, it decreased over time and then it increased. Something happened around 2009, 2010. It could be a problem of data collection. It could be anything, but it's not the only country with that. This is all the country that you see a significant decrease of COPD over time. Then it increased again about 2009, 2010, in Austria, Portugal, Italy, Slovenia, Denmark, Netherlands, Malta. So I don't know what happened about COPD mortality here. Maybe it's a problem of data, but I don't have the ability to assess the quality of the data, but it's official data from the European Commission. Yes, if we want to represent in the same slide a decrease of tax transport over time, a decrease of PM 2.5 over time, we can see that in Austria, the COPD decreased up to 2009, 2010, and then increased. And the same phenomena in Romania, same in Italy, same in Bulgaria. It's just some results pick up because we'll need many weeks to present all the graphs. Here in Belgium, so in Belgium it decreased over time without the break of increase again. In Lithuania it decreased over time. Okay, now another approach. We try to link, to use the econometric formula, the econometric model, but in order to be able to perform the econometric model, we need to test 1 by 1 and 2 by 2, after that 3 by 3. So now we are in the process to compare and to find the link 2 by 2 and to find the link between the pollutant and COPD. This is a formula of an econometric model. It's a classical linear relation, but in econometric we use a random variable, epsilon, and we calculate the random variable, and it's not a current practice in a linear model outside econometric model. So if we have a positive correlation, that means that lower emissions, lower mortality, and a negative correlation, that means higher emissions, higher mortality. We use only emissions because it's quite impossible to use concentration by country, because concentrations are based by spot, and it's difficult to link a country with a spot. Some countries have maybe one base and some other have several bases. So emissions, the data are provided by country, but not concentration. So we don't, unless we find a way to use concentration in the model, I don't have any idea how we could link concentrations and the countries. And then we have tons of tables like that. You can see in green the countries with a positive correlation, and very significant and positive correlation. Positive means that the COPD decrease, let's see, yes, positive. No, lower emission, yes, lower COPD with ammoniac. On the right is with the volatile organic. Here's a PM 2.5, PM10, cadmium, mercury. The black we don't have data, so it's not possible to make calculations. And you can see here the table for pollutant by pollutant, and each we calculate the coefficient A of the model, the coefficient of correlation, the t-test to see if the first coefficient is significantly different of 0, and the p-value, the selenium, the zinc. Okay. So now, what about in cystic fibrosis? So in cystic fibrosis, we have been able to collect the the data from the annual report of the European scientific, the European registry, thanks to recommendation of Ralph. Then we use here the list of the pollutant and the list of the EU country we had the data. And then the same kind of model, econometric linear model, so we try to find the coefficient of a relation linking the prevalence of cystic fibrosis with the emission plus the random number, the epsilon. And here we have, after a lot and a lot and a lot of calculations, we find a way to avoid the noise of the time series analysis. We use the years not in the frame of time series, we use the years as an individual. That means that each year is considered here as independent of the year before and the year after. And that avoids a lot of noise, and we will see, I think, a much better, much clearer results. So here we can see that in yellow, that means that we have a negative correlation. That means that the prevalence decrease when the, see, here, see prevalence yes, there's a prevalence decrease when the pollution increase for ammoniac, for volatile organic, for PM 2.5, PM 10, cadmium, mercury, arsenic, chromium, copper, nickel. And then what will be the next steps of 6.1? First, of course, to look carefully on the data and to discuss with specialists like some of you in the consortium, because we use the public data as it was, without any criticism about the quality of the data or what it means exactly. For example, in the Eurostat data about COPD, and also in WHO data, we have, for COPD, we have the group by age, and we see a significant group of children. But Rolf say that COPD, usually, it's not a children disease. But we have children in the COPD group in the statistics. So I don't know how to interpret that. And maybe we need to find another way or another database, or at least an explanation of this data. And of course, the future of this task will be to use criteria and data, maybe much more validated if we can derive from WP2 and WP4. Thank you. No comments? Patrice?
Yeah, thank you, Ariel. I've got a question that we may have to collectively answer or look into, is what happened in 2010? Because for every single analysis you show us, there's something happening in 2010, which is not, I believe there's some mistake or whatever, weird thing happening that we haven't looked into yet. But this is, I guess, the first thing to do is to really check the quality of the initial data you're playing with, because there's really something weird and which has to be checked. I mean, collectively.
Definitely. Yeah.
Perfect.
Which one?
Back up first, before the slide with Belgium and the curves that increase very fast in the middle of the talk. I don't remember the numbers, there was a lot.
So, this one?
Okay, some slide. Yes, it's this will be for a very, again, very naive question. Not candid, but naive. Stop! Yeah. For example, when you say to the left, so it's very naive, Ariel, no trend. You see, for me, if I look to the bottom left versus the bottom right, for example, if I exclude, let's say, the 3 first points, I can see with my eyes that are probably old and tired, some trend of decreasing. So what is the principle that say on the left you have no trend and on the right you have a trend? This is my naive question.
It's the significance of the correlation. Just the p-value of the correlation.
All right. Okay, I was expecting a little bit more of pedagogy, but we will discuss this later on. This is only statistic, but not...
Yes, this is a statistical interpretation.
All right.
Yeah.
So this is the issue. Alexander?
My question is, did you always assume a linear correlation? Like if you are looking at the trends and you're always drawing a line like it's a linear correlation. Because can you go 2 or 3 slides to the front? I mean, not or to the back, more to the end.
Here?
One more? Yeah. Because there it looks as if the COPD mortality corresponds quite well, for example, with the transport GDP.
Mm-hmm. But
the lines don't show.
Yes, this is a very bad linear relation, of course. So, and in econometric, the econometric modeling are based on linear, but we find it's not a simple linear. It's a multi-factor linear. But in order to construct the modeling, we need to construct 2 by 2. But it's based on linear. It's a good linear or a bad linear. But of course, if we want to focus in statistics, and we can use a lot of other correlation or other relations. But it's not the fixed purpose of the econometric modeling.
Yes, I think it brings us to the limitations of an all-statistic approach. And I think there are some maybe hypotheses like a linear relationship between occurrence of a genetic disease versus emissions that happen to most of the time be after pregnancy. So I think there is something to look in the consistency of the selected data in order for us to check that there is no place that has not been investigated in the field of parameters. I think there are some parameters that need to be checked, and maybe there are other parameters that are overrepresented. And maybe there is something to think in the first case of the linear regression or the correlation, at least, because as for me, there is no reason that everything is linear, and there is no reason that parameter A will be related to parameter B, as we have hundreds of parameters that maybe. So we need to discuss that, because I think it's interesting, and I think also in those data there has been some interpolation. So in the COPD mortality. So the angle in the time dependency is due to the fact that we miss data and they have been interpolated. So we miss the annual variability, the real annual variability. So maybe everything has to be explored.
Do you mean that some data has been projected and not observed during the year?
I saw in your report that you had some mortality data with gaps, and so you plotted the interpolated in between.
In between, so, because a relation, but in between, of course, by definition.
No,
but we don't project we don't put it
no,
beyond.
sorry, no extrapolation, but interpolation inside between 2000 and 2010.
Yes.
So there may be a trend in between that we don't see because it's interpolated. And the angle Sophie was talking about is due to the fact that we have a data for 2000, we have a data for 2010, and then we have a data for 2015. So there is an angle indeed, but in reality, maybe it is even less smooth. So
yes, maybe. Yeah.
I'm sure it is.
Yeah. Thank you for your comment.
So maybe to answer this, because maybe in France also it's like this. It's this vehicle also, or in France, or because in French we have a French registry called CPDC in some, and I don't know if you cross this European data with CPDC and how if it's the same kind of trend you observe also.
So do you suggest that the French registry feed the European database?
No, if they have the same number, if they have the same for checking the data, if it's the same data from the European or same from CPDT, which is a registry for all mortality in all causes in France.
So that means that the European data come from the.
I don't know about that. I'm just asking.
I no idea. No. Yes.
What I'm wondering is in the COPD data, you have a big bias. That is the number of smokers. Did you account for this bias?
Yes, we have the smokers in. We have the smokers somewhere, yeah. But it's diluted with the. I think.
I was thinking about the modeling.
Yes.
These figures where you show, let's say, the correlations and where you set up your models, are you intending to subtract this bias from the smokers? Because, I don't know how you could include this bias into your model.
So for the econometric model, we use at the moment parameter by parameter. So we don't test and include the smokers, whatever. But for the risk analysis in WP5, the smoker was one of the risk factors included. One of the risk factors. If we have good reason to say that it's not relevant, we just kill this criteria and that's it. For WP5. But for WP6, we didn't include yet.
Yeah, but I guess what Gerard is saying is that the smoking status of the COPD patient will influence its mortality or morbidity. So it has not only to be not only to be an external factor, but also an internal variable of what we're looking at just in terms of COPD patients. Is it a smoking, actual smoker, or is it not? Independently of the influence of cigarette smoking as a risk factor, see? Because it will influence the mortality and the current morbidity.
Yeah, it would have been interesting, but the problem is we don't have the information by individuals about COPD, not COPD, and smoker, not smoker. We have statistics about smokers in a country and statistics about COPD. And we have no idea to know by individual, is this one is smoker or not smoker. For that, we need data of registry directly.
Sorry for the naive question, I guess, but I'm wondering if the Eurostat bank that you're presenting a statistic on Do you know how they collected the information? I guess, I mean, if there is a clinician that gives the information to the European consortium, let's say, or if it's an independent way to collect the data and something that you know about how they collect statistic, in fact?
No, I don't know exactly for this data, but I know that usually data collected by international organizations or the European Commission are fed by data from the country. So the country sends the data, so I imagine the Ministry of Health of each country send the data, and the European just aggregate the data. And sometimes for economical data, there is a lot of political bias. For example, in Africa, the Gabon, I work in Gabon as an epidemic doctor a long time ago. In some African countries are very rich in terms of resources, but when they send their number of population, they increase their population in order to have more money in return, because the GDP per capita define the level of help, of aid to different countries. So the country can decide which data they send to international organizations, and by definition the international organization doesn't have the right to criticize the data, because every country is responsible of the data. So we know that in international organizations we have false data without the possibility to ask again the country, because the country has the full responsibility with political bias sometimes. So we need to do with. This is the first attempt to use public data. Of course, the quality of the data should be discussed, but should we have the chance to work directly with data registry or any database, that would be great. But to compare across countries, we have no way out to use international databases. But it could be a good way also to criticize the database from international, if we have good argument to do that.
Thank you.
Okay. Thank you very much.
So I'm doing only WP7, and the workshop about advocacy will be for tomorrow morning, because I think that we are all tired. So the main objective of W+7 is to organize a well-targeted dissemination effort to ensure a maximum impact of the project and release the full exploitation potential of our results. So in this second period, we achieve the dissemination of Remedia video. We set up communication tools like LinkedIn, YouTube, the business card. We increase the current number of Twitter, LinkedIn followers. We promote interaction with the communication manager of Remedia partners like Caduceo, Lipotype. And we collaborate and we share tools. We promote interaction with the others, communication manager of EN, and we work on allocation of a part of CGX per budget for communication advocacy. So for the first task,
We have that the website and the Remedia calendar have been regularly updated. 3 news were published during this period about the EN newsletter, the video, and the WP2 meeting in Paris. And we had the article published in the results section. Twitter account, we have managed to obtain a community of 200 followers. There are mainly academics, but also other European projects, network, and environmental association. We are tweeting according to the Remedia communication plan. Tweet about conference, webinars, partners, EN project activities. The Remedia LinkedIn account and YouTube account was launched. LinkedIn account is regularly updated, 2 posts per week. Our first profile paper has been published. It was a joint effort with the other 9 EN members. We have the short communication video on Remedia. The video is available on the website, LinkedIn, YouTube, and on the page of partners. During this period, we prepare also some communication materials about Remedia project. We will be giving everyone a Remedia business card. The idea is to give out to the contacts you meet and that could be interested in Remedia. And there is you will see there is a QR code that links to the website. It will be a good way to raise awareness about the project. And we have done the roll-ups. The idea is to use for Congress, to rent a modular stand and use it in this occasion. A newsletter has been sent in October, and Sophie presented Remedia and the concept of the exposome at this symposium. So these are some examples of what we did. For the task 2, so different target group for recommendation has been identified. A common policy strategy has been submitted by Remedia F4 and EDIMED to European Commission. It's a joint deliverable from EN. And the workshop on advocacy will be tomorrow. And we had feedback from an EC officer about the common policy strategy, and they want to see further development of this document. We already had a meeting with the F4 and EDIMED, and at the end of the month, of March, we will meet the EC officer. So, what is the development? And they don't seem to have a clear idea of how they are going to target politicians and society in general. They criticize the fact that we were not communicating more, including on partial results. The budget for communication dissemination is actually not so high, and the other projects have a more substantial budget. And the other point is that the awareness of exposome is still very low in France and in Europe. So what we are trying to achieve is to make an impact by providing new evidence for better preventive policy. What we want is to reach different audiences, other scientists, policymakers, patient group, and the most powerful lever to have an impact with our activities and a result is communication and advocacy. We know that the relationship between evidence and policy is complex, is not linear, and the more we communicate, the more we will bring people on board. But it's important to have professional assistance, resources, and a strategy. So what do we need is expert assistance on communication activities, so improving the current communication strategy, assisting in structuring the daily communication activities, in particular help translating scientific finding into communication messages. And then have an expert assistance on policy-related activities, defining a strategy and implementation plan, so identify relevant policymakers, stakeholders, develop a network of policymakers, and we will do 3 specific policy-focused workshops to build network and disseminate policy messages. And third, we need some specific communication policy tools and activities that could include communication tools like updating or expanding the current video, imagery, infographics, update of the website that cannot be done by the project manager team. And like I said before, institutional presence at events and seminars. And finally, policy recommendation. What we will gain with this extra budget, the impact and the visibility of the Vulture Media project will be substantially enhanced. This will benefit all partners with direct and indirect positive effects on their activities, and this will maximize the impact of all work packages by the more effective circulation of the results and activities of each work packages. So in order to anticipate, we discuss with different communication agencies. We focus on 4 that had more or less advantages, and we think that the best choice could be Beta Technology. They are currently leading communication dissemination work package for Longitools. That is another EN project, and they are experts in communication and also in policy and in stakeholder research. For task 3, an online presentation on basic EP knowledge was organized. There is not protectable results yet obtained. For task 4, expected key result have been identified, and there's been identification of contact at partner for the Innovation Management Board. So the decision to be taken the next 3 months, we would like to rent a modular stand during ERS International Congress in September, to use the roll-ups. We will have a computer showing the video and the PowerPoint presentation, and the consortium member will welcome the participants. We will do a newsletter after the consortium meeting, and it would be great if we could have for each consortium partner a communication dissemination point person to promote social activity by sharing information and to promote communication activities. So we organize different meetings, for example, with Better Technology, Consortium Communication Manager. They provide advice on potential communication activities. As I say, a meeting to come is with the EC officer about the deliverable on science to policy. And the objective for period 2 is after the General Assembly vote, if the budget will be allocated to, a part of the budget will allocated to WP7, we would like to do a subcontract with the Better Technology. We would like to finalize the stakeholder mapping, identify current hurdles to dedicated prevention programs, monitor current development, legislation relevant to Remedia, collaborate with other French members of the EN, update the communication dissemination plan, and do an external newsletter.
Do you have any questions for WP7? When Marion was here, we initiated all the French EHN partners meeting. And where is it? We have to.
The idea is to start again.
It's buried with all the other meetings. But actually, Manon left in May, where we began to do this franchise meeting. To explain to the others, we decided, as we were quite a lot of French partners in the 9 different projects from the EN, we decided to have a Franco-French discussions to facilitate the dialogue and to have a crossover discussion. That's the 10th time, I guess. So yeah, we were willing to discuss across the different projects in French for easiness. That was good at some point, except that Manu left and Roberta arrived only, if I can say, in September. So, and we didn't put forward to do it, but yeah, it could be interesting to set that again. But Roberta and I would like to thank her really much for all the work she's done since September. She took great part of the project now, and so this is really good effort because she had the difficulty to arrive, to be new in a project which was ongoing for 1.5 years. And then that was easier because the project has already a past life, but it was really hard because the project has already a past life. So thanks a lot, really. And so yes, the French discussions will come again, hopefully. Is there any other questions? No? Well, is anybody, so now we're going to go to a 4th. Is anybody missing a car, a spot in a car? Who needs a ride? 1, 2, 3. Gerard, that's okay? No, 4, 5? Okay. And so who's got space? Let's do some mathematics.
I have space.
You've got space, okay? There's one here 3, I guess, with you, Spiros, or just 2?
Yeah, I can take 4.
Oh, okay.
But not big ones.
On the roof, okay. Okay, so make sure. Ariel, you've got space too? Okay, so you've seen who is available for a ride. Maybe you can go with Spiros, so that's okay. And so Maran can go with Ariel, Maran Gerard, you can go with Ariel. And I guess, and Julian, you're by foot too? Ah, okay. Okay, so that's fine. Oh yes, and tomorrow morning, because we are late right now, we're gonna begin at 8:30 instead of 9. Yes, sorry, Camilo.
Before you leave, a couple of driving instructions, just in case. We are down here, 4th is up there, so the easiest way to go is to take the road that is in front of the conference center. This goes in front of the hospital, but then it's kind of a small mess. If you put 4th in your GPS, it will get you there. It is up here. There are several buildings. Let me kind of go in there. Please go to this white building, which is the first that you will see to your right. There are 2 parking lots, no matter where you go, but it will be fine. But please notice, don't park on the road. You will see that the road going up there, this is quite narrow, so, and please go to the roof of the building, and we will meet there. We will take a few of you to see the labs, and you can enjoy the view. So the dinner will be on the roof of this first building, which is kind of the conference center of 4th. There are 3 or 4 more buildings that are laboratories.
Actually, I think the dinner will be downstairs.
Sorry?
Marie just sent me a photo, and I think it's downstairs.
No, it is on the roof, but
it's
inside.
Inside, okay.
So,
Looked like downstairs.
no. It is upstairs, and the view is still nice.
So it's like a terrace then?
Yeah. Yeah, and I forgot, Sophie was there, but you have not.